The first version of IntelliJ IDEA was released in January 2001. 20 years later, IntelliJ IDEA is loved and used by more than 4 million developers from around the world. Today at JetBrains, we want to thank you all, our amazing users. 20 years is a big milestone, and it would not have been possible without your love and support. Today, we are excited to host the first ever IntelliJ IDEA conference to celebrate this birthday. Happy birthday, IntelliJ IDEA. Hi, everyone. I'm your host, Mala Gupta.
Hello, I'm your host, Trisha G. Happy birthday, IntelliJ IDEA. We'll also be joined later today by two more hosts, Helen and Dalia, so the whole of the Java advocacy team will be here to be your hosts. IntelliJ IDEA is a 2-day free virtual event. This is a peek inside JetBrains. You'll hear from the creators and developers of IntelliJ IDEA all about its incredible features and how to use them. You'll get inside information on the evolution of IntelliJ IDEA, and you'll learn tips and best practices. Before we go over some housekeeping details with you, I want to share this video with you where some developers talk about what they love about IntelliJ IDEA.
I like everything about IntelliJ IDEA.
More confident making changes, and also I can be more focused.
I really think that IntelliJ does a really great job with code completion.
Blown away by the productivity that I was gaining.
It simply works.
It just makes everything really easy.
And it's really cool because then, bam, it worked.
Super nice and very well configured while using the keyboard shortcuts.
It's fast and it really understands my code.
There's practically no other software I use that feels as nice.
That makes my developer life easy.
Feels like a Swiss Army knife.
So it's convenient for refactoring, for auto-completion, for importing, for a lot of stuff.
Stays up to date with the current trends in Java.
The IntelliJ Live templates are just like, they're like one of my true loves.
Little did I know back then that this was going to change my entire development experience.
It's a tool I use every day and that I enjoy using.
And you are confident enough that you can jump into anything and you can do it quickly.
It has really helped me become a happier and more productive developer and teacher.
It's mind-boggling how ahead of the curve this IDE is.
That was it was kind of a game changer for me because it was like, wow, this is so cool. I don't have to do all this work.
Happy birthday, IntelliJ IDEA. Happy 20th birthday. It's been a really fun 20 years. Looking forward to the next 20.
I love that video. Now let me share some quick housekeeping details with you before we start with the first session. The duration of the event today and tomorrow is 7 hours. So we have 7 sessions on each day and each session is 1 hour long.
And we don't have any breaks between the sessions. Why is that?
All the sessions are live with the keynote, which is pre-recorded.
We'll record the sessions and they'll be uploaded to our YouTube channel later. So if you haven't already subscribed to our channel, please do so that you don't miss any of the sessions that you want to see.
And when a speaker is presenting their session, please use the YouTube chat to ask the questions. Our host and chat moderators from JetBrains would answer all your questions and will also ask as many questions as possible to the speakers.
Please use the hashtags IJ20BD. I'm not going to read these out. These are hashtags. You can see at the bottom. Use the hashtags to share stuff on social media and obviously, preferably to say how amazing this session is.
Now, it's time for the keynote with Valentin and Max, 20 years of IntelliJ IDEA. Valentin is one of the 3 founders of IntelliJ IDEA, and Max is CEO at JetBrains. We talked with them about why they started working with IntelliJ IDEA, the challenges in their journeys, achievements, their love for coding, and much more. And it was absolutely a pleasure to see how their eyes would just light up while talking about their journeys.
While you're watching, we really want to hear from you. Please say stuff in the chat. Things like tell us your favorite moments with IntelliJ IDEA, when you started using it, why you started using it, why you're still using it. We really would love to share some of your stories at the end after the keynote.
So time to walk down the memory lane with Valentin and Max, 20 years of IntelliJ IDEA. How do you feel reaching this milestone, 20th anniversary of IntelliJ IDEA?
Well, it's a huge term. It's like half of my life. And yeah, that's a great milestone. To be honest, when the whole thing was started, I was not thinking in such long terms, like only about what would be great to achieve in the nearest time, not in 20 years.
Could you have imagined when you were working on IntelliJ IDEA in 2001 that it would become such a popular IDE and that it would be used by developers from all over the world?
Well, short answer is no. I was very skeptical. And then I remember then they offered me a job and we tried to kind of talk about my compensation. And my idea was, no, you cannot afford to pay me this money because you have to solve this many a month, I said. And they were laughing. I mean, of course, they were selling much more, but I was really skeptical about that because it turns out, yeah, it's a great product, but it's really hard to convince the whole world to use it. But I was proved wrong, and I'm really happy about that.
I never thought about like being so popular, and no, it wasn't in my mind. I just wanted people to use, and it'd be some substantial amount of people.
How did it start, and why did you start working with IntelliJ IDEA?
At the time when it started, we are 3 founders. We all were programming in Java, and the tool which was the best on the market, and yeah, we all used it, was GBuilder from Borond. But we couldn't understand why it's the best tool, but it can't literally do anything with the code. Just it's like a plain text editor with a little bit of improvement, like you have some basic code completion, a little bit of syntax highlighting, and that's it. Why can't I do very simple things like find where this function is used in my code, or change its name everywhere, and many other things? So and we understood that it's possible because the computers are quite powerful, and we could do all this and parse all the code and find all references like what the compiler does, but just not to compile the code. And we had many ideas like that. We started to discuss it with each other, and yeah, we realized that we could do it and make a much greater product. So that's how we decided to found a company and do this.
You were among the very first developers who joined the IntelliJ IDEA team in 2001. Can you tell us a bit more about how it all started for you?
The founders and the guys that had joined the team before me was so fast that when I came to the team, it felt for me like product is already done and there isn't much to do because it's already functional, the whole IDE. I was impressed beyond any imagination. It did have a thing called refactoring, which I didn't knew at that time. So you could extract method, and the guys were so patient at showing to me, look how it works, you can do this, and they transformed the code. You know, it was so impressive at that time. I had my job that was well paid for we were outsourcing company for some American firm doing a translator that was translated from some internal language to multiple other languages for multiple deployments. And specifically, I worked at the time on a compiler backend, which translated to COBOL, Java, and also C. So I was... Yeah, so by chance we had a common colleague called Anya Reshnikova. So she came to me and said that, look, I know the guys who are doing impressive things. Would you like to talk to them? And we did. And first, I didn't believe that this is serious. And, you know, I have my job. This is some kind of startup without any bright future, because what can you do? But the task was so interesting that I agreed that I will work for them part-time. So I said that, okay, so I will work for you like a day a week. And my initial task was code inspections. And I started implementing an inspection called data flow analysis. And I've read a couple scientific papers on how to implement this. And it was so cool. I mean, the task was so rewarding. It was such a beautiful piece of a task. And the results was so impressive that, in fact, I not only I didn't work for them part-time, I was full-time, somehow managing to do my daytime job. Yeah, and the weekends and the nights, of course. And after like 6 months, I believe, of doing so, I said, yeah, this finally has to end, because I'm cheating on my other employer. It should stop. And I joined the team 6 months later. Since then, I actually made a lot of things. Code inspection turned out to be not just one inspection, but the whole bunch of analysis. And then there was a bright idea that analysis not only has to run when you require them, but they have to run on the fly, and it gives you another level of code quality if developers can find out what's wrong with their code immediately as they try them, and have time and context to understand what's going wrong and fix. And then I also work on an editor subsystem, implemented code folding, many other stuff. We decided that Java IDE is not enough, and we need to support other languages and other frameworks. And at that time, we actually support, in a kind of hacky way, XML, JSP, stuff like that. So I took a bullet and refactored all the code to implement the language API and unified parsing engine. So that turns out that's kind of make all the other IDEs possible in the future. First, first kind of demo language plugin was JavaScript support. It wasn't really popular at that time, but then it turns out that it was the right choice. And also Dima Zhemirov implemented Python support on top of that.
So how did it go?
Well, we were just writing code. I wouldn't say it was much things unexpected in terms of programming. It was more challenging how to market it, how to bring it to people. And because we did not have any experience with that, like selling our product to worldwide auditory ourselves. So that's why we decided to make kind of intermediate stop. Like we had already enough code to do some simple things like find references to some declaration or rename declaration, move it to another package. And we decided that of that functionality we can pack it into a simpler product. We called it Renamer. We did not expect it to have a tremendous success, of course, because the functionality was very limited. But for us it was very important to try it, how to sell it.
IntelliJ IDEA was initially named Renamer. So is it the pain points that you saw kind of being solved and you fell for it?
Yes, of course. I mean, before that, we had to do that manually. And when you see that the task you have to do manually for, I don't know, 10 days or a month, you can do in seconds, then you immediately fell in love with, not only saves you time, but it actually enables you to do certain things. Because if you understand that, okay, I'm going to spend a month doing this, then you actually don't do it. It's not only a question of productivity, it's actually enables you to work in a certain way or do things you won't be doing otherwise.
So did you give yourself a time limit? Like when you started working on it, did you say, okay, let me give this product 3 months and let's see how it goes?
We had a limit, actually. It was financial limit because the company was founded with our own money. We all three, we needed to have some money to live. So that was the limit. And the first version of the product, it took about 1 year to bring it to the market. It was the IntelliJ IDEA which we released in about a year. But actually, Renamer was not the only stop. We sold some copies of Renamer, but not many. And then we realized that probably it's not getting any popularity because the functionality is very limited, but it's a standalone product. You have to launch it, and so you do it in parallel with your coding environment. So it's not very practical for a simple task like finding some references. So we realized that we could make maybe even a smaller functionality, like just finding references, but put it in as a plugin to GBuilder, to this IDE. And if it's a plugin, it's always at your disposal. And even for a simple task, but you perform it many times a day, it can be a handy tool. And so we made another product from the same code we had already. We packed it in a plugin and released it, and it was called Code Search for GBuilder. And it was a bit more popular. We sold more copies. I don't remember the numbers, but it was something. But again, it was just to try it, how the sales process is going. So the main goal remained the idea.
Was it hard to sell IntelliJ IDEA, or did things started falling in place as developers were trying it out, they liked it, and by word of mouth, it became more popular? How did it go?
When we released the first version of IDEA, we got some users. Actually, we got some users even earlier than that because we opened, we called it Early Access Program. We have this for our products even now. By the word of mouth, people came, used our product, and they gave us feedback, and we often implemented, like someone makes a suggestion, and maybe even next day he gets it in the next build. The first version, we got some users, not a lot. We understood that because we needed to release the version sooner, we did not have some of key features. For example, I remember that Debugger was missing in the first version. So we knew that we need to actually produce a better version with more functionality. And I think we did it in like half a year or 8 months maybe after the first version. So it was IDEA 1.5. And that's the one which got a lot of popularity already. Right after the release, we got like tens and hundreds of users. It got very, very popular very quickly. Yeah, it was mostly the word of mouth. We did not place any advertisement like on the web or something. Just maybe if you, for example, remember there was some quite popular website. It was for developers, and developers liked our tool, and then we made a deal. Like we gave them our copies of our product for free, and they put the banner on the website. And we got quite a lot of users coming from this site because it was popular.
I'm also interviewing a lot of other developers for IntelliJ IDEA's 20th birthday, and they all were really happy that they get to hear back from either the support or the other people that they report any issue to, features or complaints.
I think it was like a feature of our company from the very beginning, because we were always listening to our users and we're trying to establish direct contact like this early access program.
When I first came, it was a kind of funny story. People were really proud about that. We have very close community in the news groups. When someone writes, I want this feature, and then the next day the IDE comes out with the feature is implemented, we have an option for that, and we're really proud that we could serve our customers' need and provide every option for every customer to any request. But later on, as we developed the IDE not for a handful of people, but for millions of people, it turns out that this is not really a viable approach. We started to have so many options that regular users or regular newcomers, for instance, started to have a hard time to understand how this thing work. So some things on how the project should evolve or product should evolve had to be reconsidered, and I think we did a great job of that. Keep doing a great job, and we have a lot of things going forward on how to keep evolving.
Were there any moments where there were challenges and which were difficult to address?
I can remember one challenge. I lost back at the airport with my computer, and inside there was some source code which was not yet published anywhere else, and also I needed a new computer. So it was a bit of challenge. I think there was a very tough competition when Eclipse came. It was lacking a lot of things comparing to us, but it was free. And also they learned something from us, so they already took some of our features. And then it's much more difficult to convince many users that we offer a better value, because, okay, you say, we have this and that. And they say, oh, okay, Eclipse has it as well. We say, but you see, look at the details. It's not as good as ours. And they say, but it's free. And what we can do with that. So it was difficult competition. But then I think as a result, maybe it helped us to make a better product. Because we created IntelliJ IDEA Community Edition, which was also free and open source, and this gave us much more popularity and more users, and created a platform on which we later on created many more IDEs.
IntelliJ IDEA was open sourced. It's also available as a free community version. Was this risky? How did you come up with the strategy, and were there any fears about its viability?
So at that time, we considered like everything is Eclipse or everything is free, and IntelliJ is the only paid IDE and closed source, and we had very questionable public image because of that. And so we had to make it clear that we can do open source as well, and we did. So the plan was that we can afford to lose like half of the customers, and it turns out that we didn't lose any. Sales in terms of revenue wasn't hurt, and 2009, you should remember, it was immediately after 2008 depression crisis. So it was absolutely right move, and it allowed us to build an ecosystem of our own tools as well as other companies' tools around this platform. And IntelliJ IDEA Community Edition is the best IDE, I think. It just doesn't have features which let you develop for the server side, of course, which is by incident the most of the Java developers do their job. They pay job. So yes, this was risky, but this was the only right move that we could take.
Yes, of course it was a tough decision, yeah. Because we did not know how it will go. and everything was at stock. So everything was at risk, but yeah, it went very well as a result.
I was talking with Slata and she mentioned that one of the recent changes, you implemented that functionality, I think April last year. So do you still code?
I still code, not much in IDEA. That was the the most recent feature I implemented just because I wanted it to be present, because I don't like to, when you need to change signature of the method, you invoke some dialog, and it's quite difficult to operate with. I prefer to make all the changes right in the editor. That's why I was talking about this feature maybe for many years, but it wasn't implemented, and I decided, okay, I will do it. It was just spontaneous effort from my side.
You started with inspections, which is one of the most loved feature by a lot of developers that I know. And when the results started showing, they were like, oh, this looks cool. Do you have any interesting stories around that part?
Yeah, actually I do. I mean, after I implemented this inspection, then for almost 2 years, starting from that, part of my job was talking to colleagues which said, oh, you have a bug. So it shows there is an error in my code, but that's not true. I mean, that couldn't be true. No, your inspection is faulty. And then we sat and tried to analyze what's going on and how does it work. In the majority of the cases, the inspection was right, and there were indeed a bug in their code, not an inspection. Yeah, and after that, people kind of started to trust it, you know. And I should say that most of my colleagues are really skeptical, and they always see the problem in somewhere, someone else code first. Yeah. So having something which is, you don't have an ability to argue, is just a code. It tells you you have a problem, you can't argue that, is a good thing.
I also read that you mentioned that you just can't live without coding, and you try to do that today.
Oh yeah, so it turns out I can live without coding, but I just don't just feel right, and then you know, I need it sometimes. Unfortunately, I do code, but unfortunately not as much as I would love to, and still hope that I'm helpful in this role. And yeah, I do. And my only language this time is Kotlin. I only code in Kotlin. So kind of my horizon shrinks somewhat.
So when did you wanted to start programming? Was it early in your career or when you were in school?
Yes, maybe 12 years or something like that. I decided that I'll be a programmer. Yeah, so I just decided that I like it so much that I will do it, and never changed my decision after that.
So what language did you start programming in?
Well, actually, my first programming experience was with the calculator. So it was a calculator which allowed to write some small programs inside with some basic commands, and I made some stuff in it, even some like games or something like that. And then later on, I think my father, he brought me some materials about BASIC, but I never really programmed in it because I did not have computer to do it. So the main problem in my childhood was the lack of access to the computer. And the time when the first time I got my own computer, it was like I was in the last 2 years of the school, and it was a computer without any software. Like, it was very basic. It had very few tools inside, and everything else you had to write yourself, and they did not have any compilers or anything, so I wrote it in assembler, everything. I learned some languages before that, but not much programming because I did not have my own computer. Like I remember reading the book of Strauss-Trup for C++. It was such an interesting reading just by itself, not even programming.
You started your career as a developer and now you lead the company as the CEO. And that's an impressive career path, I would say. Do you have any secrets to your success?
You know, I didn't know how this happened actually, because I never wanted to. In the first place, when I became a team lead for IntelliJ IDEA, I didn't wanted that actually. So I never wanted to become a manager or something. So I'm a programmer. I know how to program. But then it turns out that, you know, I understand that as a team we can do more, and sometimes teams need not a management. I would say we really flat, but teams need some focus, and to have that focus, we need to lead the conversation. And I think that what has happened. And the same thing happened actually with me becoming a CEO. And I didn't have that in plans ever, but it happened. So I cannot really share any secrets, and I'm not really sure that it is a success, because I would say that as a developer, I would also have had a great career.
So you're not really focusing on the problems, but on the solutions. So that I think is one of the secrets of success that I would say.
Oh, I should think about that. Thank you. I mean, maybe it's going to be useful for me when in a way, maybe I'm stuck somewhere, then I have to think about the words, not think about the problem, think about the solution.
I know that first years that you were working with JetBrains, you were also teaching at the St. Petersburg State University. And how did you manage to juggle those roles? Also, did your work at the university help you with your work at JetBrains?
I started teaching before I joined JetBrains, so I just didn't stop teaching when I joined JetBrains. And it turned out very fruitful, because many of my students are now work for the company. It's one of the things that I'm proud of, and for me it wasn't really a difference, because you know when you're passionate about the code and you want to tell people how to program, then you can have a conversation with someone who's really knowledgeable, or something who is only starting their career, and it's actually kind of the same conversation. And it helped me to understand that, for instance, some of the things in our product are not really as good as I thought they are, because I saw people stumbling upon some issues which were kind of tricky, but then it turns out that we can improve as a product to make them more approachable. Yeah, and also it gave me a lot of not only a lot of insights, but also a lot of positive energy. But finally, it appears that it takes too much work, and again, both JetBrains and teaching was very demanding, and I had to choose at some point. So I did choose JetBrains.
Any feature or any part of IDEA that you really like or are proud of for the current edition or recent editions?
And there are many changes that make it better user experience, better user interface. That's it. So I can't mention anything in particular. For example, okay, this feature that we discussed already, which I implemented for changing method signature, I use it like every day, I think, almost. Because it's very quick, you just edit signature and apply this thing without invoking anything, any dialogues. It's a tool I couldn't live without. Because how would I program? No way. I don't know any other tool to do it, to do programming nowadays.
What are your favorite IntelliJ IDEA features?
Instant highlighting in the editor, online code inspections. Not because of I made it or started it, because I really think that it is important, and I use a lot. Then all the navigation features, which I go to class, go to file, go to symbol, finding path I use a lot because it's quick. Find usages, of course, and preview. I forgot the name. Preview declarations, kind of that stuff. So all the navigation features, I need them. Git support, of course, and the debugger is absolutely useful. Unfortunately, it is really hard to debug Kotlin code with coroutines right now. So I'm dreaming for something more usable than we have right now. Debugging asynchronous code is a problem. We tried to implement as many refactorings as possible just by reading the book, and it turns out I don't use them much. So half of the refactoring features might actually be gone, I think. But like extract method, inline, extract variables, stuff like that, are handy features. I use them every day. Because that's not the way of refactoring, more it's a way to actually write the code. Yeah, so I mentioned dependency analysis. I think that I don't use it every day, but without this tool, in some cases, it's a nightmare. I don't know how to do stuff, and it allows for to keep this code base in shape, because keeping proper dependencies and minimize the surface between the modules is very important. So we use it a lot.
So the last question in the rapid fire round is, which feature do you use the most?
I think it's syntax-aware selection. And we have this productivity guide, which I managed to lose after breaking into a new computer. But I remember that one was most used, because you operate with code as a text a lot, and you have to select a proper range for that. And syntax-aware selection is really handy.
What is the spirit of JetBrains, and what are its core values?
Well, I can talk. I can only speak for myself. For me, it always been fun, meaning that you're doing something which you enjoy a great deal, while at the same time you understand that you provide a great value for the users, for the customers, and this understanding kind of doubles that fun, doubles that enjoyment. And the spirit is, I think, to keep going and always challenge what you know, and always see how to do the next thing. And at the same time, I think that we are very friendly as a company from inside. It's some say that it is just a big family. It is true to some extent, of course, because we are 1,500. It's really hard to manage 1,500 people as a family. But it really, I mean, it's great pain for me when I see that people not kind of respect each other sometimes, because maybe they don't know each other enough. And it's great enjoyment when I see that people collaborate and help each other, and proud of each other's work. I think that these things are really important at JetBrains. And I feel that many people, if not most, I think most people, if not all, feel like JetBrains is is not their employers, but it's like a company of their own. They don't own any shares, of course, but we always say we did that or we are going to do that. It's not that my employer is going to work on this project. You know, it's very personal attachment, and I think that it is important. And I would like this to be kept on for as long as possible.
Absolutely. So there's one more question regarding JetBrains that I want to ask. JetBrains is proud to have, as you said, a flat structure. We have few managers. I hardly have met any managers here, and everybody's opinions matters. Is it difficult to lead such a company?
Yeah, it is. It is hard from my one side, but I think it is important to keep it this way, despite being hard. You know, I remember when we tried to develop a thing called Space Now. For a couple of years, if not more, everyone stopped me in the corridor and said, "So what is this thing called Space? What does it do? Why we need it? How is it going to work? No, we will not be able to sell it to anyone. No, the market doesn't need it." And you know, these things keep going on and on and on. And yes, you have to be persistent if you feel that this is the right way to go. But at the same time, being challenged is not a bad thing. You know, you've given a perspective, maybe how people going to be seeing these things on the market, and having multiple voices, even if not always pleasant, is a good thing. You know, that is what diversity is for instance. You know, it's challenging, but it is important. And you know, I understand that all of those people make their own decisions. Being developers, they still decide on the product features they develop. And so I understand that I'm talking to people with real knowledge of the domain and real knowledge of their customer base. And there is no need to kind of force them to do whatever I want, because they know better.
As you also mentioned in one of the videos that I watched about the dog fooding. Developers at JetBrains use their tools to develop the tools that they create. So they know the pain points. They also test out the product that they're building. So that is really interesting in our case.
Absolutely. It is important though to understand that dog fooding has its limitations, and it's sometimes easy to fall into a trap that you know all, you know everything, and overfeed for a particular scenario. There's a joke that, which is only partly a joke, that IntelliJ IDEA is the best idea in the world for developing IntelliJ IDEA.
And regarding the flat structure, I remember also mentioned some time back that people move around from the role of development to managing the product to going into the market.
Absolutely. I mean, after I stopped working in the IntelliJ team, I immediately saw so many shortcomings of the product, like even how this even works. I said when in and open some other project, and you know you should always change your perspective. It is important. It is a problem if you stay on a certain thing for too long, because you know your horizon shrinks, and it is important to have perspective to be able to make something useful.
The journey of IntelliJ IDEA over the past 20 years. So how would you define its journey from your perspective?
Mm-hmm. That's a really good question. I mean, 20 years is a lot, and it's way more than the lifespan for most of the products and projects in the software industry. And I think that with IntelliJ, we managed to find out not only the way to make it even better with each one new release, but also to find more opportunities for how we can use it in some other way. Like, for instance, we've managed to refactor it all the time and manage the dependencies and models in there to use it in SimCity as a static code analysis tool, or in AppSource as an engine which provides code intelligence for the code review. And of course, we managed to develop a platform which enables IDEs for other frameworks in other languages, which most of them are successful in their niches as well. And so I think the solution to that is a constant evolution. We do not take the things for granted, and trying to evolve the code to keep it in a good shape, to always make sure that it performs the best.
I think surviving and getting more and more popularity during 20 years of our history is a great achievement. So yes, so that's just what I wanted to say. Yeah, that's the achievement. Happy birthday, IntelliJ IDEA.
So, happy birthday, IntelliJ IDEA.
Thank you so much, Max. A pleasure to have you and a pleasure to talk with you. Thank you so much, Valentin. It was an absolute pleasure to talk with you.
We need to unmute Mela. It was going to happen at some point today.
Absolutely. What could possibly go wrong?
What could possibly go wrong?
Yes. So I was saying it was an absolute pleasure to talk with both Valentin and Max. And I remember a few days ago, I was pleasantly surprised when I asked about the IntelliJ IDEA version in which a particular feature was added on our internal chat channel. And Max responded with the version number. And after I interviewed him, I know how and why he knows all the details. And Trisha, before we talk about the memories that our viewers have shared with us on the chat, a lot of them, I want to ask you about your fondest memory of working with IntelliJ IDEA.
That's a really difficult one. I'm going to limit to just two fondest memories. One was when I was, so I had already been using IntelliJ IDEA in other organizations. I joined a company called LMAX where we did pair programming. And when I was pairing there with the fantastic people who worked at LMAX, I was like blown away by how they use the IDE. They were using features I just didn't know existed, didn't know how to look for, didn't even think about. And so it was just mind blowing to me that an IDE can do all of this stuff and just take away a lot of the effort of writing code. Which leads me to my follow-up memory, which is after I moved on from there, and I started, at that point, I started presenting at conferences, and I wasn't working for JetBrains. I wasn't working for IntelliJ IDEA, but I was doing demos that involved IntelliJ IDEA live coding on stage. And so I would kind of try and show some of these tricks of how to, not tricks, like real productivity boosters of all the things that I learned pair programming, so that I could hopefully try and get the audience to have that feeling of, wow, this is really cool. This makes my job a lot easier.
Of course, since we both work together, I agree with what you just said, and I love it too. So we have a lot of comments by our viewers. I would like you to start with the first one, because that's by Dan, who you interviewed a couple of days back.
I did, yeah. So I interviewed Dan because I knew that he started working with IntelliJ IntelliJ IDEA way back in the olden days, probably before it was even called IntelliJ IDEA. And so it was great to see him pop onto the chat and say he remembers the EAP on EFNet hash Java channel. We'd post stack traces. Valentin would post a link to the next build. I think I've heard a few people talking about how you would get like a new build of IntelliJ IDEA every day. You suggest a feature and maybe it might be in the next day's build. Dan says, sorry, Daniel, as he's calling himself, it's hard to describe how much better IntelliJ was than literally anything else around at the time. Suddenly there's an IDE that does actual refactorings. It was revolutionary. So yeah, that was really fun. And talking to Dan about this when I interviewed him was really, really fun. So I have that interview. We will publish it on the YouTube channel some point in a few weeks' time. So do remember to subscribe so you can see all of those details.
And the interesting part is when I was talking with Valentin about this, and he also mentioned this, that the users would come and they would ask for new features and they would add the new features and give them the build the next day. And Max, when I was talking with Max about the same thing, he said, yes, because we were growing and we were not creating this for just a handful of people, but for millions of people. So we had to kind of rework that process. So the other comment that I want to mention, because the names are not kind of the real names. So Torilas mentioned that the IntelliJ IDEA is his favorite IDE, and the favorite moment is when he discovered a keyboard shortcut or a function, and in that moment he became a faster and more productive programmer.
I love finding new keyboard shortcuts, and I'm like, right, I'm going to use this at least 10 times today. So I start adding it to my muscle memory. I remember watching Hadi give his tips and tricks talk at one of the conferences, again, before I started working for JetBrains. And I would go away and learn like 2 or 3 keyboard shortcuts after that, and sort of try and be like, how can I force this into my workflow? And some of them, like the majority of them, stay in your workflow once they find their way to being very useful. Sometimes some are like, well, I'm not going to use that, but it's always fun to try new keyboard shortcuts. So yes, so join us tomorrow for Hadi's tips and tricks talk, because you'll learn 1 or 2 tips and tricks there.
I was proud to say that. Sorry.
We're doing a good job of plugging the conference this time. Next story. I'm not going to read out people's names in case I get them wrong. I'm so sorry. But you'll be able to identify yourselves. February, I had my 6th year of IntelliJ subscription, and I started using this as a junior and paid for it from my own pocket, thinking that if I'm a developer, this product is helpful and I must do this. I did something similar. I paid for my very first version of IntelliJ IDEA. Yeah.
So the next comment is by Fabian, and he managed to convince some of his colleagues to switch from Eclipse to IDEA, and they feel that they're kind of a guru now, but trying to seriously usually means adopting it. I don't know what that really means, but yes, it seems they're happy using it.
The next comment was, I'm generally tool agnostic, but when it comes to IntelliJ, I never even think about any IDE. I assume that means I never think about any other IDE. Yeah, I think it's valuable to attempt to be tool agnostic, because as developers we get dropped into different environments. We have to use whatever the client says we need to use, and we have to learn new technologies. So we generally can't get too hooked on a particular tool. But I do think that as coders, we do tend to, once we find a tool like an IDE that does what you want, we're like, this is a non-negotiable part of my tool set now. And for me, IntelliJ is definitely one of those tools.
Absolutely. So the next comment is by Ashfaq. And he mentioned that he had to switch to different IDEs to work on different languages. But now he can use just one tool, one IDE, which is IntelliJ IDEA, of course, to write any, to work with any sort of programming language. Absolutely.
Yeah, I remember for one of my demos, I had to start using Angular, and I was way behind on my JavaScript knowledge. And it was really lovely to use the same keyboard shortcuts to do code navigation in Angular, to get code suggestions. I didn't know, because I've been away from JavaScript for a while. I didn't know you get code completion in a dynamic language like JavaScript. It was so cool, like, great. I don't have to think about this. The IDE will just do the kind of mechanical stuff for me. And I get the same experience from JavaScript as I do from Java. Same with Kotlin when I started playing with Kotlin. Right, I keep tabbing between all the different screens and now I can't see where I am. Ashish discovered IntelliJ through a colleague of mine and never looked at any other IDE. It's not cheating to look at another IDE, but yeah, we do like a bit of loyalty from the users.
The next comment is by, yes, so we have a lot of positive comments about the debugger. As we know, it's one of a great features that we have in IntelliJ IDEA, and as developers, we use it all the time. So I already formed a team for voting up for the debugger. because that's, of course, one of my favorite features too. So I think we had 3 votes. But yes, a lot of people are really happy with the debugger that we have in IntelliJ IDEA. And the amazing part is the next session is on debugger, and we have the team lead, Egor, who works with debugger, and he would show us why we need more upvotes for debugger.
I don't know how people can develop without a debugger. Like, even before I understood how to use my IDE, I realized what a breakpoint was and what it was for, particularly for things like dynamic languages like JavaScript, because you're like, what is happening here? I don't really know what this is supposed to be. So the debugger, absolutely. It's not my #1 feature in IntelliJ IDEA. Mala, you can be team debugger. I'm going to be team inspections. Inspections are my favorite. It's not just because Max said that they're the inspections and he's the CEO. Like, inspections are my favorite thing about IntelliJ IDEA. But if you come to my talk a bit later on today, you will find out that I've got about 73 favorite things about IntelliJ IDEA. So it's not limited to just inspections.
And I would be covering a lot of inspections in my talk tomorrow. So I think it's okay. We have a kind of good balance, team debugger working with team inspections.
Okay.
So we have 3 more minutes, and I would want to take another comment by Matthew. Matthew works as a developer advocate with Twilio, and he mentioned that he became a paying user of IntelliJ IDEA during the end of the world sale in 2012. And he's glad that the world didn't really end, and glad to be still using IDEA.
That's a good point. That's when I bought my first license, the end of the world, the 2012 end of the world sale. I think a lot of developers I speak to bought their first license in that sale. And then, of course, renewed every year since then. So maybe we need another end of the world. No, 2020 was bad enough as it was.
Yes, you're right. So, but probably we can ping Slaughter and request her to have another not end of the world sale, but amazing sale like that one.
Yeah, let's put her on the spot. Let's say we promised it on YouTube. No, we didn't promise anything. Nothing is going to happen. There is no sale. Slaughter, calm down. Stand down. Right. So okay. So is that all the comments we had from YouTube? I've got like 15 screens to look at here.
So let me take one other one, which is, I don't know how to spell the name, so I'll just read the comment. My first job was on IBM systems. On 5250 consoles, and debugging was a nightmare. I don't think anyone understands how much value a good debugger has, and I was going crazy all the time. Absolutely, I agree with you. And of course, you would see how it can help you in the next session.
That's a good segue. So maybe, I don't know if Helen and Egor are ready to have an early conversation, because we're a bit early. Or maybe we should just carry on like talking about the debugger in advance and just really let's really big up Egor's session so that he can get really nervous about giving his presentation.
I think Egor and Helen are ready, and because we just have 1 minute and we can add them to the stream. Helen is ready. Egor, are you ready? Okay,
Let's
so let me add Helen, and we have Egor now. Hi, Egor. Hi, Helen.
Hello. It was really great to see so many people talking about the debugger and how good it was. It was almost like it was planned for this to be the next session.
I can't wait for this talk now, just hearing all the love that the debugger's getting.
No
yeah,
pressure.
Me too. At least four people interested in the debugger.
That's great. That's all you need. Just an audience of 1. That's fine.
It's going to be great.
You can also add Max and Valentin to it and make it 6.
Okay, we're going to head off right now and hand over to Helen.
Thank you. Thanks, Mala. And thanks, Trisha. That was a fantastic introduction. All right. So my name's Helen, and it is my pleasure to introduce you today to our next speaker, Egor Ushakov. He's going to be speaking to us today about the debugger in IntelliJ IDEA and how it's a hidden gem. So, Egor, welcome. Really excited to have you here today. Are you looking forward to your talk?
Hi, Helen. Thanks for having me. Yeah, I'm really excited to tell you more about the debugger features. So as long as we have so many people interested in that. And I hope there's actually more. So I see the stream currently. We have 124 likes. So if there are more people interested in debugger features, please add some likes there. I will see that, and that will provide a lot of support for me. Thank you.
Fantastic. One-man mission to upvote for the debugger. So Egor is exceptionally passionate about performance analysis, and he leads the development of the debugging, profiling, and coverage tools in IntelliJ IDEA. So he's going to show us some of the developer processes that we can use for the debugger so we can be more productive with a range of techniques. Fun facts, the debugger was first introduced into IntelliJ IDEA back in 2002, for any of you that remember that far back. Of course, it's been evolving ever since, so it's going to be very interesting and insightful to hear about what makes it so valuable for us developers today. Housekeeping tasks, please do continue to add all your questions to YouTube. I will be putting them to Egor at the end of his presentation, time allowing. And fun fact about Egor is he never has to think about how long he's actually been with JetBrains because his daughter was born a week after he joined the business.
Yeah, her name is Alice, and she's 7 now.
Fantastic. Right, I will add your screen, Egor, and then I will hand over to you to do a well-anticipated or greatly anticipated presentation. Over to you, Egor. Thank you.
Okay, thank you, Helen. So hello everyone, and currently I look at the stream and we have 188 likes, so at least how many? 50, 60 people are interested in the debugger. Okay, so today I'm going to tell you a lot about debugger features in the IntelliJ IDEA, and probably some of them are somewhat hidden and some of them are not applicable to a kind of non-Java world, but you will see that many of them could be kind of used in other languages and technologies. Okay, so let's go. So first of all, why do we debug at all? So as someone said already, they don't have bugs, so they don't need debugger. So many people use the debugger only to find bugs and to fix bugs. And that's perfectly fine. Well, the debugger was originally created for this purpose. But in the modern world, if you think about the debugger as a kind of window to the runtime information of your application, you can get much more from that. So for example, you can analyze the code. So I usually do this. So when I see a huge amount of unknown code, I set a breakpoint there, and then using the runtime information, I can understand it much better and much quicker. So then you can, of course, see which parts of your of the code are executed and which are not. Also, some people tend to replace debugging with logging and kind of system out, println in Java and so on, because it is faster. Well, in some cases it is faster, but using the debugger, you can do the same and much more. So I will show you today some techniques how to use logging together with the debugging. Also, with the debugger, you can change the behavior of your application on the fly. So otherwise, you have to change the code, recompile, restart your application, and then see how it changed. But in the debugger, you can change how it works right on the fly without the need to restart and so on. And I will show it today for you as well. Also, right in the debugger, you can do memory analysis. So maybe it's not that kind of deep and good as in a standalone or in the built-in IntelliJ IDEA memory analysis tools, but still you can do some simple memory analysis, and I will cover that today as well. So always debug. I kind of, in Java world, I don't use run action for my Java applications. I always use debug, just because at any point you can set a breakpoint, stop the application, and see what's happening inside. And it is much more useful than just printing stack trace here and there, because you can see variable values and all the rest runtime information from your application. Okay. So what changed in the year 2014? Everybody knows that Java 8 came out in this year, and it introduced lambdas, and everybody started using them, and everybody likes to write one-liners like this. So you can have streams, and also streams were introduced in Java 8. So now you can write a stream processing in one line using 1, 2, 3 lambdas. Okay, this one is kind of trivial, but anyway, you can use it in one line. And Java Debugger historically operates with line numbers. So both these three kind of lambdas and the original line are located on the same line in the code. So it's it was really tricky to debug such code when Java 8 came out. So we introduced, probably a year later, maybe half a year later, we introduced lambda breakpoints. So today you can set a breakpoint in a specific lambda on the same line. So for example, you can set a breakpoint inside this first lambda, and then you can debug this code and immediately stop right here in the lambda. So, and this breakpoint will work only in this lambda. So you can set a condition, for example, for I value here. So if you stop on a breakpoint in every lambda on the line, you will have different variables like X here and K here. So adding a condition for this would be kind of impossible. So you will get a lot of errors for this condition if you have it like this. So in IntelliJ, you can do stuff like this. But also, you can do run to cursor. So for example, if we set our cursor here in this lambda, and we, I will just show you the tool window, and we run, and we do run to cursor to here, so we will immediately stop in this lambda. So for this kind of simple transitions, you don't have to use the breakpoints at all. And then you can do run to cursor again here to stop in the next invocation of this lambda. And this is really easy, but more of that, if you stop kind of at the beginning of such expression and we restart the debugger here, and from here you want to get into, for example, kind of this lambda directly, you can do step into. And as you know, debugger in IntelliJ IDEA shows you the kind of variants where you can step into and you can navigate using your keyboard or the mouse. And of course, filter and peek and toArray are not that interesting for us here, but lambda is interesting. So we can select the lambda, hit enter, and appear directly in the lambda. So this way, it's really easy to navigate through lambdas in your code, even if they are on the same line. So to implement this was somewhat tricky because Java generates code for lambdas, and the class names and the method names are not kind of specified. So we had to match those names with the code. And in that, of course, we used the IntelliJ IDEA analysis, different analysis to do the matching between runtime information and the code information. And now we can do this kind of without any problem. So you can use lambdas in the IntelliJ IDEA debugger as kind of first-class citizen. The same way you put breakpoints on lines in the code before. But why would you want to debug streams with all this kind of fancy lambda debugging if you have stream debugger? And in IntelliJ, we have another kind of really, really exciting way to debug your streams. So if you have a terminal operation for the stream in the expression and you stop on a line like that in the debugger, it activates the action, this action here, like trace current stream chain. And if you click on that, oops, it's on another screen here. And if you click on that, it will evaluate the stream and you will see how the data is kind of transformed during the stream stages. So here, the initial data consisted of six numbers. And if you click here, you will see that that flat map transformed it into these 11 numbers here. And you can click on the exact item here and see so where exactly it was transformed. And also, if you click on next stages, you will see that distinct remove duplicates, and you will see which kind of duplicates were actually removed. Sorted, of course, sort them. And this is understandable. And toArray just put them into the resulting array. Also, we have a flat mode here. So if you click on this, you will have the general picture. And sometimes it's really cool to see how your data was transformed. And of course, this presentation will be available for objects, not only for primitives. Of course, for objects, you have to have kind of a good toString to be able to quickly observe what objects are inside, but they will be expandable here. So you will still be able to find out what's kind of how your stream is being processed inside. So from here, you may probably be able to quickly understand what kind of stage is malfunctioning, and then continue debugging this a particular stage step by step. Like, for example, here we may be interested in factorize, and then we can set a breakpoint inside it and step by step debug if there's a problem there. Okay, so even before lambdas, there were some cases when you needed a breakpoint on a method inside the interface. So kind of you don't care about the exact implementation of that interface. So there may be kind of huge amount of them, for example, 100, maybe 1,000. But you care about the first invocation of a method. So historically, well, method breakpoints, they had it as kind of maybe since the beginning in Java Debugger, but they were really, really slow, and they are slow actually. So we asked users not to use them, and we even showed a notification if user created a method breakpoints that method breakpoints will slow down or may slow down your application significantly. And they really kind of do that because once you have a method breakpoint in the Java debugger, not the IntelliJ IDEA debugger. So if you have a method breakpoint, all your applications starting to be interpreted in the JVM. So this is kind of really, really slow. So, but otherwise, method breakpoints are really useful. So we decided to do the emulated method breakpoints. So currently, all method breakpoints are in the IntelliJ IDEA are emulated. What it means, we find all the implementations of this method from the interface, and we set a line breakpoint in the beginning of this method, and also at the return kind of instructions, if you really care about the method exit, so like here. This way, it works really, really fast. So the only kind of slow thing here is to find all the implementations. So if you have a lot of classes, it may take some time, but still after that, it will work really, really fast because line breakpoints are really fast. So let's say we have boo method here, and we have it implemented in kind of 2 classes somewhere, and it is really called somewhere just because we don't care. So we set a method breakpoint here, and we start the debugger. And from here, you can quickly see that really this method boo was kind of invoked from here, and we stopped in class 2. Okay, but this actually is not interesting because we can do find usages of boo and immediately stop here. So like this is the only usage. So we can set a line breakpoint here, do step into. So what's the point of method breakpoints in this case? So I will show you another example. So for example, foo here. So we can see it is implemented somewhere. But if we do find usages, it says there are no usages because kind of we don't have the invocation of this method anywhere. So let's put a method breakpoint here and start the debugger. So we immediately stopped somewhere in class 3. Because this method, and from the frames view, we can quickly see because it is invoked through reflection. And reflection invocations are really, really hard to track using static analysis because this kind of method name could be generated, maybe composed from several strings or whatever. So it's really hard to track that using the static analysis. And here it works like automatically from the box. And once again, if you have a lot of objects implementing this interface, you will stop in the first invocation of this method in any implementation available. So I tend to use this a lot in IntelliJ IDEA because we have a common class, probably abstract class, and action, which is the base class for all actions in the IDEA. And I don't remember, and usually it's hard for me to find the exact class of some particular action in the IDE. So I set a breakpoint on the very, very base method of an action, like action performed. And then I just do the action in the IDEA, and I immediately stop in the exact action, which does this action. It does this user action. So method breakpoints, you can use it, and you can use it maybe, I don't know, since 2017. So we removed this notification, and we ask users to use it more, because this way you can kind of be really, really more productive debugging things. Okay, so for breakpoints, we have a lot of settings actually. And if you open the breakpoints window, it will show you a lot of them here. So there are many filters here. So I will not cover condition. It's really kind of simple and trivial, and a lot of people know them. And we have more of that actually. And I will not tell you actually today about any of this. I want to show you another way how to use them in a more simpler and effective way. So for example, consider this kind of piece of code. We have work method, and it does something. So it really does something. Okay. And it does something in two different kind of scenarios, like a warm-up scenario and real work scenario. So it's just simple loops. And probably you care about debugging this method only when it is in this real work kind of scenario of your application. But here we can see that the first 10 invocations will be from the warm-up method. So how do you say the debugger don't stop when work is called from the warm-up method? And there is actually a filter for this here. So it is called caller filter. And you can go there and set it up manually, but I don't advise you to do that. Instead, when you stop on a breakpoint, use Alt-Enter to call the intentions. And here it will kind of tell you what it can do with this breakpoint using the information it has right now. So for example, you can set it to stop only in the current class, or don't stop in the class. Or you can tell it to stop only in the current object if you care. Or you can tell it stop only if this method, currently work method, is called from the warm-up method. And with this one, we don't kind of interested in. So we tell it don't stop if called from warm-up. And it will automatically populate the caller filter with this kind of full descriptor of the method. And when you resume your session, you will immediately stop in the real work kind of invocation of the work. So if you restart it, it will be preserved, of course, and you will stop only in the part of the application you are really interested in. So this way, it's really, really easy to set up the filters for the breakpoints. And I kind of advise you not to go there in the dialog and set them by hand. No, don't do that. Use intentions. It's really easy, simple. You stop somewhere you don't want to stop. Just use Alt-Enter and filter this place out. Or kind of you stop somewhere you only want to stop in this context. Just add some filters from there. And from that time, just stop where you want to stop. Okay. So finally, kind of, we stopped somewhere. So we set our breakpoints. We can use method breakpoints, Lambda breakpoints, other types of filtering, and so on. So we stopped in our application. How do we check where we are? So of course, everybody knows the debugger tool window, but we have some kind of easier ways to check, for example, variable values. And the first one is the inline debugger. So I passed some parameters here. They are really, really simple, but you can quickly check their values right here in the editor. So inline debugger puts a note with the variable values after the end of the line where the variable is referenced or declared. So args is an object here, so you can click and expect the kind of the inner structure of this object. And this is kind of the regular debugger tree. You can change value, create a render, whatever you want with this. For primitives, of course, a kind of expansion is not that interesting, but still this way, kind of getting the values of the variables, you can get them in the most easy way using the inline debugger. Also, if you don't like inline debugger or you don't see the value, you can use tooltips. So if you like mouse, you can just hover the value and get the kind of the runtime value. Also, you don't need to hover a variable. You can hover a simple expression containing variable, and it will provide you with the value. But this way you won't get the values for method invocations because we kind of tend not to invoke methods. But you can invoke method using quick evaluate. So if you're a keyboard guy, not like me, use the quick evaluate action, and I don't remember what it is because I'm a mouse guy. So Control Alt F8 on Windows. And you can select, actually, many people pre-select something and then use the quick evaluate action, but actually you don't have to. So you just put your caret somewhere and use the quick evaluate action, and it will automatically select the minimal expression containing the caret and evaluate it. So you can evaluate here and get the result. You can evaluate here and also get the result. But as I said, I'm a mouse person, so I like to be quick and do like a headshot with the mouse. So I use Alt-click evaluate. So what it is, so if you hold the Alt button on your keyboard, and on other platforms, maybe not Alt, I don't remember exactly. On Windows, it's definitely Alt. And you hover your mouse over your code, you will see highlighted what it will evaluate when you click. So for example, if I hover here, I click and see kind of true. If I hover here and click, I see true again. If I have a click here, I see true. So always true. And this way, it's much faster than tooltips because tooltips have delay, and much better, I would say, than tooltips because before evaluation, you see what will be evaluated. So when you hover, you don't see before it is already evaluated. So I like Alt-click. If you like mouse, use Alt-click. I think it's the best way to get values of the expressions which you already have in the code. But what if you want to evaluate something which is not in the code? So for example, I may be interested in evaluating args.length, for example. So this is a trivial example, but anyway. So you cannot click anywhere here and evaluate args.length. So for this, you need to use evaluate expression action. So Alt F8, I remember that actually, but I wanted to show you that there is a button on the toolbar. So you evaluate, you start it and you open the evaluate dialog. And from here, you have a one-liner where you can add anything you want to the values you have in the program and get the result. And you can also do so many kind of nice things here. So it's a real kind of editor with completion and so on, but with the runtime information you can get from the program which you are currently stopped at. So this way you can not only kind of get values of what you have in the program, but also you can do prototyping and check how to use a unknown for you API. So for example, here I wanted to print the operation system name. And I remember that it is somewhere in system properties of the JVM, but I don't remember exactly which one. So of course I could Google that, but sometimes a kind of debugger is a better Google for your program because it knows more about the kind of real environment it is running on. So what I can do is I can do system get properties and get the list of all properties and then quickly do the search here. And yes, I have the name here. So I can just put it here, check that it returns the correct value, and then copy paste it into the code. Just like this. And then I restart it and quickly, using my favorite Alt-click, quickly check, oops, presentation mode, quickly check the result is correct. And then quickly check it in the console. So yes, I've done it right with the use with the help of the debugger. But there is a great feature here, which is somewhat hidden, and this is this small expand button, and it will transform the one-liner evaluator to the full features code fragment mode. So here you can write any piece of code, well, literally kind of any piece of code, using the variable values you have in your real application. So I don't want to spend time here, but I will just show you some examples so you can do kind of stream processing using switches, kind of lambdas, mapping, variables available in this context. You can create new runnables, whatever, and see that the result kind of is really printed here. So you can do so many kind of different things, and this is kind of the trivial one, but still it works. So you can use loops, ifs, whatever you could use in a real application. So then you try this piece of code with the real data you have in your program. You just copy paste it, and there you go. You fixed the bug or changed your application, and you already checked that it works. Okay. Non-suspending breakpoint. Sometimes you want your breakpoint not to suspend anything. And why is that? And this is what I've been talking about before about logging. So consider this example. This is a simple cache. So it has a get instance, which returns a cached instance of the cache. And every time kind of it is lazy initialized. So the first time it is called, it is initialized, and then it returns kind of the same instance every time. So if you start this program, you will see that the output consists of 10 times the same object. So get instance receives a parameter. So for example, if we want to dump a parameter name, we can create a non-suspending, and then click the suspend checkbox here, non-suspending breakpoint that will evaluate and log the value of I. So I set a breakpoint like this. It is kind of yellow because it is a non-suspending breakpoint. And when I start the debugging, I will see in the console the output of this logging. And you can kind of, well, numbers are not that nice, so let's add some nice prefix here. Okay, yeah, it's much better now. And if you want to disable this logging, you just disable this breakpoint and the logging is gone. And then you can enable it again. And you can do this on the fly. So I restarted this application just because it's simple application, but you can enable and disable it right when your program runs in the debugger. And of course, in this case, we may be interested not in kind of logging all the invocations of get instance, but we may be interested in logging the exact place where the get instance was initialized. So we want this logging breakpoint to be on the next line. So we can just drag and drop it here. And this way, you don't need to recreate everything you kind of set up here. And you can just use drag and drop to quickly move breakpoints if they are on the wrong lines. So this way, you can start it here and see that now it is logged only once. But, well, it's kind of interesting thing. You can not only drag and drop, but you can drag and drop with a modifier, for example, control here. And this way, it will copy every setup of the breakpoint you have. It will copy it to another line. If for some reason you need a special logging on several lines, you can just copy those breakpoints quickly and have them where you need them. Okay, so also there is another kind of nice shortcut for this. If you have a value or an expression which you want to be logged in a certain place in the code, you can just select it and do the shift click on the gutter. And it will automatically do everything I did before for you. And then you will just have this kind of breakpoint, logging breakpoint automatically. So if you use this a lot, kind of use shift click, this will save you some time. And also a really nice and extremely powerful technique to use the non-suspending breakpoints is to change how your program behaves. So for example, we care about the initialization of the cache. And we set a breakpoint here. Unfortunately, if you missed this place already, so for example, if you are already in this loop, you will not be able to get into the initialization of the cache because it is already initialized. So how do you debug this code again? There is a way. You can stop in the get instance and set this instance value to null. So in the debugger, you can change the values. Okay, set it to null. Now you can go here and debug it. This is really easy, but actually there is a even better way. So you can do the same, but in a non-suspending breakpoint. So for example, you set a breakpoint and you say that you want it to set instance to null. Well, it is evaluate and log, so it will first evaluate and then log the result. And the result of the evaluation is actually the fact that the instance will be reset to null. And this will effectively disable the caching mechanism here. So if we see the output of the program, you see that from here on, the get instance result is always new. And if you want this behavior to kind of be disabled again or be enabled again, you just disable this breakpoint. You start the application, okay, now it works as before. And now, for example, if you want to kind of debug it or see how your application works with get instance not being cached, you just enable this breakpoint and voila, you changed how your program behaves without changing the code, without doing nothing to the kind of application itself. You can even do that on the fly. Once again, you can just disable, enable the breakpoint, and the behavior of your application will change on the fly. This is really, really powerful technique. I use it a lot, actually. And also, I have another kind of way of using this. So sometimes you have special flags in your application which are initialized using properties, for example. So if you pass a property, you can have your application working in a kind of debug or whatever other mode. You can do the same using this technique. So you just set a special kind of breakpoint somewhere in the initialization stage of your application, and you set this variable kind of usually it's a static variable, kind of globally available, and you set it to the value you need. And so when you have this non-suspending breakpoint enabled, you will have your application working in that mode. So no need to add anything to the startup options. Okay, let's continue. Advanced stepping, and this is kind of really cool part. I also like it a lot. So this is a really, really simple application just for the sake of the demo. So it does filter numbers and then it somehow processes those numbers. Don't read the code, it does really nothing. So we stop here, we enter the process method. It does something with the kind of the arc, and then it does a print line. So everybody knows drop frame. So if you kind of miss the place in the method where kind of something interesting happened and you want to kind of restart the method from the beginning, you can use the drop frame. And drop frame kind of drop this current invocation of the method, and then you can step into again and do the same method from the beginning. Of course, it has some kind of side effects because it does not restore the global state if it was changed or modified, but still in many cases it is really, really useful technique. But this is somewhat kind of everybody knows. We have more for you. So let's say I don't want to execute this method further. I want to return it right away, right at this moment here. So Java Debugger can do this. So you can do force return from the context menu of the frames view, and it will immediately return. So this method is a void method. So of course, you don't have to specify anything here. But for example, in here, we may want it to return false, because currently it will return true. So I can tell it to return, and it will ask me, what do you want me to return? And I will tell it false. And now you see we haven't entered the process method. And this way you can really change how your program behaves kind of totally. So if you don't want a method to be executed, you can just enter it and then do the force return and drop all the calculations and return right away. Also, if you care about exceptions, so for example, here, in the process, we may be interested in how the application would behave if an exception happens somewhere. So how do we check this? This program does not throw any exceptions. So there is a way here, and it is called, well, throw exception. And you specify the kind of the object which should be thrown here. And you click on OK, and you immediately stop in the catch block that will kind of catch this exception. And you can see that this is our kind of, oh my God, exception that we created just before. So this way, it's really kind of easy to check how your program behaves, or to somewhat, again, modify the behavior of your application. Okay. Sometimes in the debugging process, you are really interested in some specific objects. So for example, I have two objects here, M1 and M2, and later I kind of may be in a situation where I need to check if this is kind of M1, which I had before, or M2, which I had before. And of course, you can remember these numbers here. These are the unique numbers of the object, but it's kind of not really convenient. Instead, you can use mark object and add a label here, and also you can add a color. So a lot of colors for the debugger. So let's add M1 here and M2 here, and M2 will be green because, well, because. So later, when you enter the process, you will see that this object is the same object we had here in M2. And also, if you go further somewhere, kind of in, for example, this toString implementation, you will also see this label here in the frames view. And it means that the toString is called for the object marked as M2. And this is really, really useful to check if the object is the same as you had before. And also, for example, if you want to compare this M2 with M1 in this context, where to get the M1 object. And there is a way which is somewhat hidden again. In any place where you can do debugger evaluation, you can evaluate special kind of names, like label underscore debug label will be evaluated to the value of the mark object. And it will be evaluated in any context. So because debugger doesn't care about context, so you can evaluate it in everywhere. So for example, I added a watch like this, and I can switch to a very different thread. And this is kind of the Java internal thread. And of course, from here, you cannot anyhow access your kind of M1 object. But using this marked object, you can. So you can even use it as a parameter anywhere here in the evaluation, in the breakpoint conditions, anywhere. Okay. And this is really good, but there's more actually. So let's consider this kind of extended example of this. So we have 3 memory objects, and let's say you forgot to mark them. So here you have only one of them. Let's remove this one. Here you have only one of these kind of memory typed objects, and you want to see other objects of this type. And let's say you don't have them here. They are somewhere in the past. So you know that they are in the heap, but you don't have access to them at the moment. Well, actually you have, because you are in the debugger. It knows everything about your program. So you can right-click and invoke show kind of type object, and it will tell you the current runtime type of your variable. And it will show you all the object it has in the heap, in the Java heap of this type. And from here, you can kind of check what you want from these objects. You can once again mark them, and then later kind of use what you want with this in the debugger. And you can use the full-featured memory view here. So you have a list of classes with the number of instances that are currently in the memory. So you can type here our memory class name, and you can see that we have 3 objects as I've shown you before. But what's more interesting here is that you can actually check every object in the Java heap. So for example, we can see how many strings we have, and we have more than 3,000 strings. And you can expect what's inside, and you can filter For example, I care only about lines with length more than 1,000 characters. And it will quickly filter this and show you the kind of long lines in your Java heap. And from here, you can also call show referring objects to do simple kind of memory analysis. And it will show you where this line is referred from. It's inside the VM. And also, you can do the same in the regular variables tree, but for this kind of, it's not really interesting because it's local variable. But let's find something, for example, integer objects. We have a lot of them and they look really, really kind of strange. Why do we have so many kind of similar integer objects? Let's have a look at the referring objects. If you didn't know, integer has a cache inside for small numbers. So if you kind of create a lot of small numbers, it will use cached values instead of creating new values. So this way you can really do simple memory analysis from here in the debugger without the need to take the snapshot of your application memory. And this is much faster, and probably for simple questions like who is holding my object, why is it not being garbage collected, you can use the debugger and avoid kind of using more complicated tools. Watches. So I've shown you before that you can use watches with marked objects, and this way they will stay kind of stay available in any context. With the regular watches, sometimes it's not really convenient to use them because they really quickly goes out of the context and become red, and you don't have kind of anything valuable from them in other contexts. So for example, here we may watches, we have an object which contains milliseconds inside. And if we care about something about a human representation of this, we can add a special class level watch. So we care about this information only in the context of the this object type. So we can add a new class level watch for it, and we can specify an expression here. And in every object of this class watches, it will add this new node in the beginning that will be evaluated and show you the information you require. So this is really useful. Think about it as a special kind of custom fields which you can use to your objects, and they will show you some information about your object only in the context of this object types. But you can actually go to kind of the limit with this. So for example, A is a string value, but you can still add a new class level watch here. So for example, starts with A, and of course it is true. But now in every string object, you will have this node. So let's get back to the memory view, and you will see that in every string object, you have this kind of watch inside. So do we have any kind of object starting with A? And yes, we have, and here it is true. So this is somewhat extreme example, but anyway, I think you get it. And also there is a way to kind of tie a watch to the place in the code. So for example, here we may want to step into the println method, and this is a library call, well, not library, it's a JDK call. So we may be interested in string s length here, for example. So if we add it here, it will be shown, yes, of course. But when we go out of this context, this watch will be just garbage. We care about it only in the context of this particular method here. So we can right-click here and add inline watch with the same expression. And this watch will be here on this line. So when you enter this method, it will be evaluated and shown you in the inline debugger, right where you need this. So you can stop and restart it, and you will see that this watch is useless. But if you step into the println method, the value is here and evaluated. And you will also add, you will also have all inline watches here in a special node just to be able to delete them all at once or navigate to where you used them. And you can quickly delete them from here as well. Okay, so async stack traces, one of my favorite features of IntelliJ IDEA Debugger. In the modern world of async calculations, well, Max told something about this today. There are some situations where you appear in a async task calculation. So here it's a really, really simple program. Don't kind of think about it. It just runs something asynchronously. Then it runs something asynchronously again, and then you stop inside that task. So if you stop there in the debugger, and for now I disabled the async stack traces, but they are enabled by default. So if you disable that, you will only see in the stack, you will only see the internals of the kind of completable future and fork join pool and nothing interesting. So if you don't know, this filter button hides all the library calls. So here in the stack, you cannot see who kind of initiated the calculation of async 2 here, who initiated the async 1 here. There's no main here. So what's happening in the program? You cannot get this. And to solve this, we introduce async stack traces. So it is enabled by default. So you will in your kind of applications immediately see this stack. So it goes inside the completable future, and then it switches to the async stack trace. And then you have here the call that initiated this async task. And then if you go further, you will have the call that initiated this async 1 task. And this way, it's really, really easy to track how your kind of data and your program flows through the async calculations. We have hard-coded presets for this, for kind of standard JDK executors, for Swing, for JavaFX, for some other things. We may add some more if you need this, but some people have custom executors in their applications. So they asked us, how do we use this functionality with our custom executors? And we have a solution for you now. So this, once again, really, really simple and trivial example of custom executor. It has a new kind of thread, dedicated thread, which does in an endless loop processing of a queue. And schedule method adds a new task to the queue, and the task is kind of just an integer object. So really, really simple and trivial scheduler for your application. And if you stop in the process method here in the debugger, you will see nothing interesting, just the internals of this thread. So you cannot get from the stack to the kind of schedule method. So who scheduled this task? We don't know. So to solve this and to enable async stack traces with your custom kind of scheduler, we have a special annotation inside the JetBrains annotation package. And it's a simple package available in Maven, Gradle, whatever. And it has several useful annotations you can add into your code to make it kind of, to make IntelliJ IDEA work better with it. So in this particular case, we have two annotations, async schedule and async execute. Async schedule you need to use in your kind of schedule method, and process you need to use in your execute method, the method which kind of executes the task from the queue. And you need to annotate either the kind of the object which is used as a key inside with this kind of mapping schedule with process. So you add these annotations, you start your application in the debug mode, and you'll see what we have. So now it has added the async stack trace automatically. And from here, so you can see that the process was for the kind of the first task. And from here, from the stack trace, we can quickly go to the exact schedule invocation with the first task. And if we resume, we can go to the schedule of the second task and so on. So this way, it's really, really easy to make it work with your custom schedulers inside your code base. But there's more. So some people approached us and told us that they don't want to use JetBrains annotations. Well, we asked why, and they told us just because. So you can use your own annotations, actually. So here in settings, you can go to async stack traces, configure annotations, and you can specify your own annotations. So you need to add one annotation for schedule, one for execute, write it down here, and async stack traces will work for your code base even without the need to have a dependency on JetBrains annotations. All for you. So we have like 10 minutes left, and I will tell you one more thing. So everybody knows about renderers in the IntelliJ IDEA Java debugger. So when you have an object in the debugger, you can modify the toString presentation of the object, which is shown right here. So I don't have it here, so nothing is shown here. And also you can change the presentation inside the kind of the tree. So the fields, you can replace them or add new or do something else. So here, actually, I have a linked list, and I called it fast linked list just because, well, if you call something fast, people think it's more kind of fast. So it has a value and next and a link to the next node here. So of course, when you see such object in the debugger, by default, it does not extend any kind of JDK collections interfaces. So by default, it will be really, really tricky to get the size of this collection and to get all the elements from this collection. So as you know, you can go to the view as create and create a new renderer for this. And here you can substitute the size. So the toString presentation, you can add the toString, you can add the size calculation here, and you can add the kind of the children calculation here. But this way, it will not be shareable with your colleagues, for example. So we have another way to do this, and this is once again a Java annotation. Oh, JetBrains annotation. So we have a debug render annotation, and you add it to your code base, and you specify the text you want the debugger to show instead of the toString, and you specify the expression to use instead of the children of the node. So here we have a simple two-array implementation for this fast linked list. And we use it in the size as well. So of course, it's not that kind of efficient. We can write more kind of better implementation of size here. But anyway, so if you add this annotation to your code base and you kind of put it into the repository, and the other developers take it and debug it in the IntelliJ IDEA debugger, they will, without kind of any further setup, get this nice presentation of this collection. So they will have the size here, and they will have the elements here. And this is kind of extremely kind of powerful technique. We have some custom collections inside the IntelliJ IDEA code base, and we added some renderers like this to the code base. And now kind of everybody see this as it should be. So this is a collection. So it should be rendered as a collection. So this is how it works right now. We just added that there and forget it. So it has the size and elements. So how do you switch back to the original presentation? Everybody knows, like view as object, and you will have your old presentation. Well, not for the sub-object, but still. So with all of this, thank you for your attention. Debug more and use Debugger not only as a debug tool, but as a tool for the application development. Thank you very much. And I think, Helen, we can switch to questions.
Yeah, thank you very much, Egor. I certainly learned a lot from that, and just reading the chat on YouTube, so did a lot of our viewers. There was a lot of love for the stream debugger that you demonstrated specifically. Comments such as, it's quite cool, mind-blowing. There was a question that I believe was answered in the chat, but just to reiterate, were there any debugger features that you demonstrated today that are not available in our community edition?
No, this actually is a released version 2020.3.2. So you can try to use it right now. And I think we will share this, well, I can't say slides, this class so that you can play with it.
Fantastic. That is an excellent segue, actually. I'm going to jump around the questions a little bit. We have 2021.1, which I'm still struggling to say, is our next release. Are you willing to be drawn on any debugger features going into that release or future releases?
I wanted to say yes. We kind of trying to implement different approaches actually to the user interface. So as you've seen, we've tried, I've shown just a little of the debug tool window because with the years, now it's really kind of has a lot of labels, a lot of buttons everywhere. And in modern world, people tend to use more lightweight interfaces. So we play a lot with the user interface of the debugger. I will not commit that it will be in 2021. Yeah, but we plan to do a lot in this area.
Good to know, thank you. So another question that again was answered in the chat, but I will ask if you've got anything to add to it. The question was, I cannot modify final field values when I'm debugging. What is the problem to implement that? I.e., will that be possible someday? And the response from a member of the team in the chat, we believe it is a limitation with the JVM debugging API, prohibits changing those values. Is that something that you're familiar with, or do you want to add anything to that?
Yeah, that is a limitation. Yeah.
Okay.
For some situations, we probably may kind of to do this, but I probably don't want to go to that right now.
Okay, fair enough. Thank you. Okay, so another segue. What would be, in your opinion, the best way for a new user to familiarize themselves with the debugger in IntelliJ IDEA? It's obviously a very rich tool, a very powerful tool, but if you've not used it before, can you give some tips for getting started with it in that instance?
Mm-hmm. Okay, so we actually added a lot of new information to the documentation of the IntelliJ IDEA, so you can start from there. There are a bunch of good tutorials actually right now available there. They have different kind of situations where they show how to use debugger more effectively. Also, we plan kind of a series of videos about debugger, and actually we have them at the moment, so you can go to tips and tricks about the IntelliJ IDEA debugger. We have these videos available. So start from there, I think, documentation videos, and start using that. Actually, you can just go through menus. There are a lot of different things there. People tend to use only line debug, line breakpoints, and that's it, but there's much more in the IntelliJ IDEA debugger.
I think you've really opened our eyes to that today, just the huge range of tools that are there to support us, which is fantastic. What is the, I'm going to really put you on the spot here. What is the top feature of the debugger that you can't live without? And I'm going to try and make you just pick one. We'll see how that goes. Okay, two is your maximum.
Okay, you'll be surprised. So I'm a mouse user, as I have said already. So I like to use mouse a lot. I have a kind of physical mouse, so if you can see it here.
Yes.
And so it has like the back forward buttons, which are really useful when you go through the code. And also I set find usages on the middle mouse button so that I could quickly navigate with control click to the declaration, and with middle mouse button to go kind of back to the usages of the methods. Because of that, I really can't think about living without alt-click evaluation, which I've shown today, because I use it a lot. So I think it's much more useful, because you look at the variable, you want to see its value, and I use alt-click a lot. And so this feature is the first in my list. And if you want 2 features, I would say memory view. So
Okay.
I was one of the developers implementing this, and now I believe this is a kind of the real window to the information about your application. Because without it, you only see what you have in the context of the breakpoint which you are currently stopped at. And with memory view, you can see kind of everything inside your application.
Fantastic, thank you. Okay, Egor, that was incredible. There's been, well, there still is a lot of love for that presentation on YouTube. Everybody learned a lot, so thank you for writing it. Thank you for taking your time to be here today. It was really very valuable. So yeah, thank you very much.
Thank you, Helen, and thank you everyone for joining me today.
Thanks, Egor. Okay, we are going to be transitioning over to our next host and speaker now. If there were any questions that didn't get answered, the team will respond to them in YouTube or at a later date. So don't worry on that score. So I'm going to introduce you to our next host now. We are going to introduce Trisha back to the talk. Hi, Trisha.
Hello, thanks for introducing me again. I loved that talk. That was really cool. I gotta say, so I've been using IntelliJ for about 15 years, and there were at least 3 things in there that I did not know about at all, and can't wait to start using. It was really cool.
Thank you, and I'll leave you to it now.
Thanks a lot. So our next session is on UI and UX. Let me bring in the new speakers. So welcome to Olga. Welcome to Alina, who I'm also going to make sure is unmuted. Oh, she's muted. That's fine. So hi, Olga and Alina. So I got a chance to get a sneak peek of this talk, and I was really excited about it because it covered loads of things which really interest me. Things like how do you decide how to expose a particular feature? How do you think about the workflow of the developer as they're trying to do the things they try to do, and like how and why might you want to change the workflow of a particular feature? So I think this I'm looking forward to this talk again. I think it's going to be really, really cool. What else did I want to say? Oh yeah, so fun fact about you two, that you both recently moved to Amsterdam. I'm assuming that was independently of each other. I'm not sure. Like,
yeah,
just moved the whole team
independently.
That's cool. So have you had much of a chance to sort of see your new city, given that there's an awful lot of lockdown going on?
On the streets, yes, and the city is beautiful, but in different places like cafes and bars, not yet, but I'm looking forward to it.
There's something to look forward to, at least.
Yep.
Oh, I love your t-shirt, Alina. I don't have one of those t-shirts. I'm so jealous. I'm wearing my old t-shirt from 1,000 years ago. Look at this. It's got the old logo on and everything.
Yeah, this new one. Very nice.
Very cool. I love it. Great. Awesome. So, yes, I'm just trying to find out if there was anything else I was supposed to say. Alina, I will drop you off for now so that we can leave Olga to do her bit, and then we will see you again in a minute when it is your turn to do your bit. So I will drop you off. I will add Olga's screen so that we can start seeing what she's about to talk about. And yes, and I will see you a bit later on to ask you questions.
Great. Thank you, Trisha. So hello, everyone. My name is Olga, as you already know, and you just met Alina. We are design leads for the IntelliJ platform UX team. And we are going to tell how we design user interfaces in IntelliJ IDEA. Firstly, let me introduce the UX team. The team started 7 years ago with me. I was a single designer for a couple of years, and then the team started to grow. We got a new designer each couple of years, but then more people started to join each year. And we are waiting for even more people. So this is the current state of the team. We have 8 UI UX designers and 1 type designer. Our team is distributed among 3 offices. 5 designers reside in St. Petersburg, 2 in Munich, and 2 in Amsterdam. I need to say that we design UI not only for IntelliJ IDEA. We work on the whole IntelliJ platform on which all our IDEs are built. So our UI designs for the platform get to all IDEs. Another important thing to say is that not only designers make design decisions in the IntelliJ family. We make user interfaces together with a great team of all kinds of engineers, product and marketing managers, technical writers, and developer advocates. So how do we do that? Usually we keep a few design goals in mind. The first is an obvious one: improve the user experience, or in other words, solve the problems our users experience with the UI. The next one is to keep the existing functionality. IntelliJ IDEA supports tons of user scenarios, and at the same time, it has lots of UI accumulated over the years. Sometimes we have to remove old user interfaces, but at the same time, we need to keep the existing functionality. The next one is make features discoverable, because we'd like developers to find all the useful features we have. At the same time, we don't want to clutter the screen with heaps of extra UI, so this might be a challenge. The fourth goal is protect user habits. IntelliJ IDEA is an everyday tool, and it forms strong habits. If you break them, people might get less productive, and this is not what we want. We do that only when we are really sure that the new way is better. The next one is be keyboard friendly. To make developers productive, we want to make all necessary features accessible with the keyboard. And the last one, support UI consistency. When you have as many user interfaces as we have, it might be a challenge to keep them all consistent. So it also becomes a goal in our case. Now we are going to tell how we try to reach all these goals in our everyday work through 3 stories about our user interfaces. And the first story is about refactorings, and in particular, the rename refactoring. As you know, refactorings are IDE features that allow you to improve code much faster than doing it by hand. For instance, renaming a Java method. You can do this manually. First, rename the declaration, and then any calls the method has. But a much quicker way would be to hit Shift F6 and launch the rename refactoring. With it, you need to type only in one place, and other places get renamed automatically. But there is a complication. If you have a commonly used name like getName here, the rename operation might take a really long time. Among other things, this might happen because of the rename options. You can see them only if you open the rename dialog by hitting Shift F6 twice. These checkboxes here, this one and this one, they make the search scope much wider, and this affects the refactoring speed. But you don't see these options by default. You see them only when you open the dialog. And we cannot just turn them off because they might be quite useful. And also, we don't want to show this dialog each time the refactoring is started, because these options are not changed often. So we decided to try and do something with that. There seemed to be no familiar UI pattern to show options right in the editor. So we decided to make a new one. The first design idea was to inline options into the completion pop-up here. So here are name suggestions, and here are options. This idea was out of the top of the head, and it didn't work very well. This is because 2 operation modes are mixed in this UI. The first one is that the pop-up closes if you choose the name variant and hit enter. But if you choose an option and hit enter, you might not want to close this pop-up. You might want to see if the change applied, and you might want to choose a name variant afterwards. So this is confusing. The next idea was to move the options to a separate menu so that we don't mix these 2 modes of operation. But how to show it? We already have a handy control that we call an inlay hint. We use it to show different additional information in the editor. Like in this case, it shows the parameter name in the method call. And one of our goals is to support UI consistency. So we want to reuse an existing control. Here's how it looks with the rename options. We put an option icon into the inlay and put options into the pop-up. This seems a bit better. However, when the menu is closed and you still wouldn't know what happens when you start the rename refactoring. And we want to make features discoverable. It's one of our goals. One of the smallest way to show something is to use an icon. So we decided to visualize the options that have the most effect on rename speed as icons. You can see what these icons mean if you open the pop-up. So the resulting flow is as follows. You start the refactoring and rename the method. Then you see that the option you don't need is on, as indicated by a blue icon. So you press tab to open the options pop-up, and then tab again to get to the second checkbox. Then you press space to turn it off and enter to complete the refactoring. This seems pretty keyboard friendly to me, as we use all the familiar and simple keyboard keys. But we missed one thing. When we released this UI change internally at JetBrains, our colleagues reported that they hit tab to complete the refactoring. And it was quite unexpected for them that tab started opening the pop-up. That is, here we go against the goal of protecting user habits. This particular habit comes from the regular completion pop-up. There, enter would insert the new text at the correct place, and tab would replace the whole symbol under the correct. And do enter and tab work the same in the rename refactoring, developers are already used to tab. So we had no other choice as to change the shortcut. Finding a new shortcut that opens the options pop-up took us some time. That's because most shortcuts are already taken for many actions we have in IntelliJ IDEA. And we wanted to have something meaningful here. So we managed to find the shortcut with O for options. That's it with the rename refactoring. But this is not the only refactoring in IntelliJ IDEA, I'm sure you know. Another popular one is extract method. How does it work? You might want to break one method into several. You can do this by hand. First, you select a chunk of code, cut it, paste into the new place, add a signature to it, and add a call at the place you removed the chunk from. This sounds like a lot of actions. A much quicker way would be to press a shortcut for extract method. Here are the shortcuts for Windows and Mac. The shortcut opens a dialog where you enter the new method name, check the new signature in the yellow preview area, and hit the refactor button. And here's your new method. The obvious problem here is with the dialog itself. It's large, it covers the code, and it basically distracts you from writing it. And we think the less UI is the better. So we decided to try and make all the options in this dialog inline in the editor. But how to move all these options into the code? The first approach was the following. We insert the method call at the initial place. It's this line. Then jump to the new method signature, where you can change all the parameters same as they were in the big dialog. Additional options like checkboxes are shown under the gear icon. That is, we tried to keep all existing functionality in a pretty straightforward way. But here you move caret to a new place. And this caret jump might be quite big, and it might be hard to return to the original place of editing. So this doesn't seem like a good solution. The next version was to stay at the place where we extracted the code from, allow changing the method name, allow removing the parameters because they are already here in this line, and leave some options under the gear icon. But here we have to make some new and consistent control. We don't have these cross icons anywhere else in the editor. And if you would want to add a new parameter, you would still need to jump to the declaration. So the final version, here we decided to allow editing just the method name and left some checkboxes under the gear icon. These checkboxes might be quite useful if you want to quickly tweak the method. For instance, make it static if it's possible in the case of a particular method. So the resulting version looks as follows. You select some code, hit the shortcut, the caret doesn't jump, and you can edit the method name at the place where caret was. You can also modify some additional options under the gear icon if you need it. After you enter the name and hit enter for the first time you are using the extract method refactoring, we show a tooltip explaining how to quickly jump to the declaration to edit it if you need to do that. And we show this tooltip only once. If you press the Go to Declaration shortcut, you can then edit the new method signature as you see necessary. So we managed to remove the big dialog and keep the existing functionality by means of code editing only. That's it for me and for refactorings. And Trisha, could you please switch to Alina's slides for the other two stories?
So, hi again, my name is Alina, and I've been working as a UX designer in IntelliJ team for 4 years already. Today, I'd like to show you several more cases from my work. The first one is about initial start. As you know, today IntelliJ IDEA is 20 years old, and during all these years, more and more dialogues were added on the start. And last year, we decided to review the startup experience and to try to simplify it. So let's take a look how it worked before. Imagine that we start IntelliJ IDEA, and the first dialog that you see will be import settings. That suggests you to import settings from the previous IDE version. Let's select Do Not Import and go to the next step. The second dialog is user agreement. We can just accept it and move next. Then you see another dialog. The UI of it is also different. And here, JetBrains asks us to share our usage statistics. Let's share it and move forward. Then we get to the customization wizard dialog. It consists of several steps. And on the first step, we suggest to select theme. Here are two themes. Actually, it's a bit outdated because now we have more. For example, we have a high contrast theme as well. And also, we found out in usage statistics that most often people switch twice, so they return back to the default theme. The second step of the dialog is the launcher script. And here you can configure it for depending on your operation system. And then we get to the third step. It's plugins. Here you can enable or disable a group of plugins depending on your needs. And the last step is featured plugins, where you can install some more plugins useful for you that JetBrains suggests you based on statistics. And finally, you get to the welcome dialog, where you can open a project or create a new one. So what we had, you need to go through 7 dialogues before you can actually start working with the code. One of our goals while reworking this flow was to improve UI and UX, so you can quickly start working with your code and creating projects. While on the other hand, we still wanted to keep all these existing functionality because it's rather useful. The second problem with this dialog was the initial customization dialog. People cannot return back to it. For example, if you want to configure theme, you would need to find it in the settings dialog, and the UI won't be the same. So we wanted to make these features discoverable, so you can easily return back to them when you already started working with your project. And also we wanted to make the UI consistent, so you do not need to learn different variations of UI for the same tasks. So I started to work on the solution, and the first thought was to simply improve the UI to make the dialogues consistent, at least the same shape, so they work kind of one wizard, and to enumerate steps, so you understand how many steps are left. But then I asked myself, do we really need an interface here? And together with the developer, we walked through all the possible scenarios for import settings, and we found out that we actually can automatically import settings if we found them, and if we found nothing, we can just not show this dialog. For the case if you want to start from scratch and to reset all the settings, we just added an action restore default settings in the menu. For example, it's very useful for our testers. The second step was user agreement dialog, and unfortunately we were not able to remove it completely because we are bound here with a legacy policy, and the same with data sharing. So we just unified the UI of this dialog and merged them in one wizard. The next step was to rework customization wizard and the welcome screen, and we started to explore different options. One of them was to put welcome screen in a tab, so you have all your recent projects on the left, and you have a customized section on the right. The plus of this approach is that you can create a tab just next to welcome and start working with the code. And you can always reopen this tab. But we are afraid to break user habits because our users got used to the following scenarios. When you close all your projects, you get to the welcome screen where you can open another project. And with the welcome tab, it can't be done. Another approach was to introduce a welcome tool window. So you can always open it and return to all customization things. But we also decided not to move in that direction because tool window button will be always present, or you need to manually hide it, while most probably you do not need it while working with your project. One more approach was to introduce settings icon in the main screen with all the needed customization settings. But we're afraid that it won't be discoverable enough. So what was the final solution? We decided to merge customization wizard with the welcome screen. So its welcome screen is familiar for our users, but here you can also return, quickly get to all the other settings. So what we have here, on the first page, we see projects. And here are three entry points. You can create project, open it, or clone from version control. When you open the same dialog for the second time, you see here the list of your recent projects. We also improved this screen a bit. For example, we added here a search field that was not present in the old welcome screen. We also added icons for projects so you can better distinguish them. And we left more space for project paths so you can also see full paths of the projects. The second tab is Customize. And here you configure theme or configure launcher script the same as you can do it on the old initial wizard. We also added here accessibility section. So you can configure IDE font size and increase the scale of the IDE on the first start. Third page is plugins, and here we have two tabs, one marketplace and the second one installed. On the marketplace, you can install featured plugins, and on installed tab, you can enable or disable a group of bundled plugins. And also, this UI is the same as UI in settings, so it's consistent. We also added a fourth page here, it's Learn. Here you can start interactive course or get some help or resources. So instead of 7 dialogues, you now need to go only through 3 of them before you can start working with your project. But actually all the functionality is left, so you can just simply go to Customize tab and configure all the things that you need. What feedback we got about what are the challenges we faced while working on this task? We needed to introduce the same dialogue in all other IDs, for example, in Rider as well, and they have more actions, 6 of them. So here, for example, we can add 6 buttons, but the UI looks a bit cluttered, and it's even worse on this screen because if we try to add more buttons, it would look like this. So what we did with it, we introduced more actions link here, and we put all other actions under it. We understand that it's probably a bit less discoverable, but on the other hand, these actions are more for pro users, so most probably for people who start the IDE for the first time, they won't be that needed. And on this screen, we put them under 3-dot icon. So what feedback did we get? It was mostly positive. People really liked the new welcome screen, but there is still room for improvement. For example, there can be one more licenses dialog that appears on the start for paid IDs, and it's also rather old, and the UI is not very user-friendly. So what we have in mind is to replace it with a simple login dialog. So if you log in with your JetBrains account, we automatically start TL for you or get your license from your JetBrains account. So you do not need to configure it here. So this is it about the first case. And now let's move to the second about plugins. I worked on this case several years ago, and let's take a look how the old UI looked like. Plugin settings are appeared in settings dialog, and here you had the list of installed plugins, and the main scenario to install new plugin is hidden at the bottom. You need to find this button. And actually, there are two buttons. One is to install JetBrains plugin, and the second one is to browse repositories. So actually, before installing the plugin, you needed to decide what type of plugin you need, JetBrains or not JetBrains, and it can be not that easy when you actually do not know. When you click this button, another dialog will open. And here you see the list of plugins that you can install and other detailed information about them. And on the left, there are icons. And actually, icons are all the same. So they mostly cluttered the UI and didn't help you to find the needed plugin. In some scenarios, for example, if you want to add a custom plugin repository, even more dialog can open one over another. So there can be 4 model dialogs. Another thing that we wanted to fix is to add featured plugins to this dialog. You already saw them in the customization wizard. So we wanted to make them available on the settings dialog as well. How I started to solve this task? I decided to review different references. And the first one was the JetBrains plugins website that was released that days. And here we see the cards for each plugin. You can hover the plugin, click on it, and you'll get to the plugin page. To the plugin page. Here you see the detailed information about the plugin, description and images and so on. Actually, plugin management is present in many other systems as well. So, for example, the same is in App Store. Here you have cards for each application. You can click on it to see the detailed information. And exactly the same we see in the Chrome Web Store. You click on an extension and see the details. So we decided to use the same approach. We introduced cards for each plugin. Each plugin now have an icon, which is a plugin logo. It has a short description and some other useful information as number of downloads or rating of the plugin. You can click on the plugin to get to the plugin page to read details about it, and then you can return back to the plugins list. We released this version several years ago, but unexpectedly, we got lots of negative feedback. What problems did people face? One of them was the unclear navigation. It was hard for them to understand how it worked because it was the new pattern that it was never used before in our IDEs. Another problem was that we broke user habit. Before they can go through the list of plugins and quickly see the detailed description of the plugins. And now you need to click on each plugin to see the details about it. So we introduced the inconsistent UI, broke user habits, and we also broke one more user scenario. For example, when you are searching for the plugin, you like to compare different plugins by their rating and number of downloads. And in our new UI, you need to follow that line to compare them, and it's actually not very convenient. So we realized that actually a solution that works for many other applications and websites didn't work for our IDE, and we decided to rework it. Before reworking it, we decided to make a UX study. Unfortunately, 2 years ago, we didn't have our own UX laboratory. We have now one, but that days we asked our colleagues from Android Studio team to help with that. So during the UX study, we realized that people really have problems with navigation and searching for plugins, but we also found out some more things. One of them was about the plugin card. People said that this tag and short plugin description is not very useful for them, as well as last update date. So we simplified the plugin cards to make it more clean, and we placed all this additional information in the plugin details part. Another finding was about search. In the first version, we introduced search with the completion. So you start typing and you see the suggestions in the pop-up and you can select them. But it was not very discoverable and clear for users. Actually, developers do not install plugins that often, so it was hard for them to remember all these syntaxes for the search. So we replaced it with a simple combo box as used in many websites and very common for people. So here is the version that we have now. Here we have the list of plugins on the left and the plugins descriptions on the right. You can quickly go through the plugins list and compare plugins by rating, for example. And also you can quickly go through the plugins and read the plugins descriptions on the right. But there are still some problems. For example, it's hard to see on what tab you're at the moment. And for example, if you're on installed tab and start searching for the plugin, we suggest you to search in Marketplace and switch to another tab. And it's not very convenient in some cases. Users ask us in tickets to merge these tabs in one, but we are afraid that way we can broke some other user scenarios. So we are still thinking how to improve that behavior. So that's it about the case. And today we wanted to show you based on our cases, how we are balancing between our goals. So we are trying to improve UX to make it more functionality, more discoverable, and to make the UI consistent. While on the other hand, we are trying to keep all the functionality that IntelliJ IDEA have now and to protect users' habits as well. Thank you very much. If you have any further questions, please contact me or Olga. Sorry, there should be one more slide with thanks word and our emails. Yeah, here it is.
Great.
Thank you very much.
Thank you very much. So I've got you both on the stream at the same time, so I can ask you both questions. And I'll keep your Alina, I'll keep your screen on so people can see your email addresses if they need to contact you. We had a few questions we wanted to ask you. The first one was a comment actually, which was a comment from Mala, but I think most of us agree with it. It was really interesting to see how much effort goes into making the UI really sort of minimal. It seems obvious that to remove things should be easy, but actually, certainly seeing the first example for the extract method, getting things so there's less stuff on the screen, but still discoverable and still accessible. It clearly takes quite a lot of work to do that kind of thing. And I think as users, we don't necessarily appreciate that. That was just a comment, really. I don't need an answer to that other than, yes, I'm sure it is. Okay, there was a question about, okay, there's lots of comments rather than questions. one of the questions which I found really interesting was, are developers different types of users to normal users? I don't really know what that means, but like, is it difficult to design for developers because developers have a particular way of thinking, or they're perhaps power users as opposed to a simple, I don't know, another type of user?
I guess there are a few things. The one, for instance, is that IntelliJ IDEA and all our other IDEs are very keyboard-centric. And one of our real challenges is finding shortcuts right now, because almost all nice shortcuts are already taken. And we have to keep this thought that we should be keyboard-friendly for any design we are doing. So this is the thing. Another thing, I guess, it's that the IDE is an everyday application, and people really get used to that. So changing anything requires like very careful thinking, not to break any really important habits.
I found that one of the most interesting parts of that talk, because one of the things I'm always trying to tell developers when I'm trying to help them use IntelliJ IDEA is to develop that muscle memory. So people are asking me what the keyboard shortcuts are, and I'm like, I don't know what the keyboard shortcut is. I know it looks like this. And so I guess once people have developed their muscle memory, you have to very carefully bear that in mind when you're thinking about changing functionality or adding functionality. Like you were saying about pressing tab to move to the cog icon, because a lot of people use tab for the drop-down completion. So trying to cater for the user's muscle memory and not break their habits. It's interesting.
That is, yes. And muscle memory, as I know, is the worst thing to break, because if you change something visual, you have at least some cues on the screen for that. So you see it looks a bit different, but maybe it's in the same place, at least. Or it looks the same, but a bit to the left or to the right. It moved somewhere, for instance. But with muscle memory, you don't have any hints what changed. And it's harder.
I remember when we introduced not having the modal window for commit. The modal dialog for commit. So now that if you enable it in the most recent IDEs, you get the new commit window. And the first time when I was using the new commit window, I'm pressing. I want to say. I can't even remember, because it's whatever keyboard shortcut I used to get I was trying to get to the log window, but it wasn't taking me to the log window because we had the new commit window and we had the git log window, and I was really confused about how my keyboard shortcuts were not doing what I expected. And but that was in one of the early access things, and I think that got resolved as part of the process. So I'm assuming that for you, the early access stuff, the nightly builds as well, that with our own internal developers dogfooding the product, that must be really important feedback for you to find out if something needs to change before a big release.
Yeah, that's true. I personally consider our UX team lucky in that respect, because we have developers all around us, and we can ask them questions if we have them, and we can ask them about the new user interfaces and about how they use the old user interfaces, and it's great.
Yeah, we also actually have nightly builds, so our developers install a new version of the IDE every morning. So if we change anything, developers will come rather quickly to us and say us about it if something is very bad or, yeah.
That was a very polite way of saying the developers will scream at us that things don't work the way I expect them to.
Yeah,
I'm actually contemplating using the nightly build for my demo a bit later on, but I'm like, I'm not sure if I should use the nightly build for that or use a stable build.
Yeah, stable sounds safer.
It does sound safer. Okay, so I had some more comments and suggestions. There was something. Actually, it was something that you mentioned, Olga, in the rehearsal about keeping. Was it about keeping existing features or about keeping the existing? Oh my goodness, I can't even remember. I've made notes that I can't even read. Something about keeping existing features or keeping. Am I misremembering?
Yeah, existing functionality, yes.
Yes. And about how that's not necessarily obvious that we always need to keep existing functionality, because the IDE, it does need to, actually, here's my question. Let me form it into a question. The IDE does have to evolve. You are adding new features all the time. You are also, as you showed, not just adding new features, but trying to improve the existing features. Like, I didn't really know that extract method needed to be improved until you improved it. So you're constantly involving the IDE. And in fact, I think Valentin even mentioned that in the keynote, that the user experience, the user interface is constantly improving. So there must be a balance between adding new features, improving existing functionality, and retaining old stuff that, I don't know, like, how do we know if we can delete any of that stuff? And you were talking about how the keyboard shortcuts are like all already used. So how do you balance the legacy with moving the IDE forwards?
Well, like with the extract method, one of the way to balance it is to sometimes we have several ways to do the same. Like with the refactorings, we have inline refactorings in editor for some refactorings, like rename or introduce variable. But for some refactorings, we had big dialects still, model dialects. And also for extract method, what you need to change is already in the code. And you have, for instance, the refactoring change signature. That's kind of the next step or sibling of extract method. So we can try and use only one method, use only what's already there. For instance, what's already there in the editor to do the same stuff, and not add extra interfaces on top of that. And that's what we really want to do, because it's a challenge to keep all this, to support all these interfaces. And it's a challenge to make them all discoverable, because we have really lots of stuff in IntelliJ IDEA in terms of interfaces. Well, so one way is to just leave one method of doing something and make this method the most convenient and most discoverable. Yes. Alina, could you, do you have something to add?
Yeah, we are also trying to simplify some UIs based on the usage statistics. For example, we can check it, and if we realize that not many people, few of them, for example, less than 1% of people use some functionality, we can probably move it, not show it for all the people, and put it under some more advanced options and so on. So this is another way of improving UIs. Yeah.
Yeah, I liked that you mentioned that in the welcome screen, that sometimes you don't have to. The balance between discoverability, making stuff visible, versus actually some stuff is only used by a small subsection, so we can just hide those, not hide them, but put them somewhere slightly less in your face. I thought that was an interesting way of reaching that balance. Right, so I do have a question here. How much thought goes into accessibility when designing the new UX UI? How difficult is it to maintain a good level of accessibility? I've tried working with a keyboard screen reader only, and it isn't as easy as it may seem.
With this accessibility, we try to support it on the platform level to make all our basic components and dialogues accessible, like, for instance, for the screen reader. And currently, it's more of a technical problem. So the design decisions are mostly clear here. So we don't have to invent anything new usually, because rules for accessibility are already there. They're supported by different operation systems, by different applications, and we just need to support them as well. And we have some technical questions around that. And our platform UI team has been constantly working on that and continues to work. So I hope it will improve with time.
So it is a key. Sorry, Alina, carry on.
Yeah. We always trying to keep that in mind, and we actually have it kind of in our checklist. For example, if a designer creates a new solution, we are usually asked about accessibility. Will this, for example, new control will accessible? How it will work with the keyboard and screen readers and so on. So we try to keep it in mind as always. But yeah, probably not all the features are covered with accessibility at the moment, but we are working on it.
Okay, so it is a key thing that's on your list of things to be aware of. I have a sort of similar related question, which is around, I know that not me personally, JetBrains has been working on internationalization, well, localization actually, so that the UI can be translated into different languages. Is that something which that either of you have any experience in that here? For example, I remember when I did this for one of the websites, I used to work at a major automotive organization, and we had to translate our websites into German, and we had all sorts of problems with the sizing of things when you've got different languages. Is this a challenge that you've been facing here as well?
I can't say it was really a challenge for the UX team, at least. We had to change some wording at several places, but if I remember correctly, the reason was mostly that the initial wording might not have been really clear, so we had to improve it both in English and in other languages. Yep. And mostly that was an effort on the side of our technical writers team and various developer teams across our IDEs.
Yeah, that's something I found interesting about when you mentioned that the UI and the UX it's not just the remit of like you two or even like half a dozen people, but it's everyone. It's the developers have to come up with, obviously I assume the developers are kind of the first port of call. They're saying, let's add a button here, or let's add this feature here. So it's a sort of organizational effort to make the usability, the user experience and the user interface good as it can be.
It is, yes.
Okay, what else have we got? Well, I've got a few good questions, but the first thing I was thinking was that Egor said in the last session that the debugger needs a little bit of love in terms of the simplifying the user interface. Is that something that you're going to be involved in or have been involved with? Or is there anything you can talk about around that?
Yeah, we are working on it at the moment, and there are already some mock-ups were discussed, some approaches. Yeah, actually, the simplified debugger version was already introduced in Rider. Probably some of you have already seen it, and we are thinking about taking some of the same decisions to IDEA to simplify debugger. Yeah, so we are working on it, and I think that Egor also mentioned it as well. And so yeah. I hope maybe not the upcoming release, but this year the simplified version will be released.
Until he mentioned it, I hadn't really thought about it, but the debugger, particularly the debugger tool window, is very much about buttons. There's like buttons everywhere and like menus when you right click on something. Like he was showing stuff today that I must have seen in the menu 20 million times, but I've never read it because the menus are sort of so full of all the different options that you just gloss over them. So I'm really interested. It's clearly a challenging problem. I'm really interested to see how that's going to evolve over the next few releases or so.
Mm-hmm. Yeah, so here the main one part of it is to make it easy to start for newcomers. So you see all the main options at the first, but you, on the other hand, can quickly get more advanced options. Yeah, and the other problem that we are trying to solve as well is many icons. As you know, in IDEA, there are lots of them, and not all of them can be very clear. Yeah, so we are trying to get rid of some of them, probably replace them with buttons with labels so they are more clear if it's possible. Yeah, so we are trying different approaches.
I love, speaking of buttons and labels, I remember it's probably quite a few years back now, but when the UI was changed to unify a lot of the different buttons and the icons changed, this must be, I don't know, 4 or 5 years ago, and everyone went mad. They were like, oh my goodness, my buttons look completely different. And then like 3 months later, they've completely forgotten that everything's changed and they know exactly where everything is. But people do have that like, who's moved my cheese type attitude of, oh, the button is now it's a flattened arrow instead of a raised arrow and I don't like it anymore. How do you filter out what is just what is something that the users are going to train themselves into getting used to versus, no, this is actually a usability problem which actually needs to be addressed?
I think that icons are very kind of visible and they are everywhere. So people really got used to the appearance of the icon. And when you change them, it looks like the whole ID changed. Yeah, it was a rather challenging task to rework all the icons. I actually worked on this task. Yeah, so we tried to introduce the system for the icons because before the colors were used randomly, and we tried to add a kind of semantic for all the color and to reduce the number of colors so that you can better understand why and where each color is used. And the same about icons shapes. We tried to simplify them and to make more clear. Yeah, we got a lot of negative feedback as well, but there were also a lot of positive. But after some times, I think that people got used to new icons, and also there were users who come to us after several months and said that, oh, I like new icons. I accidentally switched to old version and I do not like all the icons anymore, something like this. So yeah, I think it's a question of a habit as well.
Yeah, definitely. That was my experience as a user. I was a bit like, oh, my UI looks completely different and I don't like it. And about like 3 weeks later, I'm like, oh no, why would I go back to that old thing? This is much better.
Yeah.
We get used to things. We get used to things the way they are. Is that the, what would you say is like the biggest challenge that you've faced so far in terms of UI UX?
That's a tricky question.
Sorry.
Yes, maybe it would require more thought, but out of the top of the head, I suppose for me it might be the domain itself, because I'm not a developer myself. I know a bit about it, but mostly I rely on my colleagues to get me into this world. And so I'd say it's that after several years working as a UX designer for this product, I already know much more than I knew when I just started, but still there are so many knowledge in the programming world that I'm still learning what people do there, what technologies they use and how they are using them. So,
Alina, okay. Alina, what do you think your biggest challenge was? Was it the icons or was it something else?
The biggest challenge, I think that for me, still the biggest challenge is that the IDE have that many users, and all users have their own different habits, and it's very hard to always keep in mind all of them, not to forget about anything. Yeah, so many users, and that our IDE is an everyday tool. I think it's the most challenging things.
This is another question you might not actually be able to answer because you don't know if you're working on it yet. Are there any interesting problems that you have worked on or are working on but haven't solved yet? Like, is there something that's kind of annoying you about usability or the user interface, which you haven't been able to come up with a solution that you're happy with yet? It's fine to say, no, everything's perfect. I fixed everything.
No, I don't think so. What I have in mind is probably search. We are trying to improve it. It's like search everywhere, search by go to class, go to action, and all these other tabs. And it's rather challenging to understand how to better improve it. And we are not sure that the current approach is the best one. We are introducing now a set of UX studies to see how people use it. So, for example, probably we are thinking maybe we do not need search everywhere, kind of all tab at all. Probably we need to have project and action tabs, 2 of them, or we still need all. So this is an open and rather hard question. And it also depends on different scenarios. For example, how big is your project? In some scenarios, some type of search works better, like search everywhere. So for big projects, it doesn't work. So yeah, it's rather tricky question to answer what direction better to move, and we are trying to investigate it now.
I think that's a really interesting topic, actually, because for me, I'm still, as a user, I'm still trying to train myself to use search everywhere. I generally tend to use the direct keyboard shortcuts for either class or file or action. And I would like, in theory, to just have one keyboard shortcut where I can do all of those things, but it's not really the same thing. Like, if I know I'm going to a class, then I don't want to search everywhere for a class called thing. I want to go directly to the class. So as a user as well, I've been trying to figure out the most efficient way to use those sets of searches. So I can see how it's an interesting challenge for you.
Yeah, actually, in my perfect world, we will have one search field like in Google. So you search and you always have what you need in 2 or 3 top results.
Right. And for me, when I'm trying to tell people how to use IntelliJ IDEA, instead of giving them 4 or 5 different keyboard shortcuts, I wanted to just give them just search everywhere so that they can get to that thing. But I can see there are challenges around that. So for example, if I type, so here's my classic example. If I type Gradle, I will end up with the build.gradle file, the Gradle tool window, Gradle settings. And so it must be impossible to go directly to that thing that I'm thinking of, because I'm just typing one word Gradle. I'm not psychically controlling my computer.
That's true.
Yeah.
Any last points before we wrap this up?
I'm not sure. It was exciting to give this talk. I'm really glad to do that, to tell about how we work, how we design interfaces in IntelliJ IDEA.
Thank you very much for giving the talk, because I learned a lot about how difficult your job is.
Yeah, and I also wanted to add, please do not hesitate to contact us if you have any suggestions or anything else in mind. We are always ready to talk with our users.
Great,
And
absolutely.
One last point. Trisha, you mentioned that our work is difficult, but I think it's at the same time very rewarding for a designer, because you have different and interesting tasks, you have different problems, you have lots of users with lots of scenarios, and this is an exciting challenge, truly.
That's cool. That's a great note to end this on. So yes, let's say goodbye. Thank you so much, Olga and Alina. That was a really good talk, really helpful. And I'm looking forward to that being available on YouTube so I can point people to it later on. Thanks a lot. Bye.
Thank you very much.
Thank
Bye.
you. Bye.
Oops, I added you and I didn't mean to add you. Hi, hold on. I'm going to remove you now. That's what happens with a binary button like that. And this is a usability problem. I pressed something and someone else pressed it at the same time and everything went all wrong. Great. Let me bring Mala back to the stream before we bring Tagir onto the stream. It's a good thing he was ready to be on the stream, isn't it?
Yes.
That could have gone really
loved
wrong.
it. Absolutely. And I loved your conversation with Alina and Olga after they were done with the talk. So many things to learn. And thank you so much. That was amazing. I enjoyed it.
Thank you very much. It was nice to be able to have that conversation. In the olden days, when I was a web developer a long time ago, I got very interested in user experience and usability and user interface stuff. But I ended up not going down that route because it's actually really difficult to do that kind of thing. So it was quite interesting to be able to talk to them about how they work and what the challenges are. Right, so Mala, I will leave you to it, and I will let you introduce the next session. I'll see you later.
Thank you so much. So time to add our next speaker to the stream. So the next session is about data flow analysis in IntelliJ IDEA, how the IDE perceives your code. And I'm so glad and pleased to welcome Tagir Valeev to present it. Hi, Tagir.
Hello.
It's a pleasure to have you present today. Sorry.
Hello, Mala. Hello, everybody.
Tagir is a Java champion, a technical lead with IntelliJ IDEA Java team, and an amazing person to work with. He not only likes Java, he also contributes to its evolution. He participates in Project Amber Expert Group, submits patches to OpenJDK. He's also created StreamX library, which enhances the Java Stream API. Tagir, you don't just like Java, you love it. Did anyone count the number of times I mentioned Java when I introduced Tagir? Also, Tagir is from Siberia, where minus 30 degrees centigrade frost is a normal thing. How do you survive that?
Thank you for so wonderful introduction. It's not so hard as you may see. And if you do something actively, it becomes quite warm. Of course, you should wear something warm in order not to freeze.
So I'm based in Italy, and I hate the winters here. And the minimum that we go is around, I think, 5 degrees centigrade. And I remember once I visited Finland, where the temperature was minus 29 degrees centigrade. And I just can't forget those days. So I don't like so much of cold. So now, talking about today's session, Tagir is excited about data flow analysis and how it makes IntelliJ IDEA smart, so it can really make non-trivial conclusions about your code. Tagir will help you to understand how the IDE sees your code, what kind of errors it can detect, and which are too challenging for it. So, Tagir, I would let you take the floor now.
Thank you, Mala, and hello, everybody. Yes, as Mala said, my name is Tagir Valeev, and my main role at JetBrains is to enhance the Java language support in IntelliJ IDEA. Today, I'd like to give a technical talk about the internals of one component inside IntelliJ IDEA. We call that component data flow analysis, and in my opinion, it's one of the smartest parts of our IDE. Please note that everything I will tell you today is relevant to the Java language only. The same functionality may not be available for Kotlin or other languages. Just a few words about myself. I first got interested in static analysis around 2014, when I first encountered the Find Bugs static analyzer. I made some contribution at that time and learned about this field. After that, I tried to create my own static analyzer, but then joined JetBrains to work on IntelliJ IDEA instead. Since then, I have been a member of the Java team, where we are working on improving the Java language support, including refactoring, quick fixes, new language features, and completion, among many other things. But the thing I like the most is data flow analysis. In general, static analysis is about finding the problems in your code before executing it. Most code inspections are relatively simple visitors that examine the syntax tree of the program and check some conditions. For example, IntelliJ IDEA suggests to replace list.stream.forEach call chain with just list.forEach. Because why write longer code and create a stream instance when there is a forEach method already directly in the list? A very rough overview of the inspection implementation would look like this. We visit every call in Java source file. Next, we try to resolve a call to the method and check if it's stream for each method. If it is, we check the qualifier. And if the qualifier is another call and it resolves to the collection.stream method, we report a warning. Here I simplified the API and removed some corner case handling, but essentially many code inspections look like this. A bunch of if conditions that match your code against known patterns that are either erroneous or could be improved in some other sense. This is useful, but it's usually perceived as a mechanical work. We have hundreds of Java inspections like this, but some inspections work differently. Today we'll talk about a specific one. It is a rather cryptically named constant conditions and exceptions, and it reports many different problems. Sometimes they look really unrelated. For example, here you can see 4 different warnings. All of them are produced by constant conditions and exceptions inspection. The first is method invocation trim will produce null pointer exception. It is so because we are just under s equals to null condition. The second is that substring call always fails. That's because if the length of the string is 2 characters, a substring starting from 3 is impossible. This call will produce a string index out of bounds exception. The third one is about the cast. That will always fail, which is also understandable as a number cannot be a string. The fourth is that condition s.equals null is always false. Why? Try guessing yourself. So we have null pointer exception, a method that will always fail, erroneous cast, and always false condition. Let's dive deeper into this inspection and understand how it works and why it reports the seemingly different things. Let's start with constant conditions. I believe many of you have seen a warning like this before. Condition is always true or false. Well, to be honest, if a condition is marked as always true or always false, it could also fail with an exception. Because, you know, in Java, exceptions can pop out from almost anywhere, so adding unless it fails would be too pedantic. Sometimes, however, this leads to confusion. For example, even if you don't have any prior knowledge about the IDX value, this condition is marked as always true, which some developers may not expect. As you can see, if IDX is at least 4, then char_at method will fail with index out of bounds, as the Java string has only 4 characters. And if it's less than 4, then the second operand is true, and the whole condition is true. Under no circumstances you will get a false result. The thing is, the condition is strange, is likely buggy, as the result of isLowerCase method doesn't have any effect. So a warning like this usually reports suspicious code, even if it's not immediately clear what's wrong. Let's try to figure out how IntelliJ IDEA understands that some conditions are always true or false. It looks more or less easy when condition is like this. Assuming that we have a parse tree of our program, we should just visit the if statement condition, compare the number on the left with the number on the right, and see whether it's actually bigger or not. However, if we stop at supporting expressions like this, the inspection would not be very useful. Let's type some that more complicated condition, even involving a basic math function, like math.abs. Still, IntelliJ IDEA knows that the condition is always true and warns you about this. Now, the syntactic tree of the condition is much more complex. It can look roughly like this. Still, it's quite easy to evaluate such an expression programmatically. We just need to go bottom up, evaluating every math operation for which operands are already known. Eventually, we'll get the result for the whole expression and see that it's always true. It looks like IntelliJ IDEA executes or interprets your program, and it actually evaluates some parts of it. It's not so convenient to interpret the programs using the syntax tree representation, so before any interpretation, we transform or compile the program into some intermediate representation. Our intermediate representation looks roughly like this. Not exactly this, as I removed some irrelevant details, but it's very close. This representation is never specified, it's not very strict, and we are not very proud of it, but it does its job. Essentially, it's a stream of instructions executed on a stack-based machine, somewhat similar to Java bytecode. Here, the stack content is visualized. When the push instruction is executed, it puts a value on the stack. When binop is executed, it takes 2 operands from the stack and puts the result back. As you can see, we start by pushing 12 and 3 on the stack, then performing a multiplication, which results in 36, and so on. The method call like math.apps takes arguments from the stack and pushes the method result. So after executing these 14 instructions, we have a true value on the stack and we can issue a warning. Looks simple. Unfortunately, in real programs, we rarely have completely constant expressions. Usually we have variables, parameters, and method calls that may return something unknown. So we would not get too far if we have worked with plain numbers. The engine we use works with more abstract values. That's why another name for this procedure is abstract interpretation. Sometimes this allows inferring the result of expressions that involves unknowns. For example, here we don't know anything about the values of x and y, but we can still infer that the result is always false. How is this possible? Let's try to interpret it. First, we push x. We know nothing about x. It's just like any other integer number. Let's depict it as a question mark, as we have to push something to the stack. After that, we push 5. Now we have modular division. But even if we don't know nothing about the dividend, we know something about the result. Whatever number we divide by 5, the result is always between -4 and 4. And our abstract interpreter supports values like this. It can track ranges of integer number, even disjointed ranges. It's not as smart working with floats, but for integer numbers, it really holds some magic. After that, we divide y by 10. A similar thing happens. Even if we don't know the y value, we know that the result is within the -9 and 9 range. Next, we calculate +20. We can do the math on ranges, not only on exact numbers. So -9 to 9 range becomes 11 to 29. Finally, we evaluate the greater than logical operator. Even though we don't know the exact operand value, we know that any number between -4 and 4 cannot be bigger than any number between 11 and 29. And so we can evaluate this expression, even though we don't know all the inputs. It can do even crazier things. For example, here we again know nothing about 2 integer variables x and y. Yet we can evaluate the condition, because the left operand is always even, while the right operand is always odd. As the comparison, an abstract interpreter knows that no even number can be equal to the odd one. By the way, you can get some of the internal state of our abstract interpreter right in the IntelliJ IDEA UI. We have an expression type action. By default, it's bound to Ctrl-Shift-P. If you press Ctrl-Shift-P several times, it can show you additional information, including the internal knowledge about this expression. For example, here you can see that interpreter knows the oddity of this expression. Okay, this is impressive, but it's still a rare case that this analysis could be helpful. Often, however, we have some knowledge about the variables. If we track the possible variable values, then we can evaluate much more. Let's write a little bit more complex program. Now we have some intermediate variables assigned and used. So to be able to evaluate the condition like this, we need to support the variables inside our abstract interpreter as well. For example, for the x equals 3 line, we push the variable, then value 3, then we have a new assign instruction that stores the variable value into the interpreter memory. Finally, we need to pop the resulting value from the stack, because the assignment keeps the resulting value on the stack. Similarly, we encode the other 2 assignments, then finally evaluate the condition. Now let's see how the interpreter state changes when these instructions are executed. Push x puts the value on the stack. But now it's not just an unknown value. We actually push the variable symbol. Then we push 3, then assign, and finally pop the result. The stack becomes empty, but now the interpreter knows the variable value. Similarly, we continue to the end of the program. When we push variables, we push their symbols on the stack. We substitute them with values only when we execute the operation. For example, at step 18, we have x and z on the stack, but at step 19, we execute the addition operation. So we read x and z values from the variable memory and perform the computation. Okay, now we have variables. But this doesn't give us too much, as we need to know the values of all the variables, which is relatively rare. In particular, we cannot reason about method parameters. For the next improvement, we'll need to be able to split the state on conditions. Let's go back to the case we've seen previously. Here we have no prior knowledge about x. To execute the if statement in our interpreter, we actually need the conditional jumps. Here we have the if false instruction, which performs a jump if the value on the stack is false, but continues execution normally if the value on the stack is true. However, how can we perform these conditional jumps if we don't actually know the result of the first condition? Here's the trick. We can split the interpreter state and produce both true and false values. Let's see how it works. We start normally, pushing x and 0 to the stack, then we have a less than operation, and here the magic happens. When relational operations are executed, they can split the state. Here we create two separate states for x less than 0 and x greater or equal to 0. In the first case, we have true on the stack, and in the second case, we have false on the stack. So now our interpreter needs to continue with both states independently. The next step is a conditional jump. We pop the value from the stack, and if it's true, we continue execution normally. But if it's false, we jump to the step 10, and the interpretation finishes. So inside the if statement, we have exactly one state, when x is less than 0. Now we continue interpretation with this step and eventually evaluate the next condition at step 7. Here we load the x value from the variable memory, and we know that if the number is less than 0, it cannot be greater than 1. So this condition is always false, and we can report the warning. Great. The problem with this approach is that now we have two separate states after the if condition. If we don't do anything, this may quickly grow and go out of control. For example, imagine a method like this. After the first condition is executed, we have two states. A is greater than 0 and A is less or equal to 0. After the second condition, we have 4 states, because now that we track combinations of A and B variables. Every condition doubles the number of states, so even a moderately complex Java method may produce an enormous number of states. To avoid this problem, we can join several states when they reach the same instruction. For example, suppose that we reach an instruction with 2 states. Both are with empty stack and have negative y, but x is negative at one state and positive in another state. It looks like there is no need to track positive and negative x separately anymore. So the states are joined to the single one, where x is just any value except 0. Some simpler static analyzers forcibly join all the states when possible. However, this doesn't allow tracking correlated variables. For example, IntelliJ IDEA can warn you in this non-trivial situation. Here, conditional expressions are executed, which are processed in the same way as the if statements in our abstract interpreter. Depending on the sign of x and y, we set a and b to the different values. Now we check if the sum of a and b is equal to 2, and IntelliJ IDEA knows that under this condition, x cannot be negative. If we take a look at the states, we can see that after the first line, we have 2 states. We could merge them and simply remember that a is either 0 or 1, and we don't know anything about the x. But in this case, we could not issue a warning. The value of a correlates to the value of the x, so we cannot just ignore this knowledge. After the second line, we have 4 states, and we still track all of them individually. Finally, this pays off. The expression a plus b evaluates to the number 2 only for the state 1. So when we enter the if body, we know that both x and y are positive here. It works even if we compare a plus b to 1. In this case, only state 2 and state 3 pass the test. So x and y cannot be both positive or both non-positive. That yields very non-trivial conclusion. X cannot be equal to Y under condition A plus B equals to 1. This looks like real magic. However, as we saw before, if we don't merge the states, the amount can quickly grow. So when the number of states reaches some threshold, we will still have to merge them, forgetting about correlations. If your method is really complex, please don't expect that IntelliJ IDEA will display all the warnings. Another problem with abstract interpretation is loops, or more specifically back branches. Here's how trivial for loop may look like in our instruction set. First, we assign 0 to I. This part is executed out of the loop. Next, we check the loop condition and exit the loop if the loop condition is not satisfied. After that, we execute the loop body. Just call the println method and print the number. Finally, we execute the update part, incrementing the I variable and return to the beginning of the loop. If we try to interpret this kind of loop, when we enter the loop body, we will have a single state with I equals to 0 and length is greater than 0. However, after the increment, I will become 1, and if the length is greater than 1, we can go to the second iteration. So we will have another state with I equals to 1. If we continue this, the states will not converge until we enumerate all 2 billion positive int numbers. We can merge the new state with all the states we already processed at a given location, but this still won't help us. The length range converges, but the range of the I variable always changes. We don't know when to stop as we always have a new state, and we cannot simply stop the interpretation at some point, because in this case we can get false warnings. This problem is solved with so-called widening procedure. When we have a back branch, the result of the increment and some other operations is dropped. We just forget about it. It's called widening because we widen the set of possible values to all the numbers. Tracking number values is great, but we are not working with numbers only. What else do we track? First, we have a type system that is more precise than defined in Java. For example, having an unknown object variable obj, we track if it's not instance of some type or even several types. Here, after the first two checks, we track that obj is not instance of number and not instance of char sequence. This allows us to warn about instance of integer and instance of string builder checks. Both are impossible, as integer is a number and string builder is a char sequence. By the way, this information is also available via the advanced expression type feature. We also track whether the type is exact or not, and sometimes it's useful. For example, here, downcasting A1 method parameter to B is possible if we are sure for some reason that we always have B as the input argument. However, downcasting A2 to B is not possible. The analyzer saw that A2 was created using a new operator, so A2 type is exactly A, not just instance of A. By the way, here you can see the exception warning, not constant condition warning like before. These warnings are actually similar. Cast operator fails if the corresponding instance of check is always false. So if we can evaluate instance of, we can also check if the cast is always failing. Another thing we track is nullness. I hate nullness. It's really tricky and dirty. Some of you probably get annoyed when IntelliJ IDEA complains about possible null pointer exception. Some of these warnings are false positive indeed. That's because it's really hard to balance between false positives and false negatives in this case. In case of constant conditions, we report something that always happens. Condition is always true. In case of null pointer exception, we report something which may or may not happen, and it's much harder to know. Let's start with a simple case. We check the input parameter for null and continue the execution after that. So IDEA sees that you expect the null value in this variable and warns you that the trim call may produce null pointer exception. This code is clearly erroneous, no question about it. Probably it was intended to have a return statement inside the if statement body, or some throw exception, whatever. And what if we remove the null check? Can it still produce null pointer exception? Sure, it can, you still can pass null to this method and null pointer exception will occur. But should we warn? Now we don't do this because we don't know the contract of this method. It's quite possible that callers are expected not to pass null into this method ever. And if null is passed, then it's a caller problem, not the method problem. So by default, we don't give warnings in this case. To do such kind of analysis, we should distinguish whether we had a null check or not. This is achieved by assigning unknown nullness to every variable by default, but the variable may become nullable. For example, here after the if statement, we have two states, one when s is null and another with s is not null. When we merge them together, we make s not unknown like it was at method entry, but nullable, which means that null is really expected here. So we need at least 4 kinds of nullness: null, not null, unknown, and nullable. Usually, a variable state represents a set of possible variable values. And it's easy to create an algebraic lattice on top of sets, as lattice operators join and meet can be easily defined in terms of set operations. Abstract interpretation theory is all about lattices. Everyone loves lattices in this field. If you have a well-defined lattice, everything else is relatively simple. However, in the nullness domain, the unknown and nullable states represent the same set of values. Both actually include null, and it's unclear which one of them is a superstate of another and what should be the result of join and meet operations between unknown and nullable. So far, we weren't successful in defining a proper lattice over the nullness domain without introducing tons of false positives or false negatives. As a result, the nullness handling inside our abstract interpreter is full of dirty hacks and special cases. Okay, enough about theory. Let's go back to our process string method. Imagine that we call it with a nullable argument. It's evident that there is an error somewhere, either at the call side or inside the process string method. It depends on the method contract, but we don't know the contract. In some cases, we can guess or infer the contract, and this works here. IntelliJ IDEA simply looks at the process string body and assumes that the process string method is intended to be called with a non-null argument. After all, it dereferences the argument right at the first line, so it warns at the call side. If you want to see the inference result, you can turn on the corresponding options under Editor, Inlay Hints, Java Annotations. After that, the result will be displayed in the editor like this. The hint tells us that IDE will assume in the analysis that the parameter must not be null. Please note that the inference procedure is quite simple because it's performed not only for the methods you see in the editor, but also for every method you are calling. This is not an abstract interpretation. We just look into the method body for some specific patterns. Otherwise, it would be too slow for online analysis. If you want better interprocedural analysis, try standalone static analyzer tools that process the code offline. You can override the inference result if you actually intend to accept nulls. Just type nullable annotation there. Well, of course, you'll need to depend on the annotation package. We have a quick fix to add JetBrains annotations to the class path, but you can select another package. Note that currently there is no single best package for nullness annotations in Java. There is a question about this on Stack Overflow with more than 1,000 upvotes, but for now there is no single best answer. So back to our code. If you override the inferred annotation with an explicit one, the behavior of the analyzer changes. Now the call sites can legally pass the null inside, and the problem is reported inside the method. Because you said that null is accepted, and still you dereference the value without a null check. This way you can actually control the analyzer behavior if you don't like the default one. Okay, enough with nullness. Often we don't know anything about precise values of variables, but we know something about relations between them. Abstract interpreter memory state also tracks pairs of equal and unequal variables. This allows inferring additional equalities and can be really useful. For example, here, if A is equal to B and B is equal to C, we know that A is also equal to C, so we display a warning. By the way, here is another quick. Let's change the variable types from object to string. Now the warning disappears. Why? Because we decided that it's more useful to track string comparison by content instead of by reference. After all, who compares strings by reference? So we get our warning back if we use the equals method instead. And the analyzer doesn't like if you downcast your object variable to string. Because in this case, it should change the attitude towards your objects, stop comparing them by reference, and start comparing them by content. For numbers, we also track relations like greater than and less than, and follow algebraic rules such as transitivity when evaluating the operations. The relations are also used to narrow down the result of some operations, such as subtraction. For example, if we know that x and y aren't equal, we also know that their difference cannot be zero. Great. So far, our analyzer only tracked local variables. What about fields? We can track them as well, as it's shown in this example. But it's not that simple. Let's add a seemingly innocent println call before the if condition. And now the warning disappears. Now IntelliJ IDEA is unsure if the condition is impossible. Why? Because we are calling the method and it may produce a side effect. In particular, it may change the same point object. You may say, come on, how can the println method change the instance of my point class? But in principle, it can. How about this? We can redefine system.out using system.setOut to a custom print stream implementation that changes the p fields right inside the println call. And impossible is printed in this code. Of course, it's unlikely that anybody would do this in real application, but you never know. Well, we could mark system.out println as harmless, but this method is not used much in production code, so we don't care. In any case, when println or other methods with potential side effect are called, IntelliJ IDEA flushes the knowledge about non-final fields. Still, some methods could be called without flushing the fields. For example, here we call math.square_root and we still see the warning. That's because this method is marked with contract pure is true. Contract is a JetBrains annotation, and we tried hard to annotate a standard Java library to avoid too much field flushing. Unfortunately, third-party libraries and user projects are not pre-annotated. To alleviate this problem, IntelliJ IDEA sometimes infers the purity annotation automatically. For example, it works for the static method cube defined here. IntelliJ IDEA understands that the method doesn't produce side effects and implicitly marks it as pure. It's important that the automatic inference doesn't work for overreadable methods. If you have a non-private, non-static, non-final method inside a non-final class, sorry, there is no automatic inference for you, because who knows what's going on in the subclasses. So don't hesitate to mark your classes or methods as final if you don't need any inheritors. In this case, code analysis in IntelliJ IDEA will be more precise. You can also write the contract annotation explicitly. And if you really want, you can even add JetBrains annotations to third-party library methods. For example, let's assume that you call random string utils.random, declared in Apache Common Slang library. It's not annotated and not inferred as pure, but you may assume that it's pure. Well, to some extent, as it changes the state of the internal random generator declared inside the library, so technically it's a side effect. But if it's okay for you, if you don't care, you can. Press Alt-Enter, select Add Method Contract action, and specify that method has no side effects. These annotations are stored in external XML files, so when you are doing this for the first time, IntelliJ IDEA will ask you where to store them. You can freely commit them together with your project and share them with your team. After that, you see that the warning appears again, and QuickDoc shows that the method is annotated as pure. Similarly, you can add other external annotations, such as nullness annotation. There is also another case when fields are not flushed. As you can see, we have a println call, but the condition is still highlighted as always false. We can replace println with any call we want, assuming that we don't pass our point as a parameter. Here, IntelliJ IDEA knows that the object P was created right in the current method, so it's a local object. And whatever side effect our method does, it cannot access P, so it cannot change its fields. Array elements. The analyzer treats array elements as fields, having names 0, 1, and so on. Here we highlight that the result of subtraction is always 0. Well, it's not a constant condition, but we decided to highlight when a complex expression always evaluates to 0. In rare cases, it could be annoying, but often it actually highlights a problem in the code. Unfortunately, elements of Java arrays are always mutable, so we also flush them on every unknown method call. But unlike fields, we also need to flush array elements when an element with an unknown index is modified. Here, for example, I could be 0 or 1, and after array I equals to 10 is executed, the difference won't be 0 anymore. Unfortunately, for now, the analyzer is not smart enough to avoid flushing if you limit the index value. In this case, the assignment will never touch our 0 and 1 elements, but the analyzer is not sure. Also, we don't track in any way unknown array indices. Here, I and j variables aren't modified, so it's quite evident for human that the difference is still 0. However, the IntelliJ IDEA analyzer doesn't know this. Tracking unknown indices is much harder than tracking known ones, so it's not implemented. We also have some support of getters, or more generally pure methods without arguments. Here, getX and getY methods are processed in the same way as fields. For example, if getX returned an odd number at the first check, then it cannot be equal to the even number when called again. Unfortunately, we don't process setters, so if your object is mutable, setters will just flush any knowledge about the object fields. We also track several specific derived values that look important. We call them special fields. Currently, there are array and string length, collection and map size, and values stored inside optional or boxed primitive. Tracking these values allows doing many non-trivial things. We have a kind of internal contract language that can describe the method behavior. It's used to hardcode the behavior of popular library methods. These contracts can use special fields. Here you can see an example of how it looks. The contract for isEmpty method is simple. If the string length is 0, then the result is true, and otherwise it's false. When this contract is processed, we also fork the memory state, like when processing the conditions. So in this example, after the first check, we know that string length is at least 1. For the string char add method, the contract says that the method fails with an exception if the supplied index is less than 0 or greater than or equal to the string length. If you remember the sample from the beginning of my talk, this contract makes that sample work. After the char add call, we know that execution can continue normally only if IDX is between 0 and 3. Another example starts with method. We can be sure that the method never returns true if the argument string is longer than this string. The prefix cannot be longer than the string itself. In this example, we don't refer to the length explicitly, but thanks to the length tracking, we conclude that the second check cannot be true. Again, you can see the interpreter memory state if you select the S variable reference in the nested if statement. The outer condition implies that the string is at least 2 characters long, and so, naturally, it cannot be empty. There are also many methods whose behavior cannot be described by hard-coded contracts, but we still want to have first-class support of them. One example is the math.apps method we saw before. When our abstract interpreter encounters the math.apps call, it just evaluates the absolute value of the argument. There are quite a lot of methods that have a method handler defined. Here you can see some of the methods that are known to the IntelliJ IDEA abstract interpreter and that are specially evaluated. For example, we know that string.indexOf returns a value that is less than string length, but not less than -1. Or the result of collection singleton is an immutable collection of one element. or the result of arrays.copyof is a new array whose length is equal to the method's second argument, and so on. Contracts and method handlers greatly improve the analysis, but this is not enough for modern programming that involves many lambda expressions. Normally, we process every lambda expression as an independent method. The only difference is that we don't start with empty memory state. Instead, we create a closure state based on the analysis of the surrounding method. However, this would not allow us to produce a warning like this. Here, IntelliJ IDEA knows that the result of the previous lambda is passed as an argument to the next lambda. And so, as the trim method never returns null, the condition is redundant and probably erroneous. To make this happen, we have inliners that recognize some widely used APIs, including Stream API, and rewrite the intermediate representation without lambdas. So essentially, when we translate the source program to our intermediate instruction set, we sort of desugar the Stream API calls to the loops. This is done on the fly, and now there are no lambdas anymore. We do the same thing with optional call chains, some map methods like compute_if_absent, and some other standard methods. Don't expect so that this will magically work with your own APIs. We saw that the analysis can be controlled by a number of annotations like nullable and contract. We actually have even more of them. For example, IntelliJ IDEA knows that getDayOfMonth method of local date never returns 0 and shows you the warning. If you take a look at the declaration of this method in the standard library, you may see that it has an annotation displayed that shows the range. You can also use this annotation in your code or as an external annotation to libraries. Another property that can be controlled by annotations is mutability. In this code snippet, you see a warning that the immutable object is modified. How does IntelliJ IDEA know this? This knowledge is possible through two parts. First, the unmodifiable list method is annotated via unmodifiable view annotation, which means that the resulting collection cannot be modified. Next, the list.add method is annotated via contract annotation that it mutates this collection. So the inspection tracks the mutability state of the collection and sees the contradiction. And you can use this unmodifiable view as well. While most of the data flow related problems are reported by constant conditions and exceptions, at some point it became clear that it's too restrictive to require that every problem found by data flow analysis should be reported by the same inspection. So now all the IntelliJ IDEA inspections and refactorings have access to some of the information discovered by data flow analysis. Here you can see the result of two separate inspections. The first one reports division by 0. Before, it supported only constant expressions in the divisor. Now it queries the common data flow, so the inspection provides warnings in much less trivial cases as well. The second warning is reported by redundant operation on empty collection inspection. When we are iterating over the collection, the inspection queries the common data flow for the collection size. Here we know that the list is always empty. So iterating it is not very useful, and it's likely that the code has a bug. Probably a negation needs to be removed. Common data flow may not only add warnings, but also remove warnings. For example, here IntelliJ IDEA warns us that an integer multiplication result is implicitly widened to a long type. It's possible that the integer multiplication will silently overflow. However, if we add asserts on the parameter ranges or check the range in any other way, the warning will disappear. The inspection asks common data flow for the value range, and now common data flow says that variable ranges are so small that the multiplication will never overflow. If you check the range for the whole expression, you can see that it's quite small, so overflow is not a problem here, and there is no need to display a warning. In a similar manner, data flow information is used by dozens of other inspections to reduce the number of false positive warnings. Also, data flow helps quick fixes to generate better code. For example, we have an inspection that suggests using sublist.clear instead of remove loop because it could be optimized by list implementation. However, the proper replacement needs an explicit bounds check, otherwise the sublist may throw an index out of bounds exception if max size happens to be bigger than the list size. However, if the bounds were already checked in any way, the additional check is not added. Of course, this is done with the help of data flow. If the generated condition is always true, it's removed automatically. Another place that benefits from data flow analysis is code completion. It adds automatic casts when data flow analysis knows a more precise variable type. This works even in non-trivial cases like here. We can suggest a cast to the common super type of integer and long. Here you can see object is either integer or long, but in any case, it's a number, so we can safely cast to a number. By the way, remember that the inline stream API calls. This helps for completion inside stream API chains as well. Here we filter the stream elements to strings. Now, in the subsequent map call, IntelliJ IDEA suggests string methods to you and inserts a cast automatically. Another area where data flow analysis is used is the debugger. Here, for example, we have a method that adds some items to the array. From a static analysis point of view, it's probably okay. Probably the caller always checks that the array is large enough to fit all the added elements, so we don't issue any warnings. However, here I started the debug session, and debugger knows the real variable values. So when we stop at the breakpoint, data flow is launched using the known values, and we can see into the future a little bit. Here we see that the array capacity is not enough, and on the last line we will actually fail with array index out of bounds exception. And data flow displays this information right in editor. It's very useful to be warned about an upcoming exception in advance. Now you know that the program state is already wrong and exception is inevitable. Another thing reported by data flow in debugger sessions is always true and always false conditions that aren't available statically. For example, here upon the method entrance, you immediately see which if branch will be visited and which won't. So let's sum up. When you edit your Java code, it's constantly interpreted in the background by our data flow engine. It tracks many things like value range, types, nullability, and so on. You can pick inside the data flow if you use an advanced expression type feature or check inferred annotations. The behavior of the data flow analysis can be controlled using a number of annotations available in the JetBrains annotations pack. Data flow analysis is used in many places. It's not only constant conditions and exceptions, but it's also used in other inspections, in quick fixes, code completion, the debugger, and advanced expression type features. We didn't mention it during the presentation, but it also helps in some refactorings, and it's used inside the data flow to here feature. So it's literally everywhere. Last but not least is that data flow analysis is your friend. So try to live with it instead of fighting it, and it will help you write better Java code. If you see any problems with it, don't forget to submit your feedback to our bug tracker. Thank you for listening. You can contact me via email or on Twitter, and I will be happy to answer your questions.
Thank you so much, Tagir. I learned so much from this session. It was an amazing session. So let me start with, I would say, comments, good ones. So one of the viewers mentioned, this is mind reading. And I absolutely loved how the inspections, they benefit from the data flow analysis, how even the simple casting that we are all used to do benefits from the static flow analysis. Again, how the debugger benefits from it. Our favorite in today's conference, day one. Also tracking the local variables, fields, method, lambda expressions. Oh my God. The list, I have a long list, but I know you've already summed all of them. So, and thanks to moderators that we have on chat, Roman and Ilyas, that already addressed, I I would say, all the questions that were posted by the viewers. So I would just take a couple of those, probably add something that you might want to add, or just other ones which I want to ask a lot of questions.
So our wonderful moderators took away all my questions. Oh no.
They were helping, Tagir. You are being mean now.
Great.
Okay, so in the keynote today, Max mentioned that he was always being told about the data flow analysis, that it was giving the wrong answers when it wasn't. So how many times have you been told the same, that the data flow analysis is giving you the wrong answer when actually they are not?
You mean that the data flow analysis works incorrectly, or I think that it works incorrectly?
Yes, the second one, because you also mentioned about the false positive and the false negatives, and there are a lot of times, there might be a lot of times where the developers would say, no, what I'm doing is right, but what you are telling me is probably wrong, but it's the other way around. So has that happened with
It actually happens usually when I'm testing the data flow analysis, but sometimes when I reach in my own code as well. And sometimes it's like I'm spending even up to half an hour to understand, because, okay, it's data flow analysis, I'm responsible for it. If there is a bug inside data flow analysis, I must understand where it is, I must fix it. Sometimes I even start a debug session, debug the IntelliJ IDEA, and go step by step through data flow analysis, and then suddenly understand, wow, it's correct. This warning is actually correct. My code is buggy, and it's I don't know whether should I dance in joy that data flow is so smart, or should I cry because I'm not that smart and I spent like half an hour trying to understand. And the data flow understands the same thing in the fraction of seconds. So you write the code and you immediately see the warning. But for human, it takes much more. It's actually a problem when computers become smarter than humans, because you cannot actually rate. Computers still make mistakes, but their mistakes becomes more and more difficult to understand. We try to alleviate this problem, and we have the feature called Find the Cause. So if you see data flow warning and you don't understand why it's here, you can press Alt-Enter, and often there is a Find the Cause quick fix. And if you activate it, it can show you some additional information. I may even try to show you it's right in the IDE. For example, yes, you can see it. For example, we can type something like, for example, some condition like this, and it says condition is always false. And if we activate find the cause, it says that value is always false because left operand is 10 and it was assigned here. It highlights where it was assigned, and right operand is 20 and it was assigned here. So you can see where these values come from and understand something, why it thinks so. Unfortunately, this feature doesn't work really well. I'm not very proud of how it works right now. Sometimes it really helps, even for me. So sometimes I don't understand what's going on, but I do find the cause and now I see. But sometimes the explanation is cryptic, or it even fails and says, sorry, I cannot explain this for you.
That makes a lot of sense, and I completely relate with the feeling that you mentioned. Should I cry or should I dance? Whether I'm correct or whether my code is correct. Tagir, which one is your favorite data flow analysis? And a follow-up question, which was the most difficult one to implement?
I always like all the stuff related to numbers. I don't know, probably for some reason I like numbers, but I actually implemented all the math inside the data flow. When I first came to JetBrains, there were no mathematical processing, no range tracking, nothing like this. I implemented mostly by myself, and just because I love numbers and I love to transfer my knowledge about math to the IntelliJ IDEA. And probably the most thing I like in numbers is tracking of modular arithmetics. You saw some simple examples like even cannot be equal to odd one, but it can do something even less trivial. If you have some modular arithmetics or if you have some multiplication, it tracks possible remainders of your values. To some extent, of course, it cannot track everything. And sometimes it jumps to non-trivial conclusion, like this operand has remainder 1 when divided by 3, and that operand has remainder 2 when divided by 3. So they cannot be equal to each other. And this part I like the most for some reason, probably because it's something the most mind-blowing.
Right. I don't remember which slide was. I think that was slide number 6, but I'm not sure. You asked us to guess why S equals no is always false. I still cannot understand why. Could you explain that a bit more?
Yes, I guess it was slide number 6. Why? So the question is why S dot equals no is marked as always false condition. Indeed, we got S from the outside world, so it could be assigned to no. Why not? But let's assume that it's actually no. So the no string goes inside this method. The first condition, if S equals to null is false, we skip it. The second condition, if s.length equals to true, is true, right? No has only 2 characters, so s.length is equals to true. And we go inside the second if, but inside the second if, we unconditionally execute s.substring of 3. And it's also warned, as this call will always fail. So if we pass no into this method, it will fail at the point s.substring 3, and exception will pop out. So if we have no at the input, we cannot reach the last condition s.equals no. That's why this condition is always false, of course, when it's reachable.
That's interesting. Thank you so much. So the next one is, what about the contract annotations like null, false, and others that you mentioned?
I didn't mention them in the presentation. You're right. It's a very interesting topic. You can annotate your methods using like contract annotation. For example, null false. If we have like Boolean method, for example, is non-empty string, and it should have a parameter, and it should return s is not null and not s is empty, for example, like this. So we understand such kind of contracts. There is some kind of contract language, and if we call this method, let's make it static. If you call it like, for example, with null, so the IDE will know that this call is always false because it's by contract. When we pass null inside, it should return false. So no reason to call this method. This condition will be always false. You can use this in your projects as well, and standard library is also pre-annotated, so it works even if you don't use this annotation.
We still have 2 minutes left, and because you were not really happy that the moderators took all the questions, so let me kind of ask the question which they've already answered, just in case if you want to add anything else. So one of the question is, the analysis performed in IntelliJ, is that intra-procedural only?
That's somewhat difficult question. It's mostly intra-procedural, but it does some bits of intra-procedural analysis. First, as you have seen, it knows about some method semantics. So if you call some well-known library method, it may just execute, it may just know what it does and get the result back. It's somehow like compiler intrinsic or something like this. Second, we have contracts, nullability, and sometimes we infer contracts, we infer nullability, and infer something else. So it adds bits of interprocedural analysis. And in some very rare cases, under some specific circumstances, we actually inline methods inside analysis. If we see that some method, like very simple, very trivial, and some other conditions are met, we just inline it so we can analyze both methods together. But in general, it's mostly intra-procedural, mainly because we are doing it online as you type the code. So it would be enormously slow if we do proper inter-procedural analysis.
Thank you so much, Tagir. As usual, always a pleasure to listen to your to view your presentation and learn from them. Thank you so much for your presentation today.
Thank you. I was very glad to present today. Hope you enjoyed it. Goodbye.
Thanks. Bye. Now it's time to add the next host for Helen. Hi, Helen.
Hello. Thank you. That was very informative, wasn't it?
Absolutely. I was kind of blown away by the topics that Tagir was covering. I would not take more time now, and I'll let you invite the next guest.
Thanks, Mala. Okay, so it is my real pleasure today to introduce you to our next speaker, a very familiar face to you all. So welcome, Trisha G.
Hello. My husband is going to take this opportunity to walk in the background. Thanks for that, Isra.
Of course he is.
Like, you know, this is just very 2020, isn't it?
Yep.
You can tell I'm in speaker mode now because I've got my glasses on, so I'm not in host mode.
Is that how I can tell? Good to know.
Yeah.
So yes, obviously you're also presenting at the conference today and you're speaking, so thank you for doing a quick hat swap. We appreciate that. Are you, okay, glasses, fair point. Are you looking forward to giving your talk today?
Should I lie? It's a new talk. It's a new talk. It's always interesting giving a new talk. So yes, it's very interesting giving this talk today. Thank you for asking.
Okay. So by way of introduction, Trisha is a very well-known person in the Java world. She constantly strives to champion the language and all of us that use it as well. She herself is a Java champion, a world-renowned speaker on the Java conference circuit when we're allowed, and last year a published author as well with 97 Things Every Java Programmer Should Know by O'Reilly. So today Trisha's going to be talking to us about the flow in IntelliJ IDEA and how she's learned about that through the various features in the product throughout her career. She's going to be doing a little bit of live coding as well. And I was fortunate enough to get a little sneak preview of this talk. And I don't think she'll mind me saying, even if she does, I'm going to say it anyway, that creating a talk on flow in IntelliJ IDEA is really challenging because flow is very natural. It's quite impulsive. We all do it differently. And taking those concepts and bringing them into the framework of a talk is in itself something that's very difficult to do. But in my view, she's done an excellent job of doing just that. So I won't take up any more of your time. Housekeeping, please keep the questions coming on the YouTube channel. We will, either the moderators who are doing a fantastic job will answer them all. If there are some, we will put them to Trisha at the end of her talk. Finally, fun fact, Trisha, I'm really picking this up now. She actually got her job at JetBrains doing live coding with IntelliJ IDEA. So you're in safe hands.
Thank you. Thanks a lot, Helen.
You're welcome. Enjoy. Thank you.
Thank you. So as Helen mentioned, one of the things I want to demonstrate in this talk is the idea of flow, how developers get in the flow and how IntelliJ IDEA helps them. This is actually a topic I've been struggling with since before I joined JetBrains. So yeah, we'll see how that goes. But before we get there, I'm going to demo a bunch of features. So that bit should be hopefully a little bit easier. So this is basically a talk I've been trying to sort of give since well before I joined JetBrains, and I've been at JetBrains for 6 years now. I was given this T-shirt by Hadi before I joined JetBrains when I worked at MongoDB, and I was a big champion of IntelliJ IDEA because it's just freaking awesome. And what I've always wanted to do is kind of help to demonstrate through sort of effectively pair programming why IntelliJ IDEA is awesome. And that's kind of the talk I want to give today. So obviously I do work for JetBrains, and I am actually the lead Java advocate for JetBrains. So I do a lot of talking about why IntelliJ IDEA is awesome. But I want you to kind of watch this talk from the point of view of Trisha as the user rather than Trisha is paid to be the advocate for IntelliJ IDEA. So this is all about my experience as an IntelliJ IDEA user. So let's go through a little bit of history. Let's find my mouse first and go through a little bit of history. This is my history. I learned Java at university. I was very lucky. My university was very forward thinking and started teaching us Java 1.1 back in 1997. So I've been with it for almost the entire 25 years. Does that say 25 years? Or does it say one of these says 25 years? The 25 years that Java's been around. And back then, of course, as everyone was using, I was using like Vi or some sort of command line editor. I don't even remember. And the command line compiler. I did a bit of a stint doing ASP because like that was the only thing for doing web development back in 1999, 2000. And so obviously I was using Visual Studio. And then like over the rest of my career, I was using a bunch of different IDEs for programming Java, largely Java and web. So I was doing a lot of JSP and web development. I mentioned web development a bit earlier on. I'm not even sure I'm allowed to mention Visual J++. I think that might have been something that Microsoft got a little tiny slap for. But anyway, I used all these different IDEs, including a bunch of time on Eclipse and Eclipse-based projects. My time in 2001, 2002, I don't actually remember which IDE I was using, which is why I haven't actually put the name of the IDE. I think it was Eclipse or an Eclipse variant. But the thing was that, and I used IntelliJ IDEA when I was working at one of the big banks in London. And I was like, oh, this is great. It's, everyone tells me it's great. It's great. It's kind of fine. But I was ambivalent as to the tool I was using for the longest time, because like a lot of developers, I got put on client side or, I got a different job and I was just given a set of tools to work with. And I just kind of worked with them because that's what you do. What happened in 2009 is I joined a company where we were doing pair programming, and I was pairing with people who really knew the IDEs. I was pairing with people who were using Eclipse and IntelliJ IDEA, and so power users of both tools. And I just found that the way to work with IntelliJ IDEA worked better for my workflow. We used both tools as power users. We were both effective, but I just really found that I could hit my flow with IntelliJ IDEA. And after that, I was just basically sold on it. So ever since then, even when I moved on from that company, I just spent a lot of time just trying to tell people why IntelliJ IDEA is awesome. So all of that kind of backstory, if you like, leads me to the fact that I wrote a blog post for IntelliJ IDEA called 20 Things We Love About IntelliJ IDEA for the 20th birthday, for this birthday celebration, which I cheated enormously. I just basically came up with 20 headers and then put like 100,000 million features in there because I love so many things about IntelliJ IDEA. So some of the stuff that I mentioned today is going to be in that blog post, and there's a whole bunch of other stuff which I have not mentioned today, which is in that blog post. But The main thing is that if you want to find out more information, more details, then the blog post will have that. And I'll put this link back up at the end of the talk as well.
Trisha, sorry to jump in. We are seeing some glitches on your slides. I don't know.
I thought it was doing something weird.
It appears to be some sort of refresh related issue, which probably doesn't help you. But
well, oh my goodness. So I'm using well, I'm not going to be using this for very long anyway. So let's you can see that now, can't you? That's okay.
Perfect, thank you.
Great. Oh no, you can't, but there's nothing on there anyway. That's fine. So of those 20 things, I'm going to pick 3 things to talk about, which are the 3 main headers I want to talk about in terms of why I particularly love IntelliJ IDEA specifically as a Java developer, actually. The first point is integration. So I'll cover this in a second. The first point is integration. The second point is intelligence. And the third point, as Helen mentioned, is flow. So let's talk a bit about the fact that it's an integrated development environment. That's what IDE stands for. And it's something we kind of sometimes forget about and take for granted. The fact that our IDE is not just a text editor, it's integrated. So what do I mean by integrated? Well, with IntelliJ IDEA, I mean, it's kind of integrates with everything. But let's start from the very, very basics. Oh, and you can't see that either. So why don't I try and move this? It says compile, run, and debug anyway. I don't know why I use slides. I'll just go straight in. So an IDE generally will be integrated with the compiler. And so it will also allow you to compile your code, to run it, and to debug it, some of which we've seen today already anyway. Which seems like something we should take for granted. But in the keynote, Valentin mentioned that actually the very first version of IntelliJ IDEA didn't even have a debugger. So that was kind of interesting. Now it does. And as we saw in the second session today, the debugger is like really fully featured. So the good thing is I don't have to talk much about the debugger. What I can do is I can show that I can compile my code. Honestly, like I'm not sure anyone actually knows what the keyboard shortcut is for compiling the code, because usually IntelliJ just does it for you. But you can compile an individual class file. As I mentioned, you don't really need to, because the editor will basically tell you if something goes wrong. So you don't need to compile your code. It will just tell you that's not right. I can run it. By the way, at the bottom of the screen, you should be able to see the keyboard shortcuts that I'm using for doing these activities. So I'm not going to call out the keyboard shortcuts. So I can run it and I can debug it, which, like I said, we saw a lot of the debugger this morning, which saves me a lot of demoing. I can debug it here. I can use F8 to step over. I can see my variables in here. I love the fact that you get the sort of comment style variables here. I can do things like, I don't know, I'm not even going to show these things because we have a whole hour-long session on this particular topic. But I can debug this sort of thing here. And yeah, so this is kind of the absolute bare minimum I expect from my IDE. I expect to be able to compile and run my code. I can see that my screen is still not really sharing properly. I've got some kind of weird artifacts here. That I mean, honestly, I share my code so much on the I don't even know why in this particular instance it's deciding, no, I'm not going to do that. Well, let's see. Let's see how this goes. At the moment, it's kind of fine. I'll just keep an eye on it. Compute tools. No, it says build tools. This is just really irritating, isn't it? Let's see. Well, that's even worse. Okay, well, never mind. I will just read out the headings as we get there. Build tools. So as part of the integration, it's fully integrated with the major build tools, particularly for Java. We're talking about Maven and Gradle. This project has a POM file. So I can go to my POM file. And let's just give some like tiny examples of the integration. So for example, it's pulled in all my external dependencies, so I can compile against them. I remember in the olden days when I used to have to go hunting on the internet for a jar file to like add to my local dependencies. Gradle and Maven have made this significantly more easy. So also my POM file has code completion, so I can do things like change the version numbers. I can refresh this, and so it should see this version number go to 0.0. So yeah, I just get full integration with my build tools. The IDE will not only use the build tool to pull in my dependencies, not only use the build tool to build and run my application. So for example, let's open up my Maven window. I can use the IDE to run the clean, for example. but it also understands the project structure that the build tool is going to depend upon. So Maven and Gradle both have a very similar project structure where source main Java is my production code and source test is my test code. So the full integration means that I can make changes to my build file so that my project builds correctly in continuous integration or external environments. And the IDE will just use all of those settings to kind of do all the right things. So that makes my life a lot easier. Next point, this does say version control systems. This is insanely frustrating. It sort of says version control systems. So this is one of my favorite features. Actually, we have a talk later on today about version control systems. I'm really hoping I don't have to go into anything in any detail because we've got a whole bunch of talks. So here, this is a Git project. My Git window will show me things like my local branches, my remote branches, my Git history, my Git log, which you can just about see here. Let's see if I can get it to refresh itself. This is insanely frustrating. Right. I'm just going to take a second to see if I can share it on a different monitor, if this is going to make things a little bit better. Hold on a sec. Okay. Let's quit that. Let's quit that. Let's move this onto a different monitor. And then let's share a different monitor. First, I have to find out where has StreamYard gone? It's here. Okay, so I need to remove this and then share a new screen. But the professional developer advocate, you don't do lots of development, you do lots of debugging technical issues in terms of sharing screens, etc. Right, share my screen, pick a random number between 1 and 3. I'm going to say 3. No, that was the wrong random number. I'm going to say 2. Okay. Now let's try this. Okay, let's see if this is any better. Did I share my screen? Add to stream. Well, it's not much better. And now I'm going to be looking sideways. But whatever, let's just get on with it. It's going to be fine. What could go wrong? Okay. That's a funny resolution. Okay. Quick, someone start talking so that I can debug this problem. I'm just going to put it back on the other screen.
Okay. This is because I said about, live coding and you being in safe hands, right? You can completely blame me.
This is my fault for being like, oh, I don't need a tech check. I've done this thousands of times. It's absolutely fine. And then deciding to do things like buy a new mic, which didn't work, buy a new camera, which didn't work, and try using a new light. You know what? Maybe I'll turn the light off. Maybe that'll make everything better.
Oh, that will definitely fix it.
That will definitely fix the problem. So
we've had various suggestions. I'm sure you can see many of them, but I'm sure you're also trying all of them. So I won't sit here and reel them off.
I'm just gonna go with what's happening. I don't want to mess around too much because we're just kind of short on time.
I agree.
Trisha, do you want to close some of the applications that you have running? Probably.
I've closed everything that I can close. That's why I can't see the comments on YouTube. I closed off Slack. I've got everything closed. It
looks good at the minute.
We're just going to have to go with this for now. I'll keep an eye on it, and we'll go with it for now. But thank you.
Thank you.
If I have to move stuff around and whatever, I'll just kind of go with it. Right. Where are we? The terminal window. I wonder if it's because I'm using multiple, I'm switching. Doesn't matter. So worst case, even if you don't have full integration with the tool of your choice, you can always open up the terminal window and you can even use the integrated terminal window. Now, I use this a whole bunch. So, for example, obviously, I can do, if I want to do stuff from the command line, I can. But also, if I want to, I'm a bit worried about the fact that those files have changed, but that's fine. If I do decide to do something like, let's say, Maven clean install, which should work from the command line, provided I've got the right version of Java set, you'll see that this highlights it in yellow. Now I can press enter, and that will just run it, which you can't see very well, but it runs, and it fails, probably for the right reasons. Oh, I know why. I need to go into standard Java. This is insanely annoying. There we go. So Maven clean install. And then that should just run it as if I'm running anything from the command line. You don't need to see the details. You just see it's running something from the command line. But what's really kind of interesting about this is that it did highlight it in yellow to say, you know, you don't need to run this from the command line. You have full integration inside IntelliJ IDEA for this. So then I can do command and enter on the Mac, and it will open up that command inside IntelliJ IDEA. So IntelliJ IDEA will kind of point you to the integration points inside the IDE. Okay, so next up, let's look at databases. I really wanted to show database integration. Dalia has done some really cool videos on Hibernate and JPA and things like that. So she covers some of the database integration on the videos on this very YouTube channel that you're watching this on. But I wanted to show some of my favorite features. So for example, we can have a look at the database which is running. I've got a MySQL database running. I actually had to use Docker to get this working, which was a new skill for me, so that was interesting. Also helped by the way, IntelliJ IDEA's integration to Docker, which was kind of fun. Do you like my password? And so then I can kind of look at these databases. I can close that off there. Let's get rid of all of these here. So I can look at the values of the database. Now, as a developer, as a Java developer, I quite often, I want to be able to dive in and out of the database, but I'm not doing like heavy duty database stuff. But I do want to be able to see what do the tables look like, what are the tables which are there, and kind of maybe I want to poke some data in there, particularly for testing. And in the past, I've always used an external tool for that, but now I don't need to do that because IntelliJ IDEA Ultimate is just going to have all of that built in. Even better than that, if I go into one of these classes, for example, let's see if I can get it to refresh. There we go. Let's do that. And let's say I've got a string, which is a SQL string inside my Java class. This can be treated as a string, or I can do language injection. And I could say, let's inject MySQL into here. And then I will get code highlighting and code completion. So, for example, let's duplicate this and change this. SQL, I'm going to call it SQL2, like every good variables are called. I'm going to inject MySQL. And then let's see, I get code completion. So, I get code completion. Live demos, man. Like, who does live demos? There we go. So I can say Sakila.film actor, where actor ID equals whatever value I want to put in here. And then what I quite often want to do as a Java developer is I kind of want to try out this query. So I can actually, I can run it. Oh my goodness, I'm completely losing my point of view now because I've been so derailed by everything. That's why flow is important, because if you're in the flow, you can figure out what you're doing. So I can run this query in the console. I can run it in a new session, and then it'll ask me for the parameters. So my actor ID, let's put 1 in there and execute that. And then I can run that. It will show me exactly what I'm running. It will run it in the console and give me the results. The output is here. So this is my one thing. So it's full integration across the board. And this includes things like other languages. I don't know, there's just so many things. It's just, I can't even mention them all. So other languages, I get all the integration. So I can have HTML in my project and JavaScript and so on and so forth. So that's kind of, I think that's, to me, one of the most basic fundamental things, if you like, about IntelliJ IDEA and why it's good, because it's a fully integrated development environment, integrates with everything that I as a developer am going to want to need. And if it doesn't ship it out of the box, I can have plugins which are going to give me the functionality I need, probably, or I can build my own plugin if I want to. So the next point I want to cover is intelligent. Now, we've already seen a bunch of this today. We've seen intelligence in the form of what the debugger can do for us. We saw Tagir's really cool presentation about data flow analysis, which was just mind-blowingly clever. I'm not sure I followed half of it, but I'm glad that IntelliJ IDEA is that intelligent so that I don't have to be. So let's take a quick look at some of the features that I think make IntelliJ IDEA an intelligent IDE. The first one is inspections. Inspections, I said it earlier on in the chat, inspections are, I've lost my window. Inspections are probably my favorite feature in IntelliJ IDEA. I love that the IDE is going to give me, is going to warn me about stuff that's perhaps not quite right and give me suggestions on things to do. So let's take a look at what some of these are. I've got a whole bunch of stuff in here called inspections. This code, by the way, it is on GitHub. It's under JetBrains/IntelliJ samples. I can share a link afterwards. So you can download this code and just play with it as much as you want. So the inspections, here's just a really small set of inspections. So for example, it'll say things like, this is empty. So there's absolutely no value in this code. It's a fairly simple one, but it's quite nice. Not only does it tell you, well, this is probably a bit of a smell in your code, it also gives you some suggestions. For example, you can just simply remove that statement because it's not doing anything. Similarly, you can have things like this one says, this is a redundant escape, so I can just remove that if I want to. What else? I have some, oh yeah, so anything where we've got some gray code. This is kind of interesting one because I'm using integer.compare and so this is an int value. Sorry, I meant to overlap that. That's an int value. This is an int value. So this is kind of IntelliJ saying, oh, you don't really need to do that. So if I press Shift 2. It's a redundant call. Okay, that's redundant. What does that mean? I'm going to Alt-Enter and say, yeah, whatever it is you think is the right thing to do, then do that. And it simplifies my code for me. So this is definitely one of my favorite features inside IntelliJ IDEA. Something else for inspections. Sorry, I've got to bring up my list of things to do. Inspections. Oh yeah, I'll come to some more inspections a bit later. So the other thing which is kind of related to inspections, and to be honest, I was never really clear about the difference between the two. I don't think you have to be, but it's worth covering, is intentions, which are kind of similar to inspections, but not quite the same thing. So let's take a look at some intentions. Intentions, let's look at Boolean intentions. So inspections were where IntelliJ IDEA is going to say to you, look, I don't really think you want to do this with your code. This might be an error, or you want to do something a little bit different. Intentions, if I press Alt-Enter, intentions are these, that they're not errors, they're just things that we could do to the code, different ways to shape the code if we want to. So for example, here, I might want to, let's have a look at this slightly weird bit of logic. Let's see what happens if I replace the and with an or. Okay, well, that's okay. What happens? What else could I do? I could invert the if condition. Okay, so since this is a not, then perhaps inverting it might help. So let's invert it. I think that makes it a little bit more readable. So I can use intentions to kind of reshape my code in slightly different directions to see if it makes things a little bit easier for me or not. My favorite set of intentions are around loops. So if I go to loops, loop intentions, they're fairly straightforward, really, quite simple. But if I press Alt-Enter on a for, it'll give me a bunch of options on different things I could do with that for loop. Now, this might be fine because I've just got a list of values. I'm going to loop over them. But maybe I might want an indexed for loop because maybe I'm going to use the index, the I, for something else. Maybe I want to print out my index because maybe I'm not using the debugger, and maybe I'm using system.out.println to debug my code. But basically, that's the interesting thing about intentions. And in actual fact, an inspection then pops up and says, oh, maybe you don't really need this indexed for loop because you're not using the I, so you can replace it back. Similarly, you can do things like reverse the loop. So I can reverse direction of the for loop if I want to. Sometimes you might want to do that. Sometimes counting down to 0 is more performant than counting up to an unknown number. So that's kind of interesting if you're into micro benchmarking stuff. So intentions is a really nice way for, I've written my code, it looks kind of fine, or it does what I want, but I'm not really sure about the readability of it. What does IntelliJ IDEA suggest that I could do to perhaps change the way this code looks? That's intentions. This is new language features. New language features, so I can use inspections to help me use the new language features in Java. Now, any of you who've seen Mala and I presenting in the past have seen us use this a bunch of times. So this probably won't be new to you. And given that Java 16 is coming out on the 16th of March, you'll get to see a whole new bunch of language level migration aids in a couple of weeks' time. So you can't see anything right now because my screen is really interesting. So I'll start with some of my simple favorite ones. So for example, there's loads of Java 8 inspections. I literally learned how to use Java 8 by getting IntelliJ IDEA to tell me what I could do. I did not know what a lambda expression was or why it was better. So I would write stuff out like this, like an anonymous inner class, to figure out what I wanted to do. And then I would get IntelliJ IDEA to replace it with a lambda. I'd be like, oh, okay, that's a lambda. Great. And I could do things like say, I don't need, where is it? Remove redundant parameter types. I don't need that. That's fine. And then down here, I can do things like replace it with a method reference. I remember in the early days of Java 8, I'm like, I don't get what a method reference is or how I should use it. But IntelliJ would be like, well, this is how you use a method reference in this context. And oh, okay, I get that. I'm sorting this array. I'm comparing the values by while ignoring their case. Okay, that seems more readable. So I really like the way that IntelliJ IDEA helps me to use the new features of the language. So I don't necessarily have to go away and read about new features of the language. IntelliJ will just say, did you know that somewhere around here you can use var, for example? Can I find an example where I can use var? Let's see. Not here. But yes, it'll suggest a bunch of things. Oh, another one. Switch expressions, which came in I want to say Java 14. It's definitely there in Java 15. And I can replace a standard switch statement with a switch expression, which is much more compact. And then I can get IntelliJ to say, oh, okay, let's inline that because I don't need that anymore. So I'm just going to use IntelliJ's intentions and inspections to migrate my code to a more current version. If I'm using, for example, Java 15 here, I'm going to get it to simplify the code if it makes sense to me. Maybe I might be like, well, I don't really understand this because I haven't used the new switch expressions. And so maybe I might want to replace with the old style switch statement. So I can get IntelliJ IDEA to kind of move my code in different directions while I, as the developer, make those human decisions about what is the best approach here. Detect duplicates. This was mentioned by one of our users. They love the way that detect duplicates works in IntelliJ IDEA. So I wanted to call this out specifically because it is kind of cool, actually. Detect duplicates. That's called duplicate. No, it's not. Where am I? I'm in the wrong project. That's not going to help. It's because I'm not using full screen and it's completely throwing me. Duplicate code inspection. So here, let's press 2. IntelliJ IDEA is telling me this is a duplicate. I can do things like show all the duplicates because I want to see, okay, it's a duplicate of what? Well, of this and of this. Fine. And then I will get it to extract the method from the duplicate code because, as we know, many of the refactorings were in right from the beginning. Being able to automatically refactor our code inside IntelliJ IDEA is one of the coolest things about IntelliJ IDEA. So I will extract a method. I'm going to call it build string. And then it will replace both sets of duplicates with the call to the method. So that's a cool thing, because sometimes you don't even, what's the coolest thing is when those duplicates are in different files. When they're in the same file, you can often see them, but when they're in different files, you don't necessarily know you've got duplicate code. So it's nice that IntelliJ IDEA goes, well, this looks like it's more or less the same. And I don't know if you noticed, but this is a different name to this, and this is slightly different to this. But IntelliJ can still go, well, it's more or less the same. Let me see what I can do to try and make it into a common piece of code that we can call from both places. Which brings me to refactoring. I'm not going to go over all the refactorings. I'm just going to go over some of my favorites. Are we running out of time? Not yet. Great. So let's go to extract method. So I might want to extract something like this. And here, I don't know if this is going to work. I should have pointed out right at the beginning, I'm using the early access version of 2021.1. Early access versions are amazing. I use them all the time. Sometimes you get some unusual usability issues, which I'm really hoping not to run into for this one. I'm sure it'll be fine. So I'm going to extract a method, and then, so it extracts the method. This was the inline method extraction we were looking at earlier in the usability session. So I'm going to call it, let's see, I don't know if I'm going to call it something because I'm not sure this is working in my current build. Loop over steps. And then it goes, look, this is really similar to the code you just extracted. So do you want to use your new method there? And I say replace. And so it does that for me, which is amazing. And in our case, the two methods were actually, they were fairly similar, but there are loads of cases where the code is not that similar. But if we extract the method, IntelliJ works out, well, actually, if I add this extra parameter, then I'm going to be able to extract a bunch of these other duplicates into that one method. And that looks like magic. That's really, really cool. I'm also going to talk about variable, introduce variable. People trying to talk to me over the chat at the same time. I'm not going to answer your chat questions. So I might want to extract a variable here. So if I extract variable, the naive approach would be, well, but just IntelliJ IDEA will just extract the variable within this scope. So it'll just extract orders.size inside this else block. But IntelliJ IDEA says, actually, do you want to do that? Or do you want to do all of them inside the first if statement? Or do you want to do everything in the whole method? And it will also highlight what are the implications of that. Am I just going to replace just these two or all 7 here? And so I'm going to say actually all of them because it's the same thing. So I want to extract that in all places. So introduce variable is I think it was mentioned, who was it mentioned earlier on? I think it might have been Max, said that these refactorings are not really refactorings. These are just the way you code. You code a bunch of stuff and then you go, oh, let's pull this into a method. Let's pull this into a common variable. And so this becomes part of your working flow as you go along. This is not something that's an afterthought that you do afterwards when your code's got too messy. Okay, refactoring. Now, data flow analysis. I'm not sure whether I'm disappointed or happy that Tagir did like a whole talk on data flow analysis, so I didn't have to go into it very much. So I don't have to do any of the clever demonstration, but I do want to say that data flow analysis is one of the coolest things about IntelliJ IDEA. So let's have a look at data flow analysis. And I've just got I've got one of the less complicated ones. I guess this is probably code that Tagir wrote because it's one of the numbers stuff and he was saying he liked doing the math stuff. So here, IntelliJ IDEA says to me, value equals 3 is always false. So it knows that by the time we get here, value can never be 3. And I really love that because then I don't have to reason through it. When Tagir was talking about it in his earlier presentation, and we were talking through this kind of complicated if statement, I think about all those times I waded through some if-else statement to go, okay, it's less than 2 characters, but it's more than 97, but it isn't a type of object. So what is it by the time it gets here? Well, I don't have to do that because IntelliJ IDEA does that. It goes, well, I'm a computer. I can do that stuff. And I will tell you that at this point, it can never be 3. And why is it never 3? Find cause. More or less says find cause. It says the left operand is in 5 to 75. The range is known from line 24. Because it can't be, it's not going to be between 10 and 25. It can't be less than 0. It can't be less than 50. It can't be more than 75. So it's between 50 and 75. So yeah, you're right. I don't need that. I can just get rid of that. And then also it's worth mentioning if I press Control Shift P twice, which I can never remember, Control Shift P, Control Shift P. Yes, that one twice. Then I can get the data flow analysis to tell me what values this variable called value is. That's really helpful when I'm trying to figure out, okay, at this point in my program, what can I expect these values to be and what can I realistically do with them?
Trisha?
Yes.
Just a suggestion from the team here. Maybe don't keep switching to your PDFs. It might help with the refresh issue. It might not, of course. We're just brainstorming, trying to come up with something.
The problem if I do that is I don't remember what I'm going to do. But the good thing is actually, no, it's perfect because I only have 2 more slides. So we will see. But I was actually thinking that the switching was probably helping to reset the screen. But whatever, we've got 2 more slides. Let's see how it goes. Context is queen. It's not king because I'm a girl. So, oh, sorry, a woman, not a girl. So the context is queen. By which I mean Alt and Enter is the context-sensitive information. IntelliJ IDEA has the context of everything at the place where you are. And that's one of the things I love about working with IDE. It doesn't go, well, you know, it could sort of maybe be this, maybe if you want to. You're like, no, it can't because I'm in this place. So it knows the context. It knows your environment. It knows a lot more about your code than you do. And that's really cool because then you don't have to worry about that stuff. It just gives you relevant context at that point in time. Okay, let's go on to the more challenging bit. Oh dear, which should take about 15 minutes, but we will see how we go. This is about flow. So we talked a bit about this at the beginning of the presentation. I've always wanted to demonstrate flow, how IntelliJ IDEA helps you get into the state of flow. And the thing is that I've always failed at this in a demo, in a live demo. And I realized this week it's because it's impossible to demonstrate in a demo because flow takes like minutes, half an hour maybe to get into the state of flow. You know, you've got to set your context up. You've got to kind of be in the zone. And that you can't do that in a 50-minute presentation. You can't sort of like just start coding for 15 minutes to get in the zone. So any sort of demonstration showing the state of flow, being in the zone while coding in a live presentation is going to be a little bit artificial. So the live demo I'm going to be showing obviously has been practiced and I'm not really in the state of flow. I sort of am, but I'm not. But what I want to do is just kind of show you how kind of zen it can be if you're using IntelliJ IDEA and some of the capabilities. As you start writing the code, you don't think about the mechanics of writing the code. You're thinking about what you want the code to do. Now, we're going to do this with an example, which the slide, of course, is not showing properly, a Sudoku. So what I wanted to do, I created a toy app ages ago where I was thinking about what's the data structure of a Sudoku grid. So the Sudoku grid has like numbers of 1 to 9, and there are constraints around what's allowed to be in which part of the grid at which time. Those details are not necessarily that valid to understand the demo, but that's kind of where we are. So what I wanted to do is I'm going to create a brute force random generator for a Sudoku puzzle. It's going to generate one of these things in the bottom right hand corner, the empty puzzle. And so we're going to try and do that live in IntelliJ IDEA. I'm going to keep an eye on the screen, see if we don't get too messed up with the resolution. So this is my generator test. I'm going to do this with test-driven development because I like doing TDD, and also because I find that doing TDD is really well supported inside IntelliJ IDEA, because I'm going to think about what it is I'm trying to achieve first and then write the code for that afterwards. So let's kind of just get on with that and see how we go. I have a live template to create myself new JUnit 5 tests. So here, The first test is I need my generated puzzle to have at least 17 items. Apparently that's a criteria. I read it somewhere. So let's make a test. Should have at least 17 items. Okay, cool. So now I've got a test. Let's do new generator. I'm not going to talk that much about the IntelliJ IDEA features unless they're really interesting, because the whole point is to talk about the flow, like what I'm trying to achieve. But I am going to use postfix completion because postfix completion is cool and I like it. So I'm going to create a new generator instance there, and I need to do a matcher, assert that. I'm using Hamcrest for this because you'll see why in a minute. So I want to say the generator, I need to get the puzzle from the generator. So generator, get puzzle. And you're thinking, why isn't IntelliJ IDEA offering code completion? Well, I don't have one of these yet. I don't have one. So I know that I want one because I want my generator to create a puzzle. So I just get IntelliJ IDEA to create my method. This is going to be a grid because that's the name of the class. I'm going to do the absolute bare minimum to get it to compile because I'm in the flow here in the test. I'm trying to create the shape of the test. So I want to make sure that the number of filled squares matches less than, I want it to be less than or equal to, no, greater than or equal to 17. So I want the number of squares from this puzzle to be greater than or equal to 17. And I need to use Hamcrest to express that. I like to put static imports in here so that when I read my code, I'm reading what it's supposed to do. I want to assert that the number of filled squares is greater than or equal to 17. Okay, so I'm going to run this test. It should fail because I haven't done anything yet. Okay, so it fails because I've got a null pointer exception. Great. I'm using Java 15, so I've got helpful null pointer exceptions, which says the return value of Sudoku generator get puzzle is null. So I could do a number of things here, but I could actually do search everywhere to go straight to the problematic method. Okay, that's not really a surprise. It's null because it returns null. So let's return a new grid. Let's rerun our failing test, and then let's see what's happening. Great. So we have an error that it's expecting 0. But it's getting it's expecting to be equal or greater than 17, but I'm getting 0. That makes sense because my grid is empty. Just created a new grid. So now what I want to do is now I'm thinking about the business logic to make this test pass. So let's put this into a field, let's say. Let's enable it. Let's initialize it in the constructor. So now I've got a field. And then let's set some values in here. So I'm going to set some value. This is a row. Let's say row 1. This is a column 1. I'm just going to put like the value 1 in position 1, 1. I'm going to static import these because I don't need all that text in the way. And then what I'm expecting, I'm going to press F2 to fix these problems. Okay, F2. Let's make that final, because I don't want to change that. So let's think about what I've done. I've created a grid. I have set one value in there. So I'm expecting when I rerun this for this to be 1 instead of 0. So let's rerun it. And it fails, and it's still 0. Well, that's interesting. Why is that 0? So let's take a look at my test, and then let's go in here to find out what value is coming out of here. Actually, I could debug it, but I'm not going to run through the debugger because we've already had a talk on the debugger. And look, it returns 0. Oh, that's interesting. So that can't be right because it's always going to return 0. What I'm going to do is I have a test for this, and I'm going to test drive that. It's not really so important to know the details of the test. The point is I'm just going to use it to remind me of what it is I need to do. I need it to, like when I add 9 values to the grid, it needs to tell me there are 9 values in the grid. So let's run this. Oh, it's disabled. Yes, so that's not going to run. So I'm going to run that. And of course, 0 passes, but none of the others pass. So let's go in and make it pass. Let's go into the right place and make it pass. So what have we got? The grid has a series of rows and columns. Now, I think I know how I want to implement this. I need to iterate through all of the rows and count up all of the values in all of the rows. Okay, so let's start by saying I want to iter. What do I want to iterate over? Oh, look, all of the rows. Great. So I don't have to think about that. IntelliJ just goes, okay, this is something you can iterate over. Now, I want to iterate over all the values in the row. The row has 9 values in. Okay. Oh, IntelliJ says, oh, great. I'm probably going to want to iterate over that row, all the cells in the row. Fine. So now I'm going to use, I'm going to create an if with complete statement, which is one of my favorite tips, which I learned off Hadi. If the cell, what have we got here? We've got is empty. That's a Boolean. That looks cool. So I actually want to say if it's not empty, postfix completion, then I'm going to add something to the count. Okay, right. I don't have a count. Let's create a count. Let's make it compile. I will come to that in a minute. Let's return the count, which IntelliJ goes, oh, no, you don't have one of those. Why don't you bring the int count into scope? All right, you do that. That's what I want to do. Now what? And then just get it to initialize it to. Great. So I don't have to type all this stuff. I don't have to think, what's the variable I need to start with? What does the for loop look like? What does the next for loop look like? What am I returning? I go from sort of inside out. I'm going to iterate over these, count them up. Okay, now get IntelliJ IDEA to create the code which is going to make that happen. So let's rerun this. This should probably work. Oops. EAP. Oh, it's our first error on the EAP. Great. So this passes. So then what we want to do is I'm going to use run anything. I'm going to run my original generator test, which is still failing, but it's failing now for the right reason. There's only one of those. So now let's go in and fix our generator. What do we want to do? I'm going to use another live template. I'm going to iterate for less than or equal to 17. So because we said we needed to have at least 17 items, I'm going to move this inside here, but I can't just set the value at 1, 1, like 17 times. That's not going to be very helpful. So I'm going to create a random column index, a random row index, and a random value to put into the grid. Let's do that. Let's start with new random. Let's just assign that to random. Oh, that's right. My screen is now absolutely fine. Let's have random dot next int. I want it to be between 0 and 9. Random next int between 0 and 9. What have I done wrong? Oh, row index. Aha. Thank you. Thank you, IntelliJ, for telling me that I was being a bit dumb. Because it's not the row, it needs to be in here. Random, next int mount. Look at that. So it's giving me suggestions that match what I'm going to want to put inside here. So random, next int 9, next int 0 to 9. And I'm going to cheat because I know the answer to this. This actually needs to be between 1 and 9, not 0 to 9, not including 9. So I need to add 1. Now, I'd test drive that, but I don't really have enough time for that. So let's rerun this and see which error we're going to get now. Oh, look, an error. A duplicate value exception. I'm brute forcing my way, putting a bunch of stuff in here. So I'm going to need to handle this duplicate value exception. I'm going to do that by surrounding this with a try catch. I know that I want one of these. Let's import that. But I'm actually just going to ignore it here because I'm going to brute force. I don't really care if it's duplicate value. I'm going to try again and try again until I've got 17 values in my grid. Let's rerun that. Now that's weird. I only have 15, but I did say loop 17 times. So that's kind of weird. Oh, I had a good fix for this. If we go to edit configurations, let's run this test, repeat tests. Let's run it 10 times. What did I do? Oh, that's cool. Cool, never mind. Just do run anything, it works. So that's interesting. I ran the same test 10 times and it's non-deterministic. Sometimes it passes and sometimes it fails with different numbers. I like this run multiple times because it gives you some interesting clues. Now, the fact is I'm adding random numbers into random indices. So sometimes those numbers are going to be overwritten with a new number. So what can we do? We're going to use intentions. We're going to replace the for each with a while, and we're going to change it. And we're going to say grid dot get number of filled squares is less than 17. Now what? Now I don't need that, so I just get IntelliJ IDEA to remove that, and now I just rerun my test. Ta-da! Everything passes. Oh, thank goodness for that. I love it when everything passes. So yes, so we are fortunately, I say fortunately, we are running out of time. So great. I might just do a really quick summary of some of the features that I used there. First, oh, you can't see any of this. I'll just read it out. Firstly, using the keyboard everywhere. So I'm not using the mouse. I'm not context switching. I'm just constantly doing everything from the keyboard. We saw code completion in use. We saw postfix completion, which is a really quite cool way of doing stuff. Complete statement. Code generation. Oh, I didn't really do code generation, but I quite like code generation for things like toString hash code equals getters, setters, things like that. Refactoring as you go. So extracting variables. I extracted one of the things into a field and then initialized it in the constructor. Inspections and intentions, which I use quite a lot, especially get the code to pass or get the code to do what you want, and then use inspections and intentions to fix potential problems or to reshape the code. You saw me, this says TDD loop. You saw me kind of doing the test-driven development way of doing stuff, and IntelliJ IDEA makes that really straightforward and really nice to work with. Which means you can create the API as you use it. So right at the beginning, I said generator.getPuzzle because I knew I needed a get puzzle, and I can drive that API from the outside in. So the API looks the way I want it, makes it easier to use. Run anything. Run anything lets me not have to move to a particular place to run anything, which I did use. I can stop everything if I want to. I can search everywhere. And yes, and finally, oh, good, the one slide we could, there we go. If you want to see more information about these or any other features, please go to the blog post because I wrote about them all there. And I really hope this link shortener works so that you can actually navigate to that URL. Otherwise, everything will have been in vain. Any questions?
Thanks, Trisha. That was a very informative talk. Obviously, apologies to the audience. You were all incredibly understanding. We did have some technical issues with Trisha's screen sharing. Trisha, there's a couple of questions for you in StreamYard that it would be worth reading just whilst we've got a couple of minutes.
Okay.
But yes, thank you for being understanding because I do appreciate there were some issues with that presentation there. I do have one question for you, Trisha, in the couple of minutes that we've got. Your talk today was on the flow of IntelliJ IDEA. Why is that so important for developers?
It's like anything creative, or not even creative, because when I'm running, I find flow really helpful. The state of flow can really help you. Like being in the zone helps you create something that is much more difficult to do when you're context switching. So flow is really about trying to remove distractions, trying not to jump from thing to thing, not like this conference where we're trying to jump from thing to thing. Just being able to focus on the problem at hand. And that, I think, there's a few reasons why that's really helpful as a developer. One, it's very difficult to load so much context into your brain. That's one of the reasonings behind moving to microservices from monoliths, because then you can only reason about one thing. So if you're working on one thing at a time, then you can solve that particular problem. I'm not really answering this question very well. It's important, dude. It just feels good to be in the zone. Like when you're flowing, you can kind of get that answer you didn't think you were going to get. And when you get distracted, it's when you get distracted that you realize you are flowing. And when you get distracted, you're like, I had this tower of cards in my head and that's all fallen down because I alt-tabbed into my email and now I don't remember where I live.
exactly what just happened with that talk, right? But everyone has been very supportive, so thank you for that. Right, Trisha, without further ado, you can take your presentation glasses off, or rather your speaker glasses off, put your presentation hat back on, because I am going to hand over to you for the next part of this conference.
Great. Yes. So there's this gives us a really good opportunity to share something with you all, with the audience. We have a brand new tool from JetBrains, which we really want to show you a short video for this tool. It's a new tool called Space.
Starts with people and teams and goes all the way to the whole organization. To connect everyone, introducing JetBrains Space, an integrated team environment. It contains chats, blogs, wiki, planning, issues, version control, CI/CD, automation, packages, company structure, permissions, meetings, absences, and more. All in one. Space ensures synergy across all areas, helping you eliminate duplications, distractions from extra notifications, and context switching. The team structure is fully integrated. When you add teams to projects, all members automatically get access to all project resources. You get all notifications in one place, code review updates, newly created issues, new blog posts. You get all of these in chats, and react in place or add them to your to-do list automatically. Connect the JetBrains IDE to Space and check out your project, see who is editing the same file, and get notifications muted when you're debugging. With a self-service approach, start new projects in no time without any assistance from your IT team. Space is a platform that can be customized and extended to meet the unique needs of your organization. Imagine how many things you can build on top of it, having all data inside Space. Space is available in the cloud or on premises. You decide. Whether you're a super boosted startup, a fast-growing company, a business with remote and distributed teams, or a giant enterprise, you deserve your own space. By JetBrains, the creators of IntelliJ IDEA and Kotlin. Space is closer than you think.
That was just the video I wanted to see after my talk. That was kind of nice and chill. I wanted to mention before we move on to Dalia's session is, oh, well, we haven't introduced Dalia yet, is we have been using Space at JetBrains for some time, and I do recommend you take a look at it. It's offering some really cool and interesting features. Hi, Dalia. How are you doing?
Good. How are you after that hectic... You handled it very well. It's kind of difficult when you don't know what's wrong to like handle it all. So
I'm a pro. It's fine. I'm just going to go off and drink a liter of gin now. But, I'm good. I'm really glad to see you online, Dalia, because you are obviously on a different time zone to us. So you are nice and fresh to the conference, and you can take over for the afternoon.
yes, I am still waking up, but I'm here.
That's the important thing. All right, I'm going to go. I'm going to leave you to it, and good luck with the rest of the day.
Yeah, thank you. That was a really good talk, Trisha. Thank you for doing that. All right, let's add the next speaker. Yuriy is here. Hi, Yuriy.
Yeah, I'm here. You hear me?
Yes, we can hear you really well. I'm really excited to introduce Yuriy today because he's one of my favorite developers at JetBrains. He's very knowledgeable about everything IntelliJ IDEA related, very passionate about making the IDE better. I love collaborating with him because he's just really interested in how can we make this better for the developers. So we just talk about features, talk about improvements. It's been such a pleasure working with him. Today, Yuriy is going to be talking to us about how IntelliJ supports new technologies, languages, and frameworks. And he'll show us how IntelliJ is not only a product, but also a framework for your own IDE features. I'm really looking forward to hearing about this session. Thanks a lot, Yuriy. And I'm going to let you take it from here.
Yeah, thanks, Dalia. Let's move on to the topic. Hello, everyone, again. My name is Yuriy, And today I'm talking about plugin development, and I will tell you how we actually try to build new features for new technologies and languages and frameworks inside IntelliJ IDEA. So you can reuse our best practices, so you can use the same techniques to support your own technologies, your own maybe languages and frameworks. And there is a fun fact about me. I'm actually believe we already have enough frameworks and enough tools on the market. They are good enough for us, but I'm really sad that we have no really good support for all of them. Sometimes IDEs really have really good support for some technology, let's say Java or Spring, but for new technologies that just developed recently, we know such big amount of work done inside IDEs. And I'm working in IntelliJ IDEA team on features for new technologies, primarily for JVM framework support, such as Spring and Java EE, but also we built a lot of small improvements inside IDE, such as custom languages, most popular expression languages, template languages, and many different tools. Okay. So there is a small plan for this topic, for this talk. First of all, I'm planning to tell you more about IntelliJ IDEA plugin system, so we can dive into this topic and let's see how it is built inside. Then we will see how we can build support for custom framework, and custom framework today will be well-known Spring framework. Let's just imagine that there is no support inside IntelliJ IDEA for Spring. Let's imagine, because actually there is a good support for Spring framework inside IntelliJ IDEA. Then we will talk about custom languages, because sometimes people need really custom DSL languages or expression languages, or maybe file formats that are not that common on the market. And we will talk about how we can develop lexer parser for a small language such as JSON path. Then we will talk about integration, because I in IDE stands for integration. So we cannot just skip this topic. So we will talk about integration with external tools, how we can call them, how we can integrate them inside IDE. And then I will share useful resources that will help you with your own plugins. Okay, that's the plan. And now I want to tell you the story about custom things in the world. Almost every company, has their own framework libraries, tools, maybe conventions, I don't know, maybe Docker images, and so on. And that's real life. We already built something for us inside our company, and these things are not open source. So there is no chance that IDE at some point will support your in-house framework or your in-house library. And at the same time, we all have a lot of routine tasks, and we cannot get rid of those routine tasks completely, because that's how our work consists of. And we actually deal with these 2 points. So we have our own in-house frameworks, we have a lot of routine, and that's how we live actually. So sometimes we try to build new frameworks and libraries just to deal with these routine tasks. And when we try to deal with the routine, we actually have 3 choices. First choice is let's build more languages and frameworks. It's obvious choice, yeah. We have a problem. Let's raise the abstraction layer and build more languages and frameworks. Nice. Now we have 2,000 different frameworks for JVM, and that's okay. Let's just try to choose something useful for us. There is a second option. Let's try to not introduce any libraries, any frameworks at all, but let's generate more code. That's obvious thing. We will build a new code generator, and while we are building this code generator, our competitors will just get all the market while we're building yet another code generator. Nice. And there is a third option for us. We can improve our tools. We can improve IDE. We can improve existing maybe command line tools such as, I don't know, maybe Docker or Terminal or something else. And today, let's talk about this third option. Let's try and improve our tooling for our custom needs. So for something that is not supported in IDE already, and try to see how we can employ IntelliJ IDEA not as just ready-to-use product, but as a platform for your own features, as a framework, like those frameworks you already built for your needs. And today I'm sharing our real experience. So everything that I'm show you here, we just do the same inside IntelliJ IDEA, or almost the same, because all the examples today will be slightly simplified, so we can just talk about them and do not go crazy on the complexity. So I'm trying to keep it simple, and we will talk about the ideas and mechanisms primarily, and not the concrete implementation choices. Okay, first of all, you can do a lot of things with IntelliJ IDEA plugin. If you build custom plugin for your own technology, you can do a lot of things. You can do languages, file formats, navigation, editor improvements, a lot of stuff. And if you see some feature in IntelliJ IDEA, like you use it for some public library or some open source tool, please note, you can build the same feature for your own technology. It is just, it is not secret knowledge. You can find more about anything inside IntelliJ IDEA in its sources, if we talk about IntelliJ IDEA Community Edition, of course. And now let's talk about IDE internals. IDE is somewhat complex system. It consists of many moving parts. It has implementation of virtual file system, for instance. It supports a lot of languages. It parses them, highlights them. It provides editor capabilities. Also, it runs inspections over your code, provides indexes for your mechanisms of IDE. And it has UI library, extension points, and so on. And all our IDEs actually consist of plugins. So any language support, either PHP or maybe Java or Groovy or something else, this is plugin. This is not that just like something set in stone inside IDE internals. No, actually, any functionality for concrete technology, such as language or tool, this is plugin, and you can build the same, let's say, set of features for your own stuff. And if we check our IDEs, maybe 3 of them, IDE, Ultimate, PHP, Storm, and RubyMine, here we have different sets of plugins. Okay, let's talk about plugin system. Plugin system, it's like a mechanism that allows different plugins to elaborate and communicate with each other. And here, every plugin implements something like a loophole called extension point. This is like a special interface that should be declared in IDE or inside plugin. And this is how plugins communicate with each other. And also, plugins may reuse existing functionality of IDE and its plugins. You should not reinvent the wheel. You know, if we already support XML or YAML or maybe JSON, there's no need to build a custom parser for JSON or XML. You can add your features on top of existing plugins. And today I will show you how you can build something on top of Java language, for instance. And if we check one of existing plugins, let's say Groovy plugin, we'll see that Groovy plugin actually depends on Java plugin, on properties plugin, and also optionally depend on some of Ultimate modules, such as UML, for instance. So you can reuse many features from existing plugins and just employ them and leverage them in your features. Okay, let's get started. Actually, we try to build something useful. Let's see how we can start. First of all, you can easily create your first IntelliJ IDEA plugin right from IntelliJ IDEA. Just go to File, New Project, and there you'll find IntelliJ Platform Plugin option inside Gradle project type. That's how you can try to create new plugin. First of all, check or enable a plugin called Plugin Dev Kit. It is built-in plugin of IntelliJ IDEA. So just check if you maybe accidentally disabled this plugin. So please ensure that it's enabled. Then create a project with IntelliJ IDEA platform plugin option, and declare and implement extension points. Profit. Yeah, not that easy actually. Also, I'd recommend to use Kotlin for your plugins, but it is not required. You can use Java or you can use Scala for your own plugin, but we usually recommend Kotlin because it is more concise and like shorter for plugin development. We actually use it for many APIs and mechanisms inside IntelliJ IDEA. Okay, so we created this new plugin. Now let's talk about the second option for plugin for new plugin. There is one more new option for your IntelliJ IDEA plugin called IntelliJ IDEA plugin template. It is a recommended way to start your plugin development. So previous one exists for ages already, but there's a new kid on the playground. Let's check this IntelliJ platform plugin template. There you'll find a lot of useful options. For instance, you'll find existing scripts for building, deploying the plugin, and delivering it to the marketplace. Also, there are a lot of useful presets and properties for you. For instance, if I open Gradle properties, you'll find separate options for your builds here. So I'd recommend to use this IntelliJ platform plugin template for your plugins. Just go to GitHub, and there you'll find option to use it as template. Just go and use this template for your plugin. Okay, so using some of the ways we finally created a plugin. Let's talk about its structure. There you'll find source code, source folders for your Java or Kotlin sources. Also, there is a manifest file called plugin XML. It declares all the functionality of your plugin. And there is a build script with a Gradle build system. If we open plugin XML file, we'll find something like this. It declares plugin metadata, like name, vendor, description, identifier. But most importantly, it declares dependencies on existing plugins. And in my case, today we will build plugin for Java IDE, for IntelliJ IDEA. So I will add dependency on common IntelliJ modules Java in my plugin XML. Also, we'll declare extensions here in plugin XML file and actions. Maybe we'll build one action that provides something useful for our users. So that's the structure of plugin XML, and you can easily check it in IDE. Okay, let me just switch to IDE and show you the same picture in code. So if I open my IntelliJ IDEA, you'll find the same structure, like build Gradle with my dependencies and options, source sets, resources. There we go and open plugin XML, all this stuff for my company functionality. And today we just imagine that there is no Spring framework on the market, and we built it from the ground in my company, and that's why we built a plugin for it today. Okay, Just let me switch back. So let's talk about extension points. So previously, I've shown you that there is a special section in plugin XML, and there you can declare your extension points, such as actions, inspections, intention actions, reference contributors, and so on. We register them in this file, and you can find more extension points inside IntelliJ IDEA files. They are available in your project. So if we go to source code and try to find file by name, long extension, like long extension points XML, and open this file from library, you'll find a lot of extension points, and you can find their interfaces. You can read what's this, which parameters they have, and you can explore more like documentation and hints here in concrete files of the platform. So you can easily check internals of IntelliJ IDEA right from your IntelliJ IDEA plugin code. And if we check existing plugin, let's say Groovy support. Groovy plugin is open source plugin, and you can easily find its source code on GitHub. There will be 1,300 lines of plugin XML to declare all the options that all the extension points provided by Groovy plugin. So you can implement a lot of things. And you can easily find all source code of IntelliJ IDEA community on GitHub inside JetBrains organization. And also recently, my colleagues from IntelliJ IDEA SDK team released one useful tool called IntelliJ Platform Explorer. Highly recommended thing. There you can find existing implementations of extension points. So let's say there is some plugin that already implements, I don't know, maybe, let's say it implements line marker, for instance, line marker. And we want to check code of this plugin, let's say Kotlin or, I don't know, maybe Scala or Flash and something else. And here you can find source code and of this plugin. You can find all the extensions implemented in this plugin and check source code of this plugin with this extension point. So here you can find more examples of already implemented functionality inside open source plugins. Highly recommended. But what you can actually do with all these extension points? So yeah, we have all those extension points, and what? Let's see how we can employ them. So let's imagine that we have developed a framework, and this is our own custom framework, which is very similar to Spring, for instance. Like just imagine it. And what can go wrong actually? So yeah, we've implemented something, and what? IDE will stop working with it? No, IDE will work with it. But what's happening actually? Let me show you. There can be some problems. So I've opened this sample project, very well-known sample project, like Spring Pet Clinic. It's like example of project based on Spring Framework. Let's open something like vet controller, some code. Yeah, and here I see a lot of gray markup. Like I see this method is never used. Why? Why IDE doesn't understand that get mapping is something like entry point? I don't know, because IDE is not a wizard. It cannot like read your thoughts and understand all the stuff automatically. Someone should tell IDE that this get mapping thing is declares entry point. Let's try to fix this for our own custom Spring Framework. So let's say we need to say IDE, if something is marked as get mapping, this is useful stuff. You should not highlight it with gray things. So this is problem called implicit usages. And the problem actually is frameworks nowadays are very powerful, and they really love nice naming conventions, implicit conventions, and they try to like automatically find and scan something from your code. And that's what we've seen right now for welcome controller. Let's teach IDE to understand those implicit usages. That's simple stuff, just to understand how we can declare extension points and how we should work with IntelliJ IDEA plugin code. So we start with extension point called implicit usage provider. We declare it inside plugin XML with the corresponding tag name, just like implicit usage provider. We declare here Java class or Kotlin class called Spring implicit usage provider. It should implement 3 methods: is implicit write, is implicit read, and is implicit usage. So let's implement this stuff. But see, here we have some magic wording. Like I see this PSI, like PSI. What's the PSI? How I can understand this abracadabra? Let's try to figure out what's PSI actually. PSI is a special program structure interface. It's a representation of your programs, of your like code, file formats, and lexical structures. It represents syntax structure of files and also includes semantics and provides references between elements. And everything in IDE, like almost everything inside IDE, is represented by a special object with interface PSI element. So PSI stands for program structure interface. This is just elements that represent your code, your syntax trees. And languages, different languages such as Java or Kotlin or JSON, they provide their own implementations of this PSI elements. So each file, each like standard file, Java file, or maybe JSON file, consists of many PSI elements, and those PSI elements, they form some structure called PSI tree. And let's try to see, for instance, for Java, how this PSI model looks like. Let me go back to the IDE. So here we see this like Java file. Let's open tools and find here view PSI structure of current file action. This action is available inside your debug IDE. It's IDE instance that is up and running if you run your plugin from Gradle. And let's click here with this option. So now I see PSI structure of this file, and I can even try to find which symbols and which like strings, what is their representation in memory. For instance, here that repository, this is PSI identifier, and there is a Java code reference element. Also, this is type element, and it is inside PSI parameter. So this thing called PSI tree, and you can easily explore it and see the structure of the file. In my case, this is Java file. This is a useful thing because let's see what we have for this unused method. Here for method, we have PSI identifier inside of structure called PSI method. Nice, we know this stuff is PSI method. So we should check that thing that will be passed here. Let's go back. So here, if we receive PSI method, we should return true if it is annotated with some magic Spring annotation. Let's see how we can build this in code. I'm going to plugin XML. Here I have extensions and extension point, and first extension point actually is implicit usage provider. Let's go to the code. So here I have implemented this like usage provider. It is very simple. If we receive class, it should be annotated with one of bin annotations. And if we go here, you'll find regular constant declarations. So I just hard code all these annotation names, class names, and maybe something else from the framework. This is how my plugin code actually interacts with the framework. So my plugin should somehow know which annotations and their semantics used in framework. So I just easily add constants. I will just decide that bin annotations are component and controller for simplicity, for the sake of simplicity here. And if class is annotated with one of bin annotations, I just return true. This is something useful, something that is used implicitly. And in case of PSI method, if we receive PSI method, it should be public, it should not be static, and it should be annotated with one of controller method annotations. And today I only have like 4 controller annotations, controller method annotations: get, post, mapping, init binder, and module attribute. And that's it. And let's see what will be. Just restart our plugin. So I've just enabled implicit usage provider, restart the plugin. And let's see if we now, if IDE now understands these implicit usages and highlights something with gray highlighting. So it is running. Now, let's wait for resolve and scan. And finally, IDE will know that it is used implicitly, and we should not. Now you see this color, regular color of declared method. If I remove get mapping, it becomes unused. So now IDE understands that get mapping declares something called entry point. So wow, nice, IDE understands me. I'm happy. Okay, we've implemented first useful extension point. Nice. Let's proceed to the next useful stuff. There is a special thing in our IDEs called inspections. It is a like special inspector, actually, some mechanism that statically check your code, traverse PSI tree, and check if there are any errors inside. Maybe not only syntax errors, maybe like semantic errors or correctness errors, maybe data flow analysis required to figure out find some bugs. We have seen today, Tagir shown us how data flow analysis can find pretty strange bugs in your code. That's inspections. And there is a special interface called local inspection tool. You can implement it in your plugin and provide a custom inspection. Let's try to build a simple inspection that will enforce a coding convention. In the Spring world, there is a recommendation from Spring team that one should not use auto-wired annotation on a field because of testing reasons, because of initialization reasons, many reasons behind this decision, but auto-wired annotation on a field is not recommended. So we implement this local inspection extension point for Java language, and we will put it inside a group with name Spring. We will enable it by default because I want to enforce this coding convention. And we will create one more Java or Kotlin class that will implement this extension point. And here we will implement some of methods of abstract-based Java local inspection tool. In our case, it will be check field, not check method actually, but check field. Let's see how we can implement something like this. So I'm going to uncomment this local inspection. So that's how we define new local inspection. It will be Spring auto-wired inspection. And here I will declare only one overridden method, check field. It will receive object called PSI field. This is representation of field in Java. So if you declare some field inside class, it will be PSI field. And if this field is annotated with auto-wired annotation, then I will highlight identifier, name identifier of this field with field injection is not recommended warning. So let's see how it works and how we can see how it works actually. Yeah. So we just restart our plugin, and right now when I just click here run, IntelliJ IDEA builds a plugin and puts this plugin inside a special debug instance of IntelliJ IDEA. So my daily life is as follows. I built IntelliJ IDEA using IntelliJ IDEA. So yeah, that's kind of cool. Yeah, so let's open and see our inspection. So now let's try to find something annotated as auto-wired. I will try to find some example in my project. Auto-wired. Okay. So here, auto-wired used correctly. It is used for a constructor. I will put it on my field. And now here, see, we have this nice warning. Field injection is not recommended. All your colleagues will receive this warning, and that's how you can enforce your like powerful coding conventions in your company. So you can just say, guys, you should not at any time use field injection. Yeah. Okay, so that's how we can build something useful like inspections. And inside inspections, you can build something really powerful and cool, and even provide your quick fixes. You probably know we have quick fixes for inspections. Let's go back to slides. Nice. And let's talk about the third topic for today for code. Our PSI tree consists of not only from elements, but it has references between elements. And that's how actual navigation works inside IntelliJ IDEA. You just go to the code, hold Control keyboard key, yeah, click, and you go to something like definition of owner or definition of string, integer, and something else. And references actually can provide auto-completion variants, and plugins, including your plugin, can contribute new references to existing languages. So you can provide, for instance, references to maybe external files or external entities inside Java. Let's see how we can employ it for our own custom framework called Spring Framework. So let's build support for things called property references. So in Spring Framework, we have ability to use interpolation using this $sign inside a value annotation. And here we mention property from one of property files, for instance, from application.properties file. And here I want to get auto-completion for this property names and navigation to declaration of this properties. And that's how I work. Yeah, I just open our source code, click here, and go to property file. But by default, this is just do not work. So let's try to see if it works or not. So we go and find the value. Here, yeah, we have some value. I just click, and IDE doesn't understand my custom framework today. It doesn't know that this nice interpolation sign means something. I need to teach this robot to understand my code. So let's build a new extension point called PSI reference contributor. And let's add our own custom reference here so we can go and find this database URL property. So I go back to IntelliJ IDEA with the code. Stop this. I will uncomment one more extension point called PSI reference contributor. This is my class Spring Property Reference Contributor. And here I register special reference provider. Reference provider should define actually two things. First thing is a pattern, something that designates like place in code where we should insert references. It will be some PSI language injection host in my case, for instance, some string in Java, which is annotation parameter of value annotation. So inside the value annotation of Spring Framework. And second thing we should build is a PSI reference provider, something that will create these references. And here I will try to find some places inside string, some like ranges, where we have interpolation with useful helper utility class from IntelliJ IDEA Community Edition with placeholder text ranges class. It will give me all the places where in my string this interpolation pattern exists. And there we will create placeholder property reference, special reference class that is implemented in my plugin. It is not built from scratch. Here I am reusing existing property reference base class from IntelliJ IDEA community. So you can and even maybe should reuse some code from IntelliJ IDEA. So I'm reusing this property reference base class and only customize some of aspects, some of like behavior aspects of this class. For instance, I provide reference variants options for auto-completion, or I customize property files search. And in my case, search will be just like very straightforward. I will try to find all the config directories and all the files with the name starts with application. That's just like this. Like naming convention in my company is pretty easy. Application.property means configuration file. That's it. That's how we create this property reference class. Let's see how it works and what features it provides. So we restart the plugin and let's see if it provides something useful for us. So we restart plugin and let's see how we can use this auto-completion and references, because I need this for my daily work. And I want to use navigation, maybe rename, refactoring, find usages, and something else. So now if I go to some place where value annotation is used and just put cursor caret here, you see there is a highlighting. If I hold Control, I see that this is this key references value user inside application.properties file. If I click here, I navigate to application.properties file. That's nice. If I just try to autocomplete inside this braces, I'll see all the options from my application.properties file. Yeah, finally I have something useful from my IDE. So I can see this navigation and I can even rename all the occurrences of this key. So I just go and use standard Shift F6 shortcut, just rename, and it will be not database, maybe db.url, rename. And if we go to the file, that's it. It is renamed everywhere. Just like I've only implemented references. I've not implemented any refactor capabilities. I've not implemented any find usages, but find usages already works. If I trigger find usages for this db.url, I find usages inside Java classes. That's nice. So I can easily rename all the occurrences and refactor my code safely. Why this magic works? Let's talk about this. So find usages and rename refactoring. By default, find usages mechanism inside IntelliJ IDEA finds elements with the same text. So actually, text of the property key and the string inside Java, it is the same text. So that's why find user just finds this. It tries to find references in this place where we have the same text. And if it finds suitable references to the same element, it matches them, and it shows this as occurrence. And it works automatically. So by default, for simple cases like keys inside properties in Java, it works like magically. I should not implement any custom find users on rename refactoring actions. And you can even customize it for complex cases. For instance, in Kotlin or in Groovy, we have property usages that try to find getters and setters not only with the same text as property name, but with get and set prefix. So that's what we get if we just add references. So we just get find usages, rename, and navigation, and all the stuff. Nice. Okay, that's it with custom frameworks. What's next? Actually, we have not that enough time maybe for full-blown custom languages introduction, but I will show you some stuff about custom languages. Let's say we have implemented some custom language, let's say JSON path, for instance, and IntelliJ IDEA can help us with support of this language. So we can build custom file type, grammar for this language, lexer and parser. We can implement highlighting, completion, inspections, refactorings, all this stuff. But today, let's implement first only the first four things. And here, special plugin called Grammar Kit will help us. And first of all, you should go and install this plugin if you need to implement custom language support. This is additional plugin, and it provides support for Backus Naur forms or Backus normal forms grammars. And also it provides editor support for JFlex Lexers editor. It can generate Lexer by BNF if you are lazy enough, as me maybe. And also it generates readable parser and PSI code generator. You should read this tutorial available inside in our IntelliJ IDEA SDK docs on custom language support. It shows you all the aspects of custom language support. But today I will just only show you some of them. Okay, let's say we need to implement some language, and maybe I use some language similar to JSON path. Let's find some usages in Pet Clinic. So here you see we have some strange string with $, vet list, ID, something like expression language, and I want to have highlighting for it. I want to have syntax highlighting and maybe years shown here. But now ID doesn't understand that this is like some custom language called JSON path. Let's implement support for this language like in 5 minutes, for instance, like very, very fast. First of all, we go to our plugin and implement one first extension point called parser definition. This is where we declare that we have one more language. It will be JSON path language. I just declare these classes. They are easily created like by hand. You can just declare here options. Is it case sensitive? What is the file type? There are no logic here, just like options. And this file type will be named JSON path, description JSON path, and default extension is the same. And then when I declare this parser definition, I go and write grammar for my language. Let's see how we can do this. First of all, I go and write something like BNF form for my language. This is how Grammar Kit helps me to write these BNF files. I see all the highlighted stuff. I see my tokens, and I see all the generator options, because I'm not going to write parser and lexer by hand. grammar kit will generate them for me. I will only declare grammar for this language. And here I declared standard options, standard like tokens and elements of this language. Here I have something called head and something called segments. And I can even try my language right here with Ctrl-Alt-P shortcut. So it opens editor of this language, of this not yet built and compiled language, and I can try my language here. So I write something valid. This is awk, this is parsed. But if I, let's say, make a mistake, here we'll have like syntax error. So that's how I can easily try to test my BNF without even compiling my project. So I can easily open this preview button. And when I'm done with my BNF, I can generate lexer and parser for my language. You can click here with right mouse button and find generate JFlex lexer. I will not just try it right here. I've already generated one. And generate parser code. Let's generate parser code. So just generate parser code. IntelliJ IDEA will generate it. And here you'll find a lot of generated code. Like you'll find all the PSI structures, all the PSI interfaces. You'll find parser. It is quite big, but it is a good idea to generate it instead of writing manually. Also, when I go to my lexer, here I'll find I'm using only simplified set of tokens in this language, like this standard set of keywords, and only identifiers and numbers are supported. So now I have lexer. I will generate JFlex generator from this lexer definition, and IntelliJ IDEA will generate lexer code for me too. So this file with 600 lines generated. Nice. I should not write it manually. So that's how we usually build new languages like grammars and flex definitions. And when it is ready, we go and implement some of extension points for custom language. For instance, I've implemented simple brace matcher. Like, let's go and see this brace matcher only has two brackets, like one pair of brackets supported, L bracket and R bracket. So that's how we match them in code. And if we run this plugin, let's run it. Like I will run this. And here we'll find syntax highlighting for the language. It is implemented with JSON path syntax highlighter. Here we have no behavior tool, only simple highlighting options, like which token with which highlighting type should be considered. So here I only specify that comma should be highlighted with default highlighting colors, comma. And for instance, if something called JSON path context, I try to highlight it with static field highlighting. And for identifiers, I'm using instance field highlighting. So I'm reusing existing colors from IntelliJ IDEA color settings. So let's see how it works. So now we have this language. Let's try to inject it. Trisha already shown you how we can easily inject any language in string literal. Let's use it. Like I use Alt-Enter and inject language. And here we can find JSON path language. So now we can use it everywhere. Like add it here. And wow, we now have highlighting for this language. If I like make a typo, I see syntax error, I can open JSON fragment here and see I can edit it right now. Yeah, it is parsed correctly. There is a syntax errors. I can use some of keywords from my JSON path implementation. That's how we really start building languages. And in the recent version of IntelliJ IDEA, in EAP version, you'll find ready-to-use implementation of JSON path language. So please try it if you use JSON paths in your like daily routine. We already implemented JSON path for you, and you can check a full code of this implementation in IntelliJ IDEA Community Edition. It is fully available on GitHub. So that's how we usually build languages and their support. Whew, nice. Let's talk about some of the options for integration briefly, like in a couple of words. This is not all of the options for you to implement custom integrations. You can integrate with external tools, such as command line tools, such as external libraries, and there is easy way to integrate with something. If there is a JVM library that implements integration, for instance, for Gradle, for Docker, for Swagger, we use Java libraries for integration. There is harder option for you. You can connect to external API via network or Unix socket. That's how we integrate with Spring Initializer service, and that's how we integrate with Java Debugger, for instance. And you can easily access your network resources from IntelliJ IDEA plugin. There is a pain and suffering option for you if you try to run something like command line tools, but we also provide mechanisms for you to run command line tools such as Git, Docker, NPM, and you can run your own command line tools. And finally, there is out of the ratings, there is a web content integration topic. I will briefly show you what I mean here for web content. If we just open here, just open the README file, and here, see, this is web content. And we can even open DevTools for this web browser. Actually, this right pane is a Chromium browser, full-blown web browser integrated inside IntelliJ IDEA. So please know, you can easily integrate many web stuff like Swagger UI, I don't know, diagrams, external services, and so on in IntelliJ IDEA with JSF. It is just nice option to integrate something. And I can even show you a more powerful option. We have integrated Swagger UI with the same mechanisms. So here we have a web page from Swagger UI, which is running inside IntelliJ IDEA, actually inside of Chromium browser, which runs inside of IntelliJ IDEA. So you can easily integrate even JavaScript and HTML UI inside of IntelliJ IDEA. So there are more integration options than you can imagine. Oh, so briefly, there are these 5 options for your integrations. Please check them. And if you have any questions, I believe you can ask more questions on our resources. We have many useful resources for you. For instance, JetBrains platform Slack, where you can ask technical questions. We have dedicated documentation pages for plugin developers in IntelliJ IDEA SDK docs. And also, you will find all the examples from the talk on GitHub. So I believe that's it for the technical content. Thank you. And if we have any questions, it would be nice to answer them all.
Yeah, this was awesome. I remember starting to develop plugins, and I saw that plugin, that XML file, and I was like, I have no idea what's going on here. So it would have been really nice to have your presentation back then, understanding like the extension points and all those things. So thank you a lot for that. And I think it's really nice to have the IDE do something customized like that. I don't know. I think it's magical just having the IDE do that. So the questions that came in the chat, the moderators did a wonderful job answering them. And one of the questions that I wanted to reiterate is if you can write plugins in Groovy. They said yes, but you can expand on that if you'd like.
Yeah, actually, you can write plugins in Groovy, and I can even emphasize here, actually, Groovy plugin is partially written with Groovy. Yeah, so you can even go crazy and write plugins for JVM languages on those JVM languages. And even more, Scala plugin is mostly written in Scala for IntelliJ. So funny facts about development inside IntelliJ IDEA.
Cool. Another thing that I had a question about. So I've heard about the template before, but I wasn't really sure what comes with that. So if I'm a beginner, I want to just write my first plugin and I want to use a template, what would you recommend me do?
I certainly recommend go and use template on GitHub, because it is like predefined and consists of all the useful stuff. Just go and click use template here. There you'll find all the default options and useful documentation on this, and even examples of code that will help you to define your own extension points. So this is all the best practices you should use in your plugin. They are all concentrated in this repository. So even you are not planning to use this plugin template, maybe check it and check if you're doing all the stuff right.
Awesome. Okay. Last thing I wanted to wrap up with is I wanted to ask you, do you have a favorite plugin or a favorite feature that you've worked on while working on IntelliJ IDEA?
Yeah, recently I've been working on this JSON path support. This is pretty exciting when you build something from scratch, like new language, new tooling, new like parser or definitions. So I'm really excited about languages, extension points for languages and so on. Yeah, that's just cool stuff.
Awesome. Well, thank you so much, Yuriy. I love this presentation. I appreciate you being here with us.
Yeah, thank you, Dalia.
Thanks. All right. And now I'm going to add in Trisha back, and I think Mala is going to be hosting the next session with you, Trisha?
No, just, no.
Just you. All right.
Just me.
Awesome. Well, you won't be sharing your screen, so we won't have to worry about that.
Yes, exactly. No more screen sharing from me. And my talk is done, so I'm happy now. I'm chill.
All right. That's good. That's good. All right. Well, I'm going to let you hang out for a second. Are you all ready to go for our next one? I think it's the last presentation, correct?
We are going to do the last session now, and then we will all, you, me, Mala, and Helen will all like get together at the end to wave goodbye to everybody, basically.
Awesome.
So yeah,
All
I'll
right.
see you in a minute.
Awesome. Thank you, Trish.
Bye.
Bye.
Yes, so our next session, I would like to introduce Marco. Hello, Marco.
Hello, Trisha. Hi.
I love how basically everyone, all the speakers are like sat on the edge of the stream going, I've got to look ready in case she adds me to the stream. And I don't know, we're drinking coffee. Going, yes.
Yes. Yeah, pretty much.
So yes, it's really great to have you on here, Marco. Not just because it means I don't have to do the spring tips and tricks. So I think I got to sort of know you vaguely a couple of years ago. I just looked it up actually. I think it's like 3-4 years ago, because you were submitting a bunch of stuff to show in Java Annotated Monthly. You were doing some great videos which use IntelliJ IDEA, which is great. Use IntelliJ IDEA properly, which is even better. And you had some really good content, especially around things like Spring and stuff like that. So it's really good to have you now on board as part of the team of the developer advocates.
Yeah, I'm super excited to be here.
I'm so pleased to have you. This is excellent. Yes. Oh, and I forgot to mention that you are the developer advocate for Team City, right?
Yep. Team City. Yeah. So all about build, CI processes and whatnot.
Great. I don't know what I was going to say. It's the end of the day. Oh, yes. So apparently you like to explore cities by foot. How is that working out for you right now?
Well, at least my hometown is. I mean, the thing is, I know my way around my hometown, so it's working out okay-ish. I mean, I've been to many places 20 million times, basically. But yes, I do that, and I think I also mentioned that I like to show people around, and I was hoping that not too many people take me up on that offer at the same time once the lockdown is gone, or else I'm going to run into troubles. But yes, exploring cities is something which I like to do very much.
And I think it's cool that you already live in Munich. So you're one of the few people who doesn't have to move to actually be near one of our offices, particularly amongst the developer advocates, because we're mostly remote.
Yeah, that's true. And it's a great Russian experience because a lot of my colleagues in Munich are Russians, so it's quite international, I'd say.
Very cool. Right, I will let you get on with it. I'm looking forward to seeing your spring tips and tricks. Have fun.
Thank you. Thanks. So yes, hi all. For what it's worth, this talk is called IntelliJ and Spring Tips and Tricks from the Trenches, because I'm essentially going to show you features that I myself like to use in my day-to-day Spring projects or Spring Boot projects. And as I'm not too much of a fan of slides, this is going to be the only slide you're seeing. We're going to do some live coding, essentially building a small Spring Boot application from the ground up. And I'm going to talk about the features along the way. And don't worry, I don't want you to stress out and try and remember all the features I'm showing, because it's quite a lot of stuff I'm going to go through. I'm quite happy actually on the last session, because it's the first time I'm doing this talk, and I'd like to see how far I can go in 1 hour. But if you just remember 1 or 2 features, 1 or 2 tricks, and then you come back to the video recording that we put up on YouTube with the timestamps of the different tips, tricks, and features sorted by category, then I'm basically already happy, and you're on your way to become much more productive with IntelliJ and your Spring projects. That is, as I mentioned, everything I wanted to show you. Let me close that slide, go straight to the IDE, because we're going to start at the very beginning. The very beginning is opening up a new project, in this case, a Spring Boot project. And what I'm showing you, just mentioning it again, is valid for IntelliJ Ultimate Edition, because the Community Edition doesn't have the Spring integration features. Now, Yuriy already mentioned parts of it in his talk, but when you create a new project, you can essentially, for a Spring Boot project, go and choose the Spring Initializer option straight out of the new project dialog. You have a couple of options. Most of you who created Spring Boot projects will know start.spring.io. I'm just going to open up that page here. It's the Spring Initializer homepage, where you can create a vanilla project skeleton, Maven or Gradle, choose between different programming languages, add your Spring Boot dependencies. And then you can create a project, generate a project, download a zip file, unzip it on your hard disk, open it up, or you can just stay inside your IDE, because Spring Initializer also offers a REST API, which IntelliJ integrates against, and do the same thing you did on the website straight out of IntelliJ, which we're going to do in a second when I press the next button. But I wanted to talk about that custom field, because some people were confused in the past what the custom field is. And essentially what's happening when you work, say, in the bigger corporation, you have multiple modules that you want to include in new projects. You can actually fork the Spring Initializer project and create your own company initializer and put the URL to that company initializer into your custom field, just to let you know what that is for. Now we're going to hit next. I'm just going to call this project IntelliJ Birthday 20 Spring. We're going to talk a bit about Maven and Gradle in a second. All the other options, Java, Jar, doesn't really matter. I'm not going to talk about that for now. What I want to talk a bit about is the dependencies we're going to add to the project, because that is roughly the scope of my talk. So I'm going to show you a couple of things when you build RESTful applications. So I'm going to add the Spring Web dependency. I'm also going to talk about templating libraries, so Thymeleaf in this case, but also FreeMarker Velocity. I hope I get the time to talk about Spring Data JDBC, or rather all the Spring Data projects, hopefully. I can't promise it yet. Then we have the actuator, which gives you live data about your Spring Boot project, health endpoints and whatnot, and also, dev tools. I think that's a good start. And if I'm missing something, I'm just going to add it in a second to the project. Now, while the project opens up, let me talk about one boring but very important point. When you have a Spring Boot project and when you have a Spring MVC project and you open it up in IntelliJ, IntelliJ is smart enough to automatically configure the Spring support. And you can see that when you go to File, Project Structure, you go to Facets, and there's a facet, which is a Spring facet. And the Spring facet detected my application class, which we're going to talk about in a second, and the properties file. This is what you need for the Spring support to work. So if you work with Spring Boot, you don't have to do anything. If you are working with a plain Spring framework project, the facet gets automatically detected, but all these configurations are missing. You have to configure the facet yourself. If you don't configure the facet yourself, you don't have any of those nice features I'm going to show you. Very important just to keep in mind to get that right. Now we have a very simple Spring Boot project, normal project directory structure. I want to talk just a tiny second about the POM.xml file and a bit about IntelliJ's Maven support. It's not entirely related to, it's not entirely Spring Boot specific or Spring specific, but something I still use quite a lot. Now, I forgot actually to add a dependency. Let me try that again. I want to add a database dependency. In my case, H2. Now, what I could do is I could go to the H2 database homepage, find the dependency block, copy and paste it back into my POM.xml file, or I can only simply hit Alt-Insert on Windows, and you can see the shortcut I'm using at the bottom of the screen, and I can simply insert the dependency straight out of IntelliJ. I can search for H2. I kind of have to know what I'm looking for because I need the group ID, the artifact ID. In my case, I know I've been using the H2 database a lot. com.h2 database is my dependency, the one I want. I can choose between different dependency versions, and I can simply add it to the project by hitting Enter. What I want to show you is there's a nice little, the 1.4200 version is highlighted, and it says it comes from Spring Boot's dependency management, right? Because Spring Boot comes with a ton of dependencies and properties predefined, and that's why you don't have to specify the version number here. And when you insert the dependency, IntelliJ is smart enough to just leave out the version number. Always make sure, tiny bit here at the top right button, click Load Maven Changes. People tend to forget that, yeah, so that the POM.xml file gets reloaded, dependencies downloaded and whatnot. Which brings us to these gutter icons, and I'm going to be talking a lot about gutter icons in this talk. You have a gutter icon here. Please do not never ignore these gutter icons. If there's one thing you take away from this talk, just don't ignore gutter icons. Hover over them the first time you see a gutter icon to see what it could roughly be. In this case, you'll find that it gives you the full dependency block from the parent POM in this case. And you can also navigate through the gutter icon to where the dependency is declared in the parent project. Here you can see the version number is placeholder. IntelliJ was smart enough to replace that placeholder on the fly. Right? And you can see the different versions here being set in that Spring Boot specific properties file. It's really about navigation, and don't be scared if you don't know where a dependency comes from. You have the gutter icon. You can always find the parent POM. You can find the dependency versions and whatnot. Super simple but convenient features. Now, the same thing also works with Gradle files. If you do the Alt-Insert in Gradle files, what's going to happen is that IntelliJ will tell you, do you want to insert a Maven dependency into my Gradle file and convert the XML syntax automatically into Gradle syntax. So that works both ways, essentially. There's many more features regarding Maven support, but I just wanted to touch that briefly. So I wanted to get into Spring Boot now, finally. Imagine we want to build yet another CRUD application, so a REST service. You have some Angular application, you have a React application that wants to display some users from a database later on. So you're going to have an endpoint, users endpoint, which simply sends some users to the front end. And on the lower level, I guess at some point, you're going to have a class which is called user service. And that class is probably going to have a method, get users. And I'm just going to create, quickly going to create a user class. That's the most amount of coding I'm going to do here with a name. I'm just going to let IntelliJ create a constructor, create a getter, and whatnot. It's a very simple user class with just a string name field. Now, my user service returns a list of these users. And what you're going to do is return list of, at the moment, I'm just going to return new user myself. I'm going to be a bit selfish for now. But this is a normal Java class. you can turn it into a Spring Bean, for example, by adding the component annotation. Because the Spring application will search for, by default, to do a component scan and search for all the classes in this package and sub-packages, and we'll find out, well, here's a class with a component annotation, for example, an instantiator bean. Now, what you might have already noticed, if I comment this out or I comment it in again, there's one thing that changes. And the one thing that changes is the gutter icon. And you already saw the gutter icon a second ago in the Maven, in the POM XML file. The gutter icon here is a Spring Bean. It's just a green bean, has a Java class in the lower right corner. If that was a Spring Bean defined in an XML file, you wouldn't have that blue C here, right? And now what does that gutter icon let me do? It lets me navigate to the application which instantiates my bean. So that's a one-way street from bean to application context. Very important. In a simple project like this, you might be thinking, oh, Marco, it's even in the same package, in the same Java package. But in bigger projects, if you have hundreds of beans, it's really cool to be able to go from the bean to the application context. It also works the other way around. If you have a look at that gutter icon up here with the magnifying glass, here you'll see all the beans that your application component scans. So you can also go the other way. You can go back to the user service from your application class. Also very cool. So the navigation works both ways. And that brings us to one of the, let's say, general concepts. That's the only thing I wanted to take you away from this talk is gutter icons, very important. And navigation is one of those big topics you can do through gutter icons, right? Let's make the example a bit more complex. Imagine you have, for whatever reason, another password service, right? And you don't create that password service with a component annotation. You just go to your Spring application and write a bean method, which is also a valid way of creating new beans. And you can already see a new gutter icon popping up here. I'll show you that gutter icon in a second, but let's first go into the password service. Again, you can see IntelliJ was smart enough by the way, without booting up the application, it's all being done at, well, compile time, basically. You can see these highlightings work. You can go back to the application context. There's also a gutter icon here, which says navigate to auto-wired candidates, which I cannot do at the moment. What this gutter icon lets me do is I can go to every class which has a password service, where the password service is injected, basically. Let's try and do that. Let's go to the user service, and let's do something that Yuriy already talked about. A very bad thing. Let's put an auto-wired inside here, and we're just going to auto-wire, not the user service, we're going to auto-wire the password service, right? You got the icon. Navigate. You navigate strictly to the password service definition. And here with that button, you can also navigate back again. So there's always a two-way navigation in these with these gutter icons, right? And if I have more dependencies, I will get a list. If I had my password service injected in more other beans, I will get a list here, and I could choose directly which bean I want to jump into. When you have a look, the other gutter icons you can see here in the Spring application, for example, run is pretty much self-explanatory. So you can run and debug the application, right? It's on the class level. It's also on the main method. And then when you look at the gutter icon here on the application, you can, for example, also open up Spring diagrams. Now, I have to admit something. I'm not the biggest fans of the Spring diagrams, even though sometimes they're useful, for example, to find circular dependencies and whatnot. But by default, when, for example, you open up the beans dependencies diagram, you will be hit with a pretty big diagram window. That's because Spring Boot auto-configures so many beans and so many contexts in addition to what the beans you have to find yourself. So I'm not going to cover these big diagrams for now. I'm going to show you a couple of smaller ones later on. But just so you know, you can also always generate these diagrams. Now, when we go to the user service, Yuriy already took it away, which is a bit sad. But now imagine you're working in a project where you do the field annotation, the field injection, and you decide, well, I want to switch to constructor injection. Then, apart from navigation, IntelliJ offers you something else. for Spring, it's always these convenience features, like alt insert in the POM XML file. And IntelliJ has alt enter. So you just go on the auto-wired field, hit alt enter, and change from field injection to constructor injection. Very simple. Not much you can do, not much you have to do. And now you can take some time in your old projects and just convert field to constructor injection. While we're talking about convenience, there's also something else, which is quick error highlighting. When, for example, you go to the to your Spring application and comment out the password service definition, that means your application now has no password service. And when it boots up, you'll get an ugly error. Actually, let me just run the application, and after a couple of seconds, it takes time to compile. It takes time to boot up, right? I will get an error message saying, Marco, you should have defined a password service bean somewhere in the application. Interestingly, you could have also gone to the user service directly, and you would have seen, hey, there's an error. Because IntelliJ is smart enough to tell you already, again, at compile time, it can tell you, hey, you have no beans of password service defined. They weren't found. You can also find these errors in the problem section here. There's a problems tool window, which I have collapsed now in presentation mode, where you can see what dependencies could not be auto-wired. So you can skip the whole, let me run my application, and then I see what the error is. At startup, you can immediately see the error right in your IDE. The issue is, so actually let me just turn that back now. So you can see the highlighting is immediately, the red underlining is gone again. The issue is, and I know it from past project myself, that people misconfigured the Spring facet, didn't configure the Spring facet. They kind of got used to having red underlinings, and then they simply ignored the red underlinings and just tried to boot up the application, even though IntelliJ already told them there is something missing. So either you had Spring misconfigured, or there was something that the Spring support in IntelliJ misconfigured, or there was something really broken. What I want you to do is make sure you have the Spring facet set up correctly, which in most cases you don't even have to do because it works automatically. And then care about these red error highlightings. Don't just ignore them, right? Every time you see a red error highlighting, try to fix it. This kind of already, when I talked about concepts at the very beginning, navigation, convenience features like alt enter and whatnot, and error highlighting. These three things, the trinity, let's call it, I want you to take away. And I'm going to repeat these concepts over and over and over again in the next couple minutes. Right. Now, when we have these, let's say, basic navigation features and whatnot, auto-completion, let's talk a bit about properties. In Spring Boot, again, something that Yuriy briefly touched on, you have a ton of properties, a ton of property files even. And if you've been working with Spring Boot for a while, I mean, you could always go to the documentation, find, the Spring Boot property key, so to speak, copy and paste it back into your properties file, or you can simply use IntelliJ's auto-completion if you already roughly know what you're looking for. So for example, I can start typing, I get an auto-completion, and if I wanted to change my database URL, I would go to springdatasource.ul, right? And I can simply start typing and put in my H2 memory database URL here. If I had a typo inside, IntelliJ would tell me, it would highlight the Spring data source and tell me, hey, I could not resolve that configuration property, right? Even what I find even cooler, actually, let me comment that out. You can see already you have the full type information here. So there's a different property, Spring data source continue an error, for example, which later on gets converted to a Boolean field. IntelliJ automatically suggests me, hey, put in false or true. Again, when you put in another value, JEJ, for example, or 123, you will get error highlighting in IntelliJ. IntelliJ will let you still boot up the application, and you will simply get an error at runtime. So you could also simply take the time and have a look inside the properties file and have a look at the red underlinings and fix them before you boot up your Spring application, right? Obviously, you can also have your own custom properties, so special username. Let's add another user that we can put into our user service. And I'm just going to put Hadi here, a user who is close to my heart, right? And then I would go to my user service. And I'm just going to do some constructor injection again. I just want to put in the special username inside my user service. Again, let IntelliJ alt enter all the way, let it add the special username. I'm just going to put the special username down here as well. So we're going to have two users that our REST service in a second will return. And again, you can already see IntelliJ tells me a special username, right? Could not auto-wire, no beans of string type found. So we didn't define any beans. In fact, I don't want a string bean to be defined. I want that string to come from a properties file, which you do with the @value annotation. Again, here, convenience features, simply do a basic completion. You get to see all the keys you have to find, special username, even the value. You can see the file that the property comes from, right? Special username. So I'm just going to do autocomplete and not even typing it anymore, having to worry about is that the right property key and whatnot. So just let it do the autocompletion. Again, I can navigate between the Java class and the properties file. I can navigate between the properties file and the Java class also back. Actually, that works now. It doesn't work, but okay. And I just want to show you. Let me go back to the user service. Completion, navigation, error highlighting. Basically, that's what it's all about. Properties. While we're at properties, there's something else. If you start working with profiles in Spring Boot, also something that people do a lot. So imagine you want to slightly override your properties file, application staging properties. The special username is now written slightly differently. So I'm just going to put in some nonsensical stuff here. Hadi is now written like so. When you go back to user service, right, and do a quick definition of the property, what IntelliJ can show you is all the properties files that the property comes from. So application of properties, application staging of properties. You can immediately see what value that property has depending on the properties file. So get used to the quick definition shortcuts, navigation shortcuts, auto-completion. It's all done in your browser, and you don't always have to go back and forth between properties files and Java classes, because by highlighting a property and pressing the right keyboard shortcut, right? I hope you can actually see that here at the bottom, the quick definition. You have it all in the same window. Bringing the concept to an end, imagine also you have, regarding profiles, you have another bean, because on your staging environment, you want to have a bean which is being executed, a component that inserts some data on your staging environment. And it should only be run in the staging profile, under the staging profile. Which you can do with the add profile annotation, add profile staging, right? This is all you need to do for now. Now the time comes to run your application, right? That's always interesting how people run their Spring Boot application. And I've been running my Spring Boot application directly. So I just hit run Spring application. I can edit my configuration though. Before that, I'm sure you've seen that window a couple of times already. And you get a couple of Spring Boot specific features. One of those features is, for example, active profiles. You can set the active profile here with auto-completion even. So IntelliJ is smart enough to scan all your components, find out, hey, he had a component defined with a profile annotation staging. So IntelliJ just lets you automatically auto-complete that profile into that little text box here, yeah, right? And then IntelliJ will take that and convert this text field into a VM option like -d Spring profiles active, if I'm not mistaken. The same with the parameters. You don't have to, fumble with the parameters on the command line and override them as a VM option and -d whatever. You can just say that special username, including autocompletion, should now be something completely else, right? So again, what I want you to do is get used to autocompletion, get used to navigation and all these helper functions, really. There's even more helper functions, including hiding the banner. If you're sick of seeing the Spring Boot banner, which you can click, make use of all the tools that Spring Boot, that IntelliJ offers you when it comes to Spring Boot. And maybe last but not least, what I wanted to tell you, there's also some folks who are still stuck with XML application context, especially in companies with legacy projects. There's the odd, because Spring is super backwards compatible, there's the odd Spring application context XML. And all these features I showed you, autocompletion, navigation, whatnot, all these, they work with IntelliJ as well. You can even create, your Spring config, like so, application context, which creates an application context XML. You would maybe include it in your application like so, import resource, right? Even here you get auto-completion. So get used to having these auto-completion features in your annotations, for example, application context XML, right? And then you can simply start adding your Spring Beans and whatnot, your password service inside here, even though I have it already defined. That also works for people stuck with XML application context. There's even more features when it comes to Spring's expression language, to the cacheable annotation, for example, to event listeners, and even more gutter icons. I cannot go into all of these features here. I'm going to show you one tiny trick regarding gutter icons. Go to settings, right? And simply search for gutter. And then you'll at least find a nice little list of all the different gutter icons that IntelliJ offers you, not just for Spring, but for Swagger, for the HTTP client, for Java, for everything. So that is I found a good way to get used to what does a specific gutter icon mean, what could it do, or you just hover over the gutter icon to see what it actually does, right? Right, so that was a lot of talk about, let's say, basic Spring features. Remember the Trinity, navigation, auto-completion, arrow highlighting. Let's finally start writing a REST service. And what you would probably do is you're going to end up with a user controller, right? Which is a REST controller. I'm assuming you know your way around Spring Boot, right? And you're going to end up with a get mapping for users. All you're going to do is return the list of users, which you get. Let me see. Now the import is here, which you get by injecting the user service inside your controller class. And you're just going to go turn user service get users. Right? That's all you need to do for now. When you boot up the application, now let me just run the application, right? What you usually would do now is you run the application, it boots up, that looks fine, I didn't get an error message, an exception in my log. Then maybe you open your browser, you open up a third-party tool to some REST client, whatever, which is all fine, fair play. But you could also have a look at these new gutter icons that you just see in your controller class. Because again, IntelliJ was already smart enough to see, well, this is a controller. I'm going to show you some new gutter icons. It shows me a gutter icon to open up let me just click that. You can click it. It tells me immediately run HTTP request for this get mapping for /users call in IntelliJ's HTTP editor. So I can just click run here. And immediately, actually, my application booted up. You can see now the REST client open up. It did a get against localhost 8080 users. And I can see a nice little JSON output, name Marco, name Hardy, 2 different users, right? That works. The output works for JSON, HTML, for XML and whatnot. Very simple, super cool feature. Instead of running the request directly, you could have also opened it up in a browser, which I told you about, or in the HTTP request editor, which brings you to the new HTTP request editor in IntelliJ. The old one looked a bit different. Now, again, this is not entirely specific to Spring Boot. It works obviously with all other technologies, but it's such a cool feature. I just want to quickly run you through it. You can see you have get users, right? Simply hit Alt Enter, run, that works. If you worked in a bigger project and you didn't exactly know what is the URL of my endpoint I'm calling, again, what you can do is, which I find pretty freaky, autocompletion. Just go behind your host and your port, do autocompletion, and IntelliJ will automatically tell you, well, there's one user's endpoint you have in your Spring application. I can autocomplete that. If I only have, by the way, one get endpoint here. If I put post here, IntelliJ wouldn't show me anything because I don't have a post endpoint, right? So again, I find a fascinating feature just like that. You can do gets against your REST endpoints. If you don't feel comfortable with the syntax of how can you actually write requests in the HTTP client, very simple, you have a couple of buttons up here, and those buttons help you a lot. So for example, when you do add request, it tells you, well, why don't you just want to post a text body here? And it inserts automatically the request for you, a template request for you, which obviously doesn't work now, but I'm going to show you a very cool feature again. I set the content type to application JSON, which means I can type here, hello world. IntelliJ will automatically do syntax highlighting. It will tell me this is not valid JSON. You can see it underlined in red again. If I switch the content type to application XML, then immediately IntelliJ will tell me the whole thing is not XML, or you wanted to write is something else. So for example, this tag, auto-completion features, very, very simple and cool way to get, to issue all your REST requests, not just against Spring Boot endpoints, but against any endpoints, basically. And what you can also do is, for example, convert, which I like to do a lot, is convert these calls between curl, from curl to curl again. So if I just click this, you can see the actual curl call. You can copy and paste this to your command line and just run the same request. If you had a curl call from Stack Overflow, copy and paste coding, you can simply put it into the HTTP editor. It will work. You have even more examples for requests with authorization, basic out, and all this kind of stuff. It's a very powerful tool and something I'd like you to take a look at, basically. HTTP client, keep that in mind. Super useful, super helpful to work with it. Now, when you go back to the user controller, there's something else I wanted to show you, which you basically can see when you click this gutter icon up here. There's even more gutter icons. And I cannot say gutter icon enough in this talk, basically. You can see, well, when you hit that one, you can open it up in an HTTP client, what we just did. You can also click Go to Declarational Usages. Very important. IntelliJ tells you where in your project, in your HTML files, JavaScript files, in your REST editor, where does the user's endpoint get called? At the moment, it only gets called in the file I just showed you, right? So you can just go there. But if you had a big project again, it's super helpful to see where does the endpoint in your project get called. By the way, what I just clicked the user controller here. What you also can do is, so again, navigation, you just step inside. You can also step back straight from the HTTP client back into the controller class that defines the endpoint. So again, here navigation works both ways, right? And so we covered the navigation, the usages both ways. We covered the HTTP client. What we haven't covered yet is show all endpoints of a module. What does this do? Now it opens up a tool window. I'm just going to close it again because you'll find it at the bottom of the screen. You'll find the endpoints tool window. Again, it's not entirely specific to Spring. It just works with Spring. Also other frameworks, which you can find out about on the website. But essentially, what it gives you again at compile time is a complete overview of all the, for example, REST endpoints of your application. So you can see you have one module, that's your project. It's called IBJ20 Spring. It has one endpoint, a user's endpoint, listening to GET requests in a user controller class. You immediately see some documentation, which you don't have here yet. You have a tab for an HTTP client call. You can immediately issue requests against an endpoint, an open API description. So there's even more to it than that. But just to show you how that works, when you go here and create a new endpoint, admins, for example, right, you'll immediately, again, at compile time, see the new admins at point here. And you can just jump straight into the method, the declaring method, by double-clicking that. Again, a bit simple in this simple example, but super, super helpful in big projects. You can search for these endpoints, right? Just put in admin or just put in A or whatever. Placeholdering, you'll get every endpoint that starts with A. I find a very simple, useful feature. Even more, you might get the impression that endpoints only have to do with server endpoints, because that's what we wrote at the beginning. At the moment, we just had get mapping admins, get mapping users. It also works for client endpoints. So, for example, if you say you have a new REST template, for example, and do get for objects, and again, I find it gets pretty scary. So imagine in the real world, you basically call a REST endpoint, right? And again, you do an auto-completion in your get for object method, and you get auto-completion for admins and for users. IntelliJ is smart enough to do that, right? You just do that, like so. Now, that call inside, if you're thinking about programming logic, that call doesn't make sense here. But I wanted to show you a tiny feature. The feature is that in the endpoints tool window, you also see the endpoints you call as a client. So you can see already here, you're calling localhost 8080/users a get call inside the endpoints window. You have some filtering possibilities up here. So for example, if you go by type and you only want to see HTTP server endpoints, you'll only see your Spring controllers. If you search for HTTP client, you'll also only see the endpoints you hit with your REST template in that case. And you can also filter by framework, WebSocket client, WebSocket server, MVC controllers, REST operations, test REST template, web test client, a ton of stuff. What I want you to take away from the endpoints window at compile time, not at runtime, you have all the information you need and you can navigate quickly between different endpoints, be it server or be client endpoints. And by the way, because so far what I've been doing is I've been using plain good old Spring MVC. That means I didn't use any Spring Web Flux, no reactive frameworks, no web client, no reactive REST client, so to speak. Everything I'm showing here basically works for both. It works for Spring MVC, for the reactive Web Flux framework, so you don't have to worry about that. But I cannot show too much in one single session. Let's quickly sum up the HTTP support with the controllers. I want you to get into the habit when you write your controllers, have a look at the gutter icons. The gutter icons will let you find out where do you find usages, for example. Where is users being called? You can open up the HTTP client, you can fire up requests, and you have this endpoint tool window, all super useful. And a tiny trick at the end is, by the way, if you're opening up a project and you don't really know, you just have the URL of your REST endpoint, you can do a search all action inside IntelliJ and just search, for example, for /admins. And in the search all window, you can find the URL /admins. It will take you straight to the controller class, which defines the get mapping in this case. Also super useful. Okay, that was REST controllers. And I mentioned at the beginning, I'm also going to show how to work with HTML templates, because I like to work with HTML templates too. And maybe you don't have an SPA application, and you still like to work with Thymeleaf, free marker velocity, and whatnot. What does IntelliJ offer in combination with Spring and Thymeleaf in this case? Now, let me add a template. I'm just going to call it home, right? And there's one important thing, right, that didn't work. I just need to quickly do something that is copy and pasting the namespace declaration of Thymeleaf, right, which you need to do to trigger the Thymeleaf support. We're going to end up we have a thime leaf added to the project. We going to have welcome, for example, and then just a list. So I just want to go through all the users that we basically created that our user service has. And in thime leaf speech, you would end up with the th each block, and we have to find out in a second how this works. But you can already see again, IntelliJ tells you, ooh, that block doesn't look right. So error highlighting already adds compile time. You don't have to wait to boot up the application to find out that this template now is not quite right. I'm going to create a new controller. I'm just going to call the web controller for now. It's a simple controller, not a REST controller. And again, you're going to have a gap mapping. This time, Spring expects a template string that you return from that method. So in here, you need to return the template. You might have noticed by now, I don't even know what my template is called. I just click auto-completion. And IntelliJ is smart enough to scan all the templates you have in your project. Again, might seem a bit anticlimactic. If I just have one template and know exactly what it's called. But if you have many hundreds of templates, it's really cool to just get auto-completion working. So I'm just going to return the homepage template here. And I need to put these users from my user service into the model, into the model of the page. So again, last but not least, let me show you just to please the crowd with the direct field injection. I'm just going to go, well, field injection. Here's my user service. And then maybe I just changed. Let me finish that off. Maybe I just changed my mind. Instead of field injection, I want to go constructor injection. So we're going to go with that. And then, yes, you add the variable called users, which is essentially user service get users, right? That's all you need to do to hook up your thime leaf template with your web controller. Now, back in the template. Interestingly enough, you could have already, you will know by now, is that you get auto-completion. Basic auto-completion features. You can see already, well, there's users in my model. You have a couple of helper functions, thime leaf specific helper functions, but in my model, there's users, list, or list users, right? A list of users. And get auto-completion. When you miss a letter here, you get error highlighting again. IntelliJ tells you you don't have such a variable defined, right? Users. Call the view. I'm going to iterate through that. Another tag. I'm just going to print out the name of every user. And again, I'm just going to go u dot. IntelliJ tells me, hey, you have a name field. You could also call the getter, right? Like so. Again, error highlighting. If you're missing a letter and whatnot, you can navigate back and forth between the model and the template file, right? So keep in mind navigation, two-way navigation, auto-completion, error highlighting. It's always the same story when it comes to those features. And one feature that I like a lot actually is what scares people, especially coming from legacy projects. And that's something that Yuriy also quickly touched upon when he refactored the property name, actually with Shift F6, and then it changed the property key across all these across all the classes. If, for example, you wanted to rename users to users for whatever reason, in the template file, hit Shift F6 or the corresponding Mac shortcut, do a refactoring really, and you'll find the name changed here. Navigating back to my Java class, you can see even the add attribute call changed here. So now I'm having a Z in here as well. So all of that works with the takeaway being trust your IDE. So all these refactorings and IntelliJ IDEA are really powerful. Renamings are really powerful. They work with template languages. They work with JavaScript files, which I'm not showing here. But it's so much more than just doing everything, doing everything manually, really. This is roughly what I wanted to show you regarding the thime leaf support. This also works with, I mentioned, with velocity, with FreeMarker, all these. You can even write JSPs if you want. The support is there. Make use of it, make use of navigation. And so you don't have to, actually, there's one thing I'm missing. I wanted to do one last thing. I wanted to show you in a browser if my page actually is doing something useful. As I see here, I'm missing something, right? So this should hopefully work. Right, let's open up a browser window. I need to pull that over. Localhost 8080. I can see my two users, even with the weird spelling, because I booted up Spring with my staging profile. I'm sorry about that. So that everything worked without me having to first run the application and seeing that my template was basically correct. All right, that was the templating support, HTML support, gutter icons, navigation. Keep that in mind. Now let's have a look at something else. I promised you to talk a bit about Spring Data JDBC, and let's see if I can still squeeze in a couple of things. First, going to show you something else. When you, in IntelliJ, you have these tool windows at the bottom. If you look at the tool windows for Spring, for example, you obviously, when you run your application, then you have the console window nicely highlighted with the banner here, and stuff that you can hide, which I showed you earlier. And you also have an endpoints tab. And if you have Spring's actuator dependency added to the project, which you did at the very beginning, then the actuator data, for example, your health endpoints, and there's a couple of default ones. So for the database, for example, you do queries for the disk space and whatnot. You will see these health endpoints directly under the run tool window, basically. You also get the mappings. That's the REST mappings kind of duplicated to what the endpoint window gives you. Here you can see you have a user's endpoint. That's essentially just if you exclude the library endpoints that the actuator gives you with that icon here, you can see there's actually only just one user endpoint, which corresponds to user controller.users, right? Runtime information, basically. And you can also have a look at the beans and you see in the Spring Boot project, there's a ton of beans. Highlighted in yellow are the ones that come from Spring Boot's auto configuration, or the ones that you basically defined yourself in white with a white background, right? So that is something that you can have a look at if you want to get into the actuator and have pretty solid output. Just have a look at the run window, which you probably, if you've been using IntelliJ with Spring, you probably already know of. Then there's another tool window, which we haven't mentioned at all yet, even though it's a Spring and Spring Boot talk. It is the Spring tool window. So I'm just going to open up the Spring tool window. And again, I get somewhat duplicated information, but I have a couple of tabs, beans again, where I can step through my application and again see, well, in your application, you are referencing an application context XML. Again, I see by default, I see all these classes that come from Spring Boot automatically. I can have a look at my application class, and you can scan through it. There's a ton of information, basically, that you can see. But this is the diagram I wanted to show you at the very beginning. These are the diagrams for now I like to sometimes have a look at, where you can see the application as a user controller, user service, web controller, and whatnot. Essentially, Spring Tool Window, Beans tab, you can step and have a look at all the beans in your Spring application. When you look at the MVC tab shows you your controllers, all the controllers you have defined, so your user controller. It shows you the endpoints that these controllers define, admins/users, for example. Also, you can see the web controller. So if you're just having a look at, hey, what controllers does my Spring application have? What URLs are defined? You can have a look at the Spring tool window and the MVC tab. There's also a data tab, and I think I have the time to pull it off. I'm just going to quickly show you. So in Spring Data, for example, you would write a user repository, which extends from a CRUD repository, for example, a Spring Data specific class. And with Spring Data JDBC, you would actually write methods like, imagine you have a custom select method, something like that. And you're going to write add query, select star from users, something. It doesn't really matter now. Yeah, so the query itself doesn't matter now. Then you can see in the tool window, immediately IntelliJ was smart enough to pick up, hey, you have one user repository defined in your project. It has one method, a custom select method, and that custom select method, which is not inherited. These are only the not inherited methods. Actually, let me show you all the other methods that are being inherited. So you have delete bys, find alls, and whatnot, and you can see the actual query. So again, everything you see in this tool window, Spring beans, MVC-specific beans, Spring Data-specific beans, and that even didn't touch, that was just Spring Data JDBC. If you're working with Spring Data JPA, IntelliJ obviously also has great JPA, Hibernate support. You can run, your queries, your JPA queries from inside IntelliJ, see if they work, see that they compile correctly or compile. You have your database tool window. There's so many different technologies that integrate with Spring, and you'll find that IntelliJ basically has superb integration with all of these tools, frameworks, libraries, adjacent technologies, and whatnot. So you'll have to play around with that for a bit. This brings me, there's unfortunately a lot more that I could show you, but this kind of brings an end to all the features that I've been rushing through now. And I'm just going to try and sum up everything I just showed you with another slide, another photograph at the end that I did, or that I prepared for this talk. So in general, if you thought, well, Marco has been speeding through all these features, I forgot everything, then fear not. What I want you to do is just keep 3 things in mind. First of all, gutter icons. Respect the gutter icons, use the gutter icons. They usually help you with navigation, but also a ton of other features. So make sure that when you navigate between files and in Spring files, use the navigation features. They always work both ways. Beans, dependencies, application contexts, and whatnot. Don't just click around in your file tree and search the right place. Completion, be it the properties completions, be it these auto-wired, from auto-wired to constructor injection, alt-enter, and all that kind of stuff, completions in the HTTP client for URLs and searching for finding the right get method and post method and whatnot. IntelliJ supports a lot of completion in your Spring projects. Third, very important, error highlighting. Do not ignore the error highlighting. Missing beans, wrong URLs, wrong property keys, wrong types and whatnot. There's a ton of error highlighting that IntelliJ can actually already tell you about without you having to boot up the application and find out about the application failure at runtime. And just so we're going to put up the timestamps in the YouTube video for all of these features with the recording. But just a quick summary of what we went through. When you create a new project with IntelliJ, use the integrated Spring Initializer integration. So just create a new Spring project out of IntelliJ. Always remember there's Maven and Gradle support, so you can actually navigate. It's not just an XML file. You can insert stuff into the XML file, navigate between parent files and whatnot. Always find out where does a dependency come from. Gutter icons with bean context navigation, we had that. So you'll find, these gutter icons on the beans, Java classes, XML beans, doesn't really matter. You can navigate through your complete application context. We had a look at different profiles that IntelliJ was smart enough to even do an auto-completion of the profiles it detected in the run window. We had the properties file support where you have these property keys and can just go, inside where's the property being used, what type has the property. We had a look at REST controllers, HTTP clients, endpoints, and whatnot. So really strong, super strong support with the HTTP client to call your Spring Boot REST controllers, or your Spring MVC REST controllers, rather. We had a look at the HTML template support with the example of ThymeLeaf. Same works for FreeMark, Velocity, everything else. And we had a look at these tool windows at the end, just briefly. The Spring tool window, the actuator tool window, where you get the information from the actuator displayed nicely. And in the end, that means you never have to leave your IDE again, and you're just locked into IntelliJ and can do everything you ever wanted to do regarding a Spring project from inside IntelliJ. This is my last slide. Thank you. I hope you learned a thing or two for watching, and let's see if there's any questions left.
That was amazing. Thank you so much. I really like the way that you summarized it into navigation, completion, and error highlighting. I never really thought about it that way, but like I knew it, but I didn't think about it that way. So that was really, really helpful. I also really love the features that you've covered, because often when people are talking to me about Spring, they're also talking about the features inside the IDE, and kind of showing them all tied together is what's really compelling. You did a great job of that. So that's a short summary to say, when we cover the Spring features, because the Java advocates are thinking about covering Spring features in Q2, we might be needing your guidance with some of these things.
Yeah, I'd love to. Yeah. And I also, what you mentioned is, I mean, I prepared the talk, and I also didn't think of it being navigation, completion, error highlighting, and then I just went through all the features, and I thought, hey, this is essentially what it all boils down to. And you don't even have to remember every single feature. You just have to keep that in mind. And the next time you're working on something Spring related, you're thinking, hey, shouldn't there be a better way instead of just clicking around? And I just found that might help people.
It was super, super helpful. Right, we don't have any time for questions because we have to kick you off so we can do the wrap up. But thank you, it was super helpful. I'm sure people can get you on Twitter if they want to ask you some more questions.
Absolutely, ask questions. I'm always available. Twitter, YouTube chat. Ask questions. And sorry for the overtime.
Oh no, it's absolutely fine. You hit the time perfectly. Thank you so much.
Thank you, Trisha. Take care. Bye, folks.
All right, let's bring the rest of the hosts back. We have Helen, we have Dalia, we have Mala. Time for our end of day wrap up. Yes, this is not our team meeting, so I can't spend an hour talking at you about stuff. That's such a shame. Yes, I just wanted to wrap up the day. I have learned so much today, and honestly, I knew I was going to say this, but I didn't know how much I was actually going to learn, like the debugger, the stories that Max and Valentin were telling. It was a really information-full day. What were your favorite bits?
Oh, Mala, you're on mute.
Muted.
We have to have something like that today.
Yes, it has to happen. So I liked all the session, and it's so difficult to pick up either one session. And I have favorite parts from all the sessions. I really liked the session on the UI UX by Olga and Alina. And because it's so difficult to think of how difficult it is to make things simple. Yes, of course, session on Debugger, the one by Tagir, Marco, Trisha. I think Yuriy, every session, I learned so much. I would not keep on talking because I know we have to wrap up.
I think for me, again, I'm struggling to pick one favorite part. I really want to go away and just play with the debugger at the moment. Obviously, just hearing all the presenters, picking up their knowledge, their tips and tricks, having the audience with us and hearing their interactions and what they really like and enjoy about the product as well. I just have to find a way to make some headspace for more knowledge tomorrow. But whilst I have the floor, actually, we are proud to share that IntelliJ IDEA has been voted the favourite IDE for 2020 by the D-Zone audience. So, Trisha, you're going to hop onto that award show in a minute and receive the award, right?
Straight after this, I'm going to hop onto that, receive my award, and then have a lie down.
Fantastic. So, yeah, big well done to IntelliJ IDEA for that one.
Yeah, that's awesome. For me, I really enjoyed learning the inner workings of the IDE because I feel like it helps me use it a little bit better. So all the sessions that I attended were good, but then I didn't attend the morning ones because I was sleeping. So I'll go back to the beginning and start watching those again. And I'm really looking forward to that.
So on behalf of everyone at JetBrains, I thank everyone attending the session. Don't forget to like the video and subscribe to YouTube's IntelliJ IDEA's YouTube channel. And we all hope to see you tomorrow for another set of amazing sessions on your favorite IDE, of course, IntelliJ IDEA. Bye.
Bye.
Bye.